and then you go to design and quick layout. And that's my quick layout. It's my favorite one. You also get to the chart title, all this stuff. I think I'll show this again real quick. You got all these options. You got so many cool things. It's so nice.
Gary! I was just looking for the sports channel, Gary.
Oh, I've got the button going. It's 20-point Tuesdays. We started off with it. I forgot I had the button pressed. I was loading it up. But it is 20-point Tuesday. We'll try to throw out lots of 20 points. I'll have to see what that was like as we came in with the 20-point Tuesdays. I've thought about that, and apparently we now did it. Let me adjust my lighting here. There we go. Go a little. There we go. Oh, no, I can. The light thing's working. Oh, what? That's too bright. Oh, so many settings. So many settings. How is everyone doing this morning? How is everyone doing this morning? You guys doing well, guys and gals? So, Jared, I'm going to miss it too. It's so much fun. Like, this is like our morning TV show. I'm a little tired too. I want to get, Miss Red Bull. Oh man, in pain. I ran 12 miles. I used to run a lot of cross country. So 12 miles, that's a good run. That is a good, powerful run. Haven't slept yet? Oh no. Well, we will have stats class. We'll do the Kahoot later. But get some sleep. Wings, Red Bull, everything good. I was saying, here, let me hop over to the main screen right here. Just so you know, I did put in the syllabus for the other students. So here's my BAS 320 class. They've already missed all their assignments because they're in the past. I've got to reorder stuff, but I've put their, the final. Here it is, June. Wait, I got to fix this up. This is craziness. There it is, knitted assignment. That's their first assignment. I've already given them an assignment. Gosh, the coloring seems quite crazy today on my, I'm really like blue and purple, it looks like. But I've already given them their first assignment. Second time this week. Oh no, I'm sorry. And then I'll show you guys this real quick. We'll open up their syllabus. So here's their syllabus. And then I put right here, encourage each other, chat guideline rules. Oh no. So I told them that Midterm has given us the name Stat Nation, and we're all here for each other. So the chat guidelines, I don't know if you guys have any advice, or like if you guys like are watching this and be like, hey Brian, you should put this in the chat guidelines. But I just want students to know, like, I want you to talk. I want you to have fun. Like, have fun. Yes, seriously. Like, just talk to each other. Like, you guys, like Elizabeth right now and Thomas and everyone, just talking to each other and just, I feel like there's more communication in our online class between students and professor. I think it has when we're supposed to call each other professor. Like, Dr. Mark Collins told me that, but I don't have a PhD. And they're like, still, but everyone's called professor. We voted on it. Faculty Senate did. I'm like, oh, well, then I guess people can call me that. I'm not that, though. I have a title, senior lecturer. We made history. You guys got it. We are Stat Nation, and I like it. I like it a lot. I like people started saying that. We kept it. And then I said, once again, you don't have to use your real name, Professor Beast Mode. I'll take that. I'll do that. 20 points, Jared, right there. Starting off on these 20-point Tuesdays. We got that extra credit button. I never pressed that button, but you got it. So we know what's going on. You guys have been awesome. Once again, thank you. Let me hop back to the other screen. Let's see if I can do the quick transition over here. Oh, look at that. It's like nothing happened. There's ways I can set it up, but I just... craziness. The Nation. Stat Nation. The Nation. We're going to do a Kahoot at 4 p.m. today. 4 p.m. Kahoot today. And it seems like I keep hitting the camera. Pretend you're not seeing this. Oh, I've got it so that it blocks it. Oh, I just have to do that now. Wow. That's so easy. I've got it set up correctly. There's my light behind me. Don't look at the light. Let me push the light a little bit away. You didn't see the light. You're not seeing the magic behind the TV show. That little tiny thing was the light right there. Okay. Is there a lecture tomorrow? There is lecture tomorrow, but we're not doing that much material tomorrow. I'm glad. Christina, you thought it'd be like Zoom, but I'm guessing it was better than that. I'm hoping. Like, you're like, no, this was horrible, Brian. Don't ever do it again. I mean, you could say that, and I'd be like, oh, oof. Guess I won't do it again like this. But for the most part, I've seen really good reactions during the semester and during mini term. Reaction's been really good. So and like Taylor's saying. So definitely just, tell me what you think. Tell me what could improve. And so Thomas, great question. Thomas, let's lead into that. The test can be taken up till, let me tell you what time, because I'm gonna have to send announcements about this. Let me go. Let's start talking about the test a little bit here. And so we will start talking about the test because that is super important. We have the Kahoot at 4. So write down Kahoot at 4. I'll give out some crazy points again during the Kahoot. And my brain is like waking up. I think all of our brains are waking up. And the exam is open till, the exam is only open till 3 p.m. on Thursday. 3 p.m. So that's a change. So let me put in the chat. Exam open till 3 p.m. on Thursday. And the Kahoot is at 4 today. Kahoot at 4 p.m. today. So so the exam is not open all of Thursday. I see, like, I don't know, like I thought about it and then I'm like, okay, we end on Wednesday. So I'll have it open like Thursday morning, Thursday. Does that work for everybody? Does we don't have lecture on Thursday, right? And the exam opens at midnight tonight. Yep. I would once again, I'd probably wait till later. If I was you guys, I'd maybe take it in the morning on Thursday. Is that good for everybody? Yeah, it's 3 p.m. Eastern Standard Time. Yep. So that's why I wanted to put a little bit afternoon. So that way you'd have like the morning to wake up, you know, study or to get it done. And then I'll be finishing up grades probably on Thursday evening. So Thursday evening, like I might be able to get all the grades done because that was kind of my goal is like by Thursday evening, I can get all the grades done, all the extra credit, everything. So it's like almost 48 hours from now, like 2 days and a half from now, boom. And then so Mike, I would make sure to take, you could take it after that, or you could take it tomorrow evening. And that's also why I did it at 3 p.m. So for anyone who has morning classes, you could take it after the morning classes. Does that make sense? And does that work for everybody? How, like, feel free. This is a conversation. Start today? Oh my gosh, Neelan. Feel free to make suggestions or changes. Feel free to make, how about we do 5 p.m.? 5 p.m.? I think 5 p.m. would be good. And then that way people, if they have morning classes, can have a little time to study. If you can of course take it Wednesday night, but how does 5 p.m. sound? And everything does start really quickly. Okay, I'm gonna change it to 5 p.m. here. It has now been changed to 5 p.m. The vote is in. The vote is in. We got 5 p.m. So tell me if there's any issues. Please tell me right away. Streamlabs is back on the job. So what's the deal with the executive summary? Let's talk about that real briefly right here. I've seen some really good executive summaries, and I've seen some. Sorry, I shouldn't laugh like that. Let me look at that. That's like, you guys like, Brian, you're like, you saw me laugh. You're like, he's so mean now. He's so mean, he laughed. I don't know. I saw some executive summaries where I'm like, the executive summary is not quite what we're looking for. The executive summary and the outros. These are big, big things. Okay. Executive summary. One, here's where I see people making the mistakes. And you saw I sent an email about it. And I sent the email because I was reading executive summaries. I was giving people advice on them. And then I want people to do well. So I want everyone to do well. So here we go right here. First off, I can't make that clear enough that this should summarize your entire report. Your executive summary should have every key detail that you'd want someone to know. Now, don't worry. I've seen some that are pretty good that don't have numeric details. But if you're not really quoting the numbers in your report, now don't just copy paste the numbers. Like here is I don't want anyone to feel like I'm picking on them because I know a few people have written things like this. But if you take your confidence intervals and you just put them up at the top of your report, that's not really summarizing. Yeah, and then each part should have a couple sentences and try to put it all into a paragraph. Like try to make it kind of flow. If it doesn't flow perfectly, that's all right. But try to kind of like make it into one big paragraph. And I did, I think I sent out some advice too yesterday that you need to make sure to talk about the shape, center, spread of the histograms because I didn't do that. And I saw a lot of people who sent me their reports not doing that because I didn't do that when I was going through the project. I kind of skipped over that part where it said like describe the distributions, which means talk about the shape, center, spread. So in the executive summary, let me review the previous comment, Camden. You said, so I a couple sentences under each graph. Yeah, like your executive summary can be about 5 to 8 sentences. I might have said 4 to 6, 5 to 8. It's like depending on how strong and how long your sentences are. Project 3 video on the guidelines. Make sure you go to the announcement, Isaac. Let me go grab that announcement. The announcement is project released announcement. Let me go to the project released announcement. So here's where the project is. This is where the project is. Make sure to be using this project. It'd be very bad to use a different project, but this is the project released announcement. So just go to the announcements, go to project released, and this is where the files are at. If you have any confusion or you see a different due date, please contact me immediately. 1 or 2 people have and said, Brian, I don't think I'm doing the right project. And I said, nope, you're not. Go to the project released right here. Does that make sense? Throughout, and then my executive summary is how the business can. Well, no, the executive summary. Let me bring this back over here. The executive summary is literally like your whole report. Let me make this clear. If someone reads your executive summary, they actually don't have to read your report. Does that make sense? What an executive summary is? An executive summary is if someone reads your executive summary, they actually don't have to read your report. You really say, like, well, why would I write a report then? It's a summary of your whole entire report. It has all the key things. It's like an abstract. Exactly, Kyle, you got it right there. Kyle, 20 Point Tuesdays, you got it. Hit that extra credit button. It's still running, apparently. I'm going to do a quick, well, maybe I won't be able to do it in time. All right. So it's like, yep, and then I can look over it, and I'll give some advice. I give quick advice, like I kind of catch the bigger things. So make sure to give those numeric details. So also you should give your suggestions in the executive summary, like what you think your company should be doing. So make sure to have your suggestions in the executive summary. So make sure it's there. I can send you an Excel data file out if you need. So yeah, if you have problems with it, just send it over. And the outro. The outro is best summarized as the where do we go from here? So like collecting data. This is like you say, well, isn't that the same thing as suggestions? And so a lot of people, don't worry, if you use my where do we go from here stuff, that's all right. It's not the end of the world if you do that. The where do we go from here, with some of the data we collected, let's look at the data real quick. I got a quick question about the project. Do we add the screenshots directly into our report? And yes, you add the screenshots directly into the report. Make sure to not have the questions in there. Don't have the questions or any sort of, it should look like a report, like you'd put it on, like the shareholders' desks and be like, here you go, here's my report. And so, Summer 3 project. Sure, I called it that. I forget what I call files. Yep. If we already submitted, when should we expect the grades? They might be graded today. I had the meeting with the grader yesterday. They're an amazing grader. They really tell me if you see anything, you want to know what happened. I told them to put short notes. So they might put like interpretation on it or something, but they're really good. They're really quick. They're very fair. I told them where to be fair. Well, I told them where to be nice, not where to be fair. I told them to be fair at all times. But I told them where to take off more points and other, like, here's the areas I want you to be harsh on. And I did say executive summaries I want to be very, very well written. So your executive summary should, once again, let's just look at it again. It should summarize the entire report. It should give numeric details. It should give your suggestions. You should literally think, I could give someone this executive summary and they don't have to read my report anymore. So you don't, and it's all right, a few people have said this, you don't want to say things like, I made bar charts, histograms, because yes, you did that, but what did you learn from it? What was the numeric details? Like, what did you learn about pizza toppings? What did you learn about sauce? What did you learn about delivery time if you analyze those things? Then what suggestions do you have to the company? And what was the average sorry, Kyle, repeat that again. I'm sorry, I don't understand the question. I don't understand. What was I going to talk about this? This is the file, and I forgot what I was going to do with it. I think, how many points do we give submit last night? 7 points. 7 points. So unless you think you have major errors, I wouldn't resubmit. But 7 points is a big boost right there. Also, some people I saw did the pivot chart, and you get 1 point if you basically do it, Make sure you do a pivot chart, not a pivot table. You get 2 points if it looks good. And then I told them 3 points if the pivot chart is something they would think that a group member, like they would be happy to display it. So that's the grading of the pivot chart right there. It's bonus. You get 1 point if you just pretty much attempt one. Don't just, you could kind of take advantage of that. You get 2 points if you turn in something that's like decent, and you get 3 points if they would consider using it for their projects. Like they'd be like, oh, this looks good enough that I'd use it. Do you remember what the average on the project was last semester? It's usually in the mid 90s, usually pretty good. Yeah, you rarely are there bad grades on the project. Like if you turned it in last night, and even if you had some errors, you probably made an A. Like someone could make like a B, but you'd have to have like bad interpretations. You'd have to not do parts of it. It's very hard to do very bad on the project. How much I think it's 5%. 5% of your grade is the project. So it's a good kind of, it can move the grade around a little bit, but it's definitely something that you don't want to yeah. And so don't worry. The project grades are usually pretty good. Just take it seriously. Once again, exam is 25%. So yep, exam's going to be a big portion. So once again, I was planning on turning it in last night, but I got, and ordered pizza. You start the project and it's talking about pizza and you're like, you know what? I could use a pizza. But don't worry, Camden. You know what you can do for extra credit? You can do the pivot chart stuff, and I've got the pivot chart videos. So make a good pivot chart. If you follow through the pivot chart playlist, which is only like 15 minutes of videos, you will see how to make a good pivot chart. So just follow through that. It might take you like 30 minutes to make a really good pivot chart. It's just review those concepts. So make a really good pivot chart, and you can get 3 points, or you'll probably at least get 2 because it'll look good. But you can get 2 or 3 points as long as you make a pretty good one. 3 for grade, 2 for, it looks okay. If I submitted the project last night, we got the pivot table. In pivot chart, remember pivot chart. So you'll only get like 1 if you do a pivot table. We want to make sure you do a good looking pivot chart. Could I just submit the pivot table? You can't. Email me. It's got to be here. I'll do this. Ben, you can email me it. But it's got to be, I'll give you 1 point, and you have to say, like, email me with, like, stat201, help me put it, like, but you have to, stat201 mini, and initials, and then pivot chart addition. I will allow you to submit, and I will allow you to get up to 2 points. You get 1 point if you submit a pivot chart, and 2 points if I'm like, I would use this. So you got to be careful. So you can submit via this, and I'll add it on. And you have to remind me, double check, because I'll have to go in and manually add these. So I don't want you to resubmit because that'll cause problems with the submission dates. But it's a point deduction on it because it's day late. So I'll allow you to do that, and email me with that. And yeah, and so make sure it's a pivot chart, and then follow the guidelines. And here's the way you'll know it's a good pivot chart. Is if you take a screenshot of it. You kill me, Coleman. 20 points, Coleman and Ben. If you take a screenshot of it and you would display that in a board meeting, like if you would display that in front of a class. So exactly. Yeah, no, I always want to, Jared, 20 points. I always want to give you guys opportunities. I always want to be like, yes, do more work, because that's what we're here to do. We're here to do work. We're here to learn. So there should always be opportunities, and we just kind of, change it around as we go. Let's head back to lecture. Okay, that was a really productive 20 minutes. We know what's going on with the test, the Kahoot, the project. Man, woo! Sometimes I see in the class starts to people start to come in like 20 minutes in, and I'm like, oh, you're missing all the info on what we're doing, what's going on with the world today. They're like, I'll just watch the lecture. No, it's so mean. All I do is look at analytics. But what are we? We're a stats nation. Stats nation, all those points. You guys have done so well on all these points. I know, right? So, Kyle and Thomas, 20 points. So, here we go. It is time for lecture. It's time for lecture. Let's do this. Let's add in that green pen. Green pen time. You know what this means. That means I just made an edit in the video, and let's start this up. Why do I have so little Streamlab points? The world may never know. I don't get points. Because I don't talk. Interpreting p-values. The chapters on the test tomorrow start with chapter 14 all the way up till this chapter. Oh, no, not up to this chapter. Up to the chapters we'll be covering tomorrow. Well, we'll continue through. It's so weird to have another class tomorrow. I'm not active enough. You're right. So here we are with interpreting p-values. So when we interpret the p-values, and there is still a chapter after this. This is not the end. Starts with chapter 14. So look at where chapter 14 is. All the material up through that. Up till, let me be very clear. Let me restart. I just want to make sure people aren't confused. The chapters on the test tomorrow are 14, 15, 16, which is here, 17, and business analytics. Business, there we go. So these are the which that's pretty small. That's like not that much. You've got confidence intervals and distribution of the sample mean. You've got hypothesis testing, moron tests, 2 sample t-test, and then business analytics. And so we will be covering 17 today. We will be covering business analytics tomorrow. If you literally show up for business analytics, you should get all the points on it. You should get all the points on business analytics. Yeah, feeling decent. Yeah, I agree. And once again, I've been stressing how important tests and confidence intervals are. So if you understand tests and confidence intervals, you should be pretty good. So I just want to be very clear on that because I misspoke and I was like, up to this one, I was like, oh no, I don't want anyone emailing me and be like, you said it was up to chapter 16. I'll be like, misspoke. I didn't study chapter 17. Yeah, I realize how bad misspeaking can be. And then I'm like, it got to be very clear. And the Kahoot will help. Yep, I agree. Where could we review? Claire, great question right there, Claire. I sent out the videos I have go over testing. Confidence intervals and tests are very similar. Did anyone watch the videos that I sent out saying these are really good review videos? Because they go over the conditions, they go over the different types of tests. And so you do have a homework and quiz, but it's not on the test, Needy. Yep. And watch those videos. They go over like a lot of stuff. They go over a lot of it. So I would sit down, watch those videos. I would just try to, the good news is probably your classes that start on Thursday are not going to have that much, like it's not going to be all the way up to like, we're driving 60 miles per hour down the highway, obeying the speed limit. But your classes on Thursday, luckily, I'm not saying don't take them seriously, but probably Thursday morning is going to be a nicer, like a reboot to where you're like, okay, catch my breath. Okay, back to like starting up a class, not at the very end of a class. So I understand this is like the very end, the very tough part. Are we doing? Yep, we'll definitely do some homeworks and quizzes. I did send them an email. Yep. And so let me here, I'll send you the list here again. I'll put it in the chat for those watching the video right now. We go to announcements. It was in like the advice announcement. Project advice, project help, preparing for exam 3 advice. It's like, wait, which announcement did you send this out in, Brian? So let me make sure we got this here. So this is the preparing for exam 3 advice, and there's the playlist. So go ahead and check that out. And there you go. We got it. Okay, let's do this. Let's get into lecture right here. It is time to do lecture. Interpreting p-values. So you should have something that you've heard me say. 1,000 points for the first person who can tell me my interpretation of a p-value. Pause right here and try to interpret a p-value yourself if you can't. Who can tell me? I'm going to give 100 points if someone does a good job, but I want to give 1,000 points to someone. I want to go crazy. Well, that's what statistical significant means. Kyle, 100 points right there. That's what statistically significant means. Less than 0.05. And 0.05 is usually assumed to be alpha. So Kyle's brought up some amazing points right here that alpha is about 0.05. And when it's less than alpha, so when p-value is less than alpha, we call that statistically significant. So what is statistically significant? If it's low, reject the null. If it's high, just let it fly. You're right. That's Hannah gets 100 points right there. Hannah, you're right. If it's low, reject the null. If it's high, just let it fly. Maya's right. 100 points to Maya. P-value shows if something is statistically significant or not. Wait, Camden, I'm still giving you 100 points, but we never say the bad A word. We never say the bad A word. I'll try to send some video. I don't know if I have any on confidence intervals specifically, but I might make one. And then also the review goes over it. We reject or not reject. You got it, Camden. No one has said my specific interpretation of a p-value for the 1,000 points. It's the thing I say really quickly. It's the thing I always say really quickly, and then I slow it down. It's when I draw out. William, I'm giving you 500 points. William I like William's the best so far. So when I draw out this and I say, I'm Mm-hmm. Mm-hmm. Can you hear it? Can you hear it? I kind of shaded over that one there. Who's got? Kind of Neeland. You're getting really close. Neeland's really close. Neeland gets 500 too. Okay. So I split up the points between I know, right? I split up the points between Neeland and William. You guys got really close right there. It's the probability of our results or results more extreme than it happening by random chance variation given that the null is true. The given is very, very important right there because we assume the null 20 points here. We assume the null is true. We assume that the null is true, and then we look at, well, then how likely were our results or results more extreme happening by random chance variation given that the null is true? So the p-value is the conditional probability, which means given, the whole conditional thing right here is like given this is true, of observing our results or results more extreme given that the null is true. Yes. Let's go right here. Sarah and Maya, I'm giving you both 500 points. Great job. We'll split up 1,000 between you both. I don't know. I'm going to slow down the points. I went crazy right there. I want to see if people could get it. But I think understanding why p-values are what they are is very important because when you think about a p-value, it's telling you what you saw was either likely or unlikely given your first assumption is true. So what's a very important thing for 100 points? What's a very important thing to know whenever talking about a p-value? And this changes. What is a very important thing to know when you start with a p-value? What's a very important thing to know? It's on the screen right there in green. What's a very important thing to know to talk about? It's in green. The null, Jared, 100 points right there. The null we should know because the null is like what we're starting out believing. We're saying, what's the probability of our results or results more extreme happening if the null is true or given the null is true? Like given means if the null is true. So we need to know what the null is because then when we look at our p-value, we could say, well, we could just continue to believe the null, but our p-value was low, telling us that our null was unlikely. Our results were unlikely, excuse me. Our results were unlikely given the null is true. So that's when we reject the null. Big p-values, what do big p-values mean? And a lot of people saw this on their project. If you have a big p-value, you definitely don't reject the null. Like when you get a p-value, which many people had, if you have a p-value equal to 1, you do not reject the null. That means you have no evidence for your alternative. So do not reject the null. But when you have a p-value of 0, that means you have tons of evidence for your alternative. And you really never get one of 0. It just gets very close to. So there we got it. Kyle, 20 points right there. We either reject or do not reject. And do not reject means fail to reject. Exactly. It's the same thing. It's just who in this world today says, I failed to reject the null? Only stats people. I like to say do not reject. And once again, that does not mean accept. It just means I do not reject it. Alpha levels and critical values, you should know instantaneously that alpha looks like this. We do. 20 points, Camden. So the alpha level is alpha right there. It's just that symbol and the critical values. So we can choose different alpha levels. You can choose an alpha level of 0.05, 0.01, 0.10. And so which of these alpha levels would be easier to reject for? Oh, let's do it. Let's do a vote. Streamlabs vote. You ready? Get ready to vote. 1 or 20. Which of these would be easier to reject for? Get ready for Streamlabs vote. So I'm going to pull up the polls here. It'll be here in a second. I'm going to edit the poll. I was trying to make it so I could run polls instantaneously. 20 is an option. And which of these is easier to reject for? Or 1? And I didn't add the decimals, so you can just do it nice and easy. 20 or 1. Which of those is easier to reject for? Maybe. Which of those is easier to reject for? Remember to do your vote. Which of those is it easier to reject for? Let's see. We'll see. I don't want to sway the class. Let's repeat. Let's do it. Let's add in a thing right here. Wonder if you can change your vote. When the p-value is lower than alpha, reject the null. There's a hint. Did everyone hear that hint? We're looking which of these is it easier to reject for. Some people might change their vote. When the p-value is lower than alpha, reject the null. and these are the alpha levels. We're saying these are your alpha levels. So when your p-value is lower than alpha, reject the null. So which of these is it easier to reject for? Let's see. Change your votes if you want. So when the p-value is lower than alpha, reject the null. When the p-value is high, so which of these is it easier? I should stop right there. Think of them as limbo bars. So we got this limbo bar and this limbo bar. This limbo bar is at 0.02, 0.20. That looks horrible. Let me redo that. And this one is here. When the p-value is lower than alpha, reject the null. So which of these limbo bars is it easier for the p-value to go under? And the answer is, I think I tricked too many people. No. Get 100 points if you said 1. The answer is 1. Does that make sense? I tricked a lot of people. Because your p-value has to be lower than it. Which of these is it easier for the p-value to be lower than? Okay. You changed mine? Oh, no. Wait, complete poll. I tricked a lot. Don't worry. If you got it wrong, you were in the majority. You were in a Strom. Oh, no. I am so sorry. I should stop talking. The higher the alpha is, the easier it is to reject. Take that note. Here's what you should write down. Higher alpha, easier to reject. Does that make sense? And the question was, which of these alpha levels is it easier to reject for? And it's easier to reject when alpha is higher because the p-value has to be lower than it. So imagine we set an alpha. If I set an alpha of this, what percent of the time? It was 20, yep. What percent of the time would I reject with this alpha level right here? What percent of the time would I reject due to random chance? Due to random chance, I would reject this percent of the time. All the time, yep. And then an alpha level of 0.01 says you only reject 1% of the time due to random chance. Or 99.999, Claire, 100 points right there, you're right. Like, exactly. Well, you said the answer was 1. I might have misspoke. Sorry, Hannah, if I misspoke. The answer is 20. Sorry. No, sorry. You did say it was 1. Oh, no. Yeah, which of these is it easier to reject for? I hope I didn't switch the question midstream. Which of these is it easier to reject for? I might have misspoke. Sorry. It seems like I did. 2 people have said it. I think so too. Thank you guys. It does seem like it. It is easier to reject for this one. It's easier to reject because the p-value has to be lower than it. I might have changed it. I'm very sorry. Ignore that last part of the lecture. So when the alpha level's higher, it is easier to reject. A lot of people are confirming. Brian definitely misspoke. That is strong evidence. We have evidence. Okay, wait. Look at this. What is the null hypothesis? The null hypothesis is did not misspeak. And then we'll just put misspeak right here because I can't. I'm running out of room. And then the alternative is misspoke. So what is Brian doing right now since multiple students are saying Brian misspoke? What is Brian doing? I am rejecting the null. You're right. I am rejecting the null. You guys have given me sufficient evidence to reject the null. Was one student, whoever said it first, was one student enough evidence? At that point, I was like, maybe. And then the second student said it, and I was like, uh-oh, 2 students are saying it. And then like 3 or 4 were saying it. And I was like, okay, I have strong evidence here. I reject the null that I did not misspeak. I have strong evidence that I have misspoken. So we kind of do this in our own heads if you think about how it works. Now, I could have made a type 2 error. Wait. I could have made a type 1 error because in type 1, the null is true, and I reject the true null. So maybe I made a type 1 error here, but I think I haven't. Seems like I did misspeak. Good call. Using that for other things we already know or have reviewed. So we've got here statistical significance. Statistical significance is literally... 20 points. 20 points, Neelan. That's a and Hannah gets 100 from that since you misquoted her. Unless that was an actual quote. So statistically significant means that the p-value is lower than alpha. Does everyone have that down? Statistically significant means that the p-value is lower than alpha. So think about this. When we make alpha higher, it's easier for something to be statistically significant. Does everyone understand that? Statistically significant just means the p-value is lower than alpha. So all we have to do is make alpha higher. Now, it's kind of playing a game. P-value is, yep, that's what statistically significant means, is that the p-value is lower than alpha. Now, usually alpha is assumed to be 0.05. That's what alpha, yep, like a limbo bar. Just makes it easier to go into a limbo bar. Kyle, you got it right there. It makes it easier if you raise the threshold, but you're playing a game if you do that. Usually statisticians don't do that. These are the common alpha levels. And what does statistically significant means? Unlikely by random chance, lower than alpha. And alpha is the threshold by which we call unlikely. Why is it 0.05 to begin with? Stats people came together and said 0.05 is cool. And they were like, oh yeah, we like 0.05. 0.05 is a 1 in 20 chance. It's just kind of what is decided as kind of unlikely. And then you could make it harder to reject the null. This would be harder. Or you could make it easier to reject the null. It's pretty arbitrary, and it's just kind of like, people were like, yeah, that sounds good. And then enough people said it sounded good, and then it became the thing we said that sounds good. So it's what's generally accepted. It's like everyone created this standard of the 0.05 standard, and then it's what's generally used now. There's no, it has to be this. So you could make it harder to reject the null and find what you call statistical significance, or you could make it easier. Now, if you want to do good research, do you think you'd make it harder or easier? If you want to do good research, like, would you want to make it harder to find results or easier? Now, I know it sounds crazy because you're like, well, I want to find results. Exactly. It'd probably make it harder. So a lot of people might go to a 0.01 standard, and it just depends on, like, to what degree they're saying they have evidence. And we'll be talking about errors in just a moment here, because if you reject the null and you do it incorrectly, you've made a type 1 error. More on that in a moment. So when you do a test and try to do this in your project, quote the p-value. The p-value lets us know exactly what you found. So, if someone says they reject at the 0.05 level, all I know is what? If someone says I reject at the 0.05 level, all I know is what? What would I know? That's a decent test question. Like, I'd like it to be a written response if I could. Someone says I reject it at the 0.05 level. All I know is this. It's less than 0.05. That's all I know. I don't know if they got 0.00001. So, like, I don't know if they got this. I don't know if they got this. I don't know if they got this. And if you see, these get more and more significant, and these would be their p-values. All of those are less than alpha, and all I know is that their p-value, if they reject at the 0.05 level, all I know is that their p-value was less than alpha, which was 0.05, because they rejected at that level. Once again, alpha is just the level at which you reject at. You're saying, here's my limbo bar, and if I go below this limbo bar, I can reject. If you put the limbo bar up higher, it's easier to reject, but that's kind of playing a game. Like, you don't want to make your limbo bar too high. Imagine if you went to a party and the limbo bar was set at 7 feet. And they're like, we're going to play limbo. And so, like, they have a 7-foot tall limbo bar. So they have a 7-foot tall limbo bar. What would you think? You'd be like, well, everyone can get under this limbo bar. Lame party, going home, bullying Shaq. 20 points, Sarah and Jared right there. Everybody's a winner except for Shaq. and yeah, that sounds lit. Oh, man. William, 20 points right there. So, so everyone but the basketball players are going to have a fun time at this party. They can just duck under it. They can just move their head under it. You'll finally win a limbo. So here we go. Practical versus statistical significance. This is a pretty easy part right here. I think it's very easy to understand what's going on right here. Here's the biggest note you need to know for this. Statistical significance just means p-value less than alpha. Statistical significance, and I know at least one person is taking 320. 320 starts up on Thursday. So this will also be used in 320. All you need to know for statistical significance is that it's yes, no. Like, more than that, but that's all you respond to it with. Something is statistically significant or it is not statistically significant. It's that easy. And all we do is we look at the p-value. Here, try one on for size here. You ready? P-value is equal to 0.06. Alpha is equal to 0.10. Be careful. That's not your usual alpha. Is that p-value statistically significant, yes or no? And then look at your guideline right here. Yep. That's it. It is. It is. And why is it statistically significant? Because the p-value is less than alpha. So this is definitely 20 points, all those people, everyone answering. This is statistically significant because, no, don't worry. You get 100 points, Josh. You were seeing if I was watching the chat. Josh gets 100. So it is less than alpha. And you'll remember, you'll be like, oh, it's got to be less than alpha. That's how we do it. So I can trick you a little bit because I can change it. I can go to the usual alpha, or I'll change it. This won't be the usual alpha. Statistically significant, yes or no? Now, is it statistically significant? You can kind of use that language, but usually people just say, is it statistically significant, yes or no? And you could say it's significant at lower alpha levels. Someone might say that, like, it's significant at a lower alpha level. And once again, we usually just quote the p-value if we're going to give it. And everyone's saying this is not statistically significant, which is correct. But then usually if you have something really small for a p-value, you could say it was significant at the 0.00001 level. That's how people usually talk about it. Like, they might say that. And then I usually just quote the p-value. Like, the p-value was this. It'll be in like a table of research usually. Someone will just like, that's the p-value. Like, it'll just be given so the reader can see it. So they can make their own decision, which is, they'll be like, oh, that's really super significant. Wow. And then we oftentimes talk about effect size coming up later here. So when you talk about practical significance, we want to talk about, excuse me, we want to talk about effect size a lot of times. And effect size is the difference between the hypothesized value and the parameter that we actually, the actual truth. So you could think of this right here as what we hypothesize to be true and its actual value. So to put this, so p-value has to be less than alpha. Yep, you got it, Camden. 20 points, Camden. Yep, that's how statistical significance works. So I want you to think about effect size here for a moment. With effect size, I'm going to bring out two people here. I'm going to call up my brother. Here's Darren. And I'm going to call up my friend, LeBron. He's got to be taller. He's got to be taller. There's LeBron. That's about right. Darren's 6'3". LeBron, what is it? How tall is LeBron? I haven't asked LeBron how tall he is lately. LeBron's probably like 6'9". He's not like one of the tallest people in the NBA. Here's Brian. Brian Darren, same height. 6'8", 6'9". That's about right. It's about to scale. I mean, he's not that much taller than us. I've never seen someone draw. I'm bad at drawing. I don't know. He's 6'9". Dude, there you go. I draw him back. So we're gonna play basketball. Now I want you to think about this. I know we have no net. I'm sorry. We're badly drawing stick figures. So let's compare Brian and Darren. Now, if someone does not know Brian and Darren, then with this right here, is there a large effect size between Brian's ability to play basketball and Darren's ability? Brian and Darren grew up together. Brian and Darren played basketball together growing up. What do you think the effect size is? Small or large? What would be the effect size between Brian and Darren? And the effect size is the difference between the null, which is probably that we're the same, and then the truth. So you have to think, what is the truth between Brian and Darren and their abilities? Well, it might be pretty small. It's larger than that. Darren's better than me by a good bit. But then let's compare Brian and LeBron. So what would be the null for Brian and LeBron? It'd be that they're the same. I know you're like, that's ridiculous. Well, it's because you know the truth. You know that Brian is way worse than LeBron. People have been like, Brian's better than LeBron. I'm like, yeah, no way. You could watch 2 seconds of that game and I'd get dunked on 5 times. It'd be impossible. He would break the laws of reality to beat me in ways that no one had ever thought possible. I know he'd post. I haven't heard that term in so long. Matthew, 20 points. I love that. That is. I love that term. I haven't heard that in so long. You would just dunk all over me. It would be sad. But so what you're seeing right there is as you watch this game in your head, you're seeing the large effect size. Well, then I'd miss my free throws. I actually am pretty good at fouling. That's about the only one thing. You guys are killing me. When we were growing up, very quick story. When we were growing up, my brother was did they call him Larry Bird? They'd call him Larry Bird because my brother could hit 3-pointers all the time, and then they would call me. Why can't I think of his name? The guy who would color his hair all the time. I can see his face in my head. He was on the Bulls with Jordan. Dennis Rodman. Yeah, Dennis Rodman. Yeah, Dennis Rodman. They'd call me Dennis Rodman. So, because I wouldn't on purpose do it, but I'd always be fouling people. Like I'd always go up and I would just like hit people with my elbow. So it'd be under the hoop, and I would just like, it's bad. I was bad. Yeah, there's the other nicknames for him. So, and he is so crazy. And it like I don't think I would take offense to that. If he's yeah. Oh yeah, people would stay out of the paint because they're like, I don't want to get elbowed by Brian. And then they would be like, Brian, you got fouled out of the game. I'd be like, I did? And they'd be like, yeah, he elbowed people like 5. I'm like, I'm sorry. I think it's like being like 15 or 16 and being 6'3" and not being used to it. And like just being like, I'm lanky and I don't understand I don't have spatial recognition of where my elbows are at. So yeah, I was not on purpose. I didn't have spatial recognition. I still don't, but this is the way it goes. So what you're seeing here is the effect size. You're seeing the effect size. Yeah, you know what I'm talking about. It's like you're like, I don't know where my elbows are at. I'm sorry. I didn't mean to elbow you in the face. I really didn't. I'd feel bad. I'd elbow someone, they'd be like, oh dude. And I'd be like, I'm sorry. They'd be like, come on, man. And I'd be like, at the second time, they'd be like, come on. I'd be like, I'm really sorry. I didn't mean to. They'd be like, you can't play. And I'd be like, I know. Teams would pick me just so I wouldn't elbow them. Like, I'm done. I didn't mean to. Okay. But I hope you, no, I can't play basketball. I can run. I could run back then, but I did track, cross country, swimming, wrestling. I was bad at basketball. Thank you, Matthew. So my brother and I have a very small we have a very small effect size. Going back to lecture right here, we had our fun. So my brother and I had a very small effect size because if you assume that we're the same in our basketball abilities, the difference is smaller. But Brian and LeBron have a very large effect size. Like you could do this with other stuff right here. You could do this. Let's try this. Ready? We're gonna switch topics here. Everyone's loving my horrible basketball career. You ever see those videos on YouTube where it's like home chef versus amateur chef versus professional chef? So let's go here. We've got home chef 1. We've got home chef 2. We've got, and then we've got professional chef. So where would the effect size be smallest between, like, if we asked them to make like an omelet? And then we got Gordon Ramsay over here doing his thing. I don't know. He might not be the best. Where would we see a large, small effect sizes would probably be between these two groups right here. Like this is where the effect size would probably be very small. Like if you tried the differences in their omelets. But then if you were to compare between like these people right here, and this might be like the largest effect size right here between like a home chef and Gordon Ramsay. We're just putting Gordon Ramsay on a pedestal right there. So when you're talking about the effect size, you would assume under the null that I know I'm hungry too, and like I know the person who makes the best omelets in the world. Need to get some portobellos and some goat cheese. Portobello goat cheese bacon omelet. Do it. So with this right here, your differences between the omelets, you would assume, Skylar's lucky, you would assume that the omelets are equal. You would assume that the omelets are perfectly equal, and then the difference that you actually observe is probably an estimate of the truth. Goat cheese is really good. And so this would be a large effect size right here. So you could just think about this in common terms. The null, which is what we hypothesize to be the difference, is oftentimes 0 between two groups. And then the stronger the difference is, I think we broke Claire. It's goat cheese. I love goat cheese too. The actual differences right here are pretty much what we're kind of estimating them to be. Like these are the actual differences right here. Okay. So we understand what effect size is, right? Who feels like they know what an effect size is? Just decide about, there we go. That's too funny, Claire. Awesome. Say hey to your cat for us. Say hey to your cat for us. Okay. So now we have errors. You ready? Here's what we got to know. We have a type 1 error. A type 1 error. Does everyone see this? You probably know this if you reviewed last class with us. In a type 1 error, 1,000 points first person. A type 1 error, the null is what? First person, 1,000 points. We're going crazy here. Who's going to get it? True. It's I'm splitting it up between 3 people. 400 points each. Neeland, Sophia, and Kyle. So Sophia was like, true. So good job. We got it. So there's your 300 points each. Splitting it up. You ready? In a type 1, microphone's in the way. The null is true. Does everyone see the type 1? The null is true. Type 1, the null is true. Type 1, the null is true. Aw. Type 1, the null is true. Now, if the null is true, what would be a bad idea to do the null? If the null is true, it'd be a bad idea. People were saying it earlier. It'd be a bad idea to do what to the null? In a type 1, the null is true. It'd be like, if we assume Brian, you got it, it'd be a bad idea to reject it. We could assume that... I'm going to try to draw this one in the reverse. Oh, I'm so not used to it. That's the reverse stick figure. Okay, that's got to be Brian because he's shorter. He's standing on a box right here. Brian, you're not as tall as LeBron. You're cheating. So it's just visual representation. Brian has a big head about himself. So in a type 1 error, if we assume that Brian and LeBron, what's up, Tyler? If we assume that Brian and LeBron are the same, what would be a type 1 error? Ooh, who knows this? This is tricky. In a type 1 error, what would be a type 1 error here? Slow it down. Remember, in a type 1, the null is true. And the alternative right here, and I'll say something. Yesterday, when I was doing notation, I forgot to change this to an A. I copy-pasted. Well, not the same height. We're saying same basketball ability. Sorry. I put me on a box just because I drew myself a little bit odd there. So we're saying we have the same basketball abilities. What would be a type 1 error in this instance? In a type 1, and the null is true, but we reject it. In a type 1, the null is true, but we reject it. So what would that mean? Now, slow it down. You have to be like, okay, this is true then. Look at the null and say, that is true. Like, be like, oh, this is true. That you have the same abilities, but reject it and say that the LeBron is better. Yeah, Kyle, amazing job, Kyle. You're getting some 300 points right there. Kyle phrased it so perfectly. I read and I was like, yeah, that's the perfect answer. So in a type 1, it would be that we have the same ability. It's true that we are the same. In a type 1, the null is true. Just look at that null right there and be like, that is true. Does that make sense? You look at it and say, it is true that they have the same ability, but we rejected the null and we said that they have different abilities. So you watch me and LeBron playing, you're like, oh, LeBron is better, but you were wrong. We're actually the same. But what is a type 2? What is a type 2? Crack me up, Isaac, 20 points. What is a type 2 error? In a type 2 error, the null is false. Does everyone see the type 2? You can do, if I see some people in the video, you could like, if you see a question on the test like this, and I see you in the video do like this, I know you know what's going on, because I do look at the videos every once in a while, make sure no cheating. But you go like this, type 2, the null is false, and we fail to reject it. Does everyone see right here where we have the 2Fs? In type 2, the null is false, and we fail to reject it. So you've got your type 2, you got the null is false, and we fail to reject it. So right here. And so Brian and LeBron do not have the same abilities, but we fail to reject it. So I'd take this Skylar, 300 points. Yep. Don't talk too loud. I haven't found anyone for cheating yet. So if you're doing that and you haven't said anything, you're fine. So in a type 2, the null is false, and we fail to reject it. And that means that it is false that LeBron and Brian have the same abilities. They're actually different. We've just called it different. LeBron is better. So it is false that Brian and LeBron are the same, but we continue to believe that. So we're going to think that Brian and LeBron are the same when they're actually different. I'm going to go, I'm kidding. I'm going to go tell your Kevin teacher. We can't get you guys in trouble for that. I mean, it's also college, so it's like, you can say. You guys are cracking me up so much today. Okay. So there are things that control the type 1 and type 2 error. Type 1's the easiest, though. There's only one thing that controls type 1 error. And guess what? We're going to hop over to the main screen. Extra credit, everybody. Hunter, 20 points. The screen said I had to give extra credit. I must oblige the screen. So here's how you remember these things right here. We start by counting. So we go 1, 2. Then we do the letters A, B. Then we do the sides of a battery. I think there's a question in the tell me see. Wait, the professor. You guys are cracking me up. What are the sides of a battery? What are the sides of a battery? What are the sides of a battery? Like the sides. What are the sides of a battery? Positive and negative. I've never heard anyone say it. Morgan, 100 points right there. I've never heard anyone say it another way. Everyone says positive and negative. I've never heard. Oh, is it called terminal? I think it might be. So positive and negative. So when you look at this right here, please take note of this. Does everyone see this pattern right here? This pattern right here. Now I'm going to slightly change this. What controls a type 1 error? What controls a type 1 error? Your what level? What controls a type 1 error? Your alpha, Josh, 20 points right there, and Kyle, the alpha level. Your alpha level, whatever you pick for alpha, controls the type 1 error. So whatever you pick for alpha. So if you increase, I just kind of went crazy. A lot of people have reached like the 3,000 threshold, and good job. So just send me those points. Today, there's no limit. Today, there's no limit. So I've kind of went crazy today. I want a bunch of people to get max extra credit. Oh, and I got to mention something else later on. I will. So you can see right here, we got the alpha level, and then what controls the type 2 beta level. Now, alpha level is literally just at what point you reject. Alpha level is at what point you reject, but beta is more complicated. The three things that control beta, which beta is your type 2 error. Alpha is your type 1 error. Does that make sense to everybody? Alpha is literally your type 1 error. Beta is literally your type 2 error. Does that make sense to everybody? Alpha is literally your type 1 error. Beta is literally your type 2 error. You guys thought you'd never get to like those crazy points, but you did it. You did it. Sarah and Kyle and Kate and Devin and Kyle, 20 points each right there. So we know that these are type 1 and type 2 error. It's so easy to change your type 1 error. It's only alpha. It's literally Camden. It's literally a type 1 error. Like, people are like, well, how do I know what my type 1 error is? What's your alpha? That's your type 1 error. Beta is more complicated. Beta has these three components that control your type 2 error. You have sample size, you have effect size, and you have alpha. If any of these go up, beta goes down. So put like a, change colors here. If any of these go up, beta goes down. Or if any of them go down, beta goes up. So think about that. If we have a smaller sample size, we'd be more likely to make what? If we have a smaller sample size, we'd be more likely to make a what? If you have a smaller sample size. Alpha does affect beta, yep. Effect size. Sorry, I abbreviated effect size. Good question, Hannah, 20 points. So if we have a smaller sample size, we'd be more likely to make a type 2 error. So think about this. Let's go to Brian and LeBron again. A smaller sample size with Brian and LeBron would be if you only watched Brian and LeBron, let's say for 10 seconds. If you watched Brian and LeBron for 10 seconds, you might be more likely to say Brian and LeBron are the what? If you watch Brian and LeBron for 10 seconds, you might be more likely to say, although preposterous, you might be more likely to say Brian and LeBron are the what? The same, which is a type 2 error. If you watch Brian and LeBron play for 10 minutes as though he would humor me, then you would definitely reject the null. Does everyone see what am I changing by changing how long we watch the game? By changing how long we watch the game, Brian is changing the what? Brian is changing your sample size. And if you take a larger sample, you'd be less likely to make a type 2 error. Larger sample, less likely to make a type 2 error. The number of observations, exactly. Does everyone understand that? The longer you watch the game, the larger your sample size, the less likely a type 2 error. If you watch the game for a very short period of time, you might make a type 2 error. You don't have that much data to go off of. Does that make sense? So if you watch the game for a long period of time, you'd be less likely to make a type 2 error. Yes, that's what I like. That it's like, hopefully those examples like, oh, the larger my sample, the less likely I am to not find results. A type 2 error is a false negative, which basically means you did not find results. Larger samples, less likely to make a type 2 error. 20 points, 100. Great notes in the chat. Makes sense. So the effect size, think about this. When are you more likely to say that Brian is the same as someone else? Brian versus Darren or Brian versus LeBron? When are you more likely to say that Brian is the same as someone else? Brian versus Darren or Brian versus LeBron? Darren. And think about this. That's because the effect size is smaller and you're more likely to make a type 2 error. Now, if we take LeBron has a bigger effect size. So since LeBron has a bigger effect size, he's way better than Brian, then you're less likely to make the error and say that Brian and LeBron are the same. So because LeBron is way better, this is effect size we're talking about right now. We're talking about effect size. So if you were to say Brian versus LeBron, Brian versus Darren, you're more likely to make a type 2 error with Brian versus Darren because we're more similar. It's like Brian and Darren are this, Brian and LeBron are this. So, LeBron's way up here. And you're more likely to make a mistake and say, oh, Brian and Darren are the same. So with Brian and LeBron, it's less likely that you would make a type 2 error because there's a bigger effect size. The difference between Brian and LeBron is way bigger, i.e. this difference between my hands is the effect size. Good, yep, I like it. And then alpha is a bit interesting with this example. Hopefully this doesn't confuse anybody with my example here. Alpha, the higher the alpha, the less likely you are to make a type 2 error. But in this instance, it actually goes reverse with the points. Let me think. If anyone can help me make this example work perfectly for the alpha, it'd be awesome. But if you increase your alpha, which actually goes to a lower difference in our points because it's how much evidence you need. So if you increase your alpha, you require less evidence. So in the terms of a basketball game, a very high alpha would be something like LeBron beating me by 1 point. Because, and sorry, it sounds weird because you're like, wait, that's low points though. That's a low difference. But in that instance, you're actually asking for very little evidence, which if you only need very little evidence, that equates to a high alpha. Because alpha is the amount of evidence you need, your p-value, because remember your p-value has to be below alpha. So if you increase your alpha, you make it easier to reject. So if you say, well, if they win by 1 point, then that would make it very easy to reject. A very low alpha would mean you need a lot of evidence. So it's a little bit weird with this example. The higher the alpha, the less evidence you need to reject. So Jared, 20 points right there. The higher the alpha, the less evidence you require to reject, because alpha is the point at which you reject. And it's your type 1 error. So the higher the alpha, the less evidence you require to reject. So if you make it easier to reject, it would equate in a basketball game to saying, well, if they win by 1 point, they're better. Oh, it might be a speed run. Yeah. You guys want to do a speed run? Here, we'll do it at the end of this section right here. So let me see. We only got a little more notes. We'll finish off this section because we're almost done with these notes. Like, there's not much left. I like that. And they're not inverse. Here, I'll show you this. The notes just go through what we just talked about. Alpha and beta are not complements, but they're inversely related. You are right. So if alpha is low, is it then type 1? So alpha literally, let me make it very, very clear. Your alpha literally controls what % of the time you have a type 1 error. So if you pick alpha, if you pick alpha to 0.05, what % of the time are you expected to make a type 1 error when you do your tests? With an alpha of 0.05, what % of the time will you make a type 1 error? Because alpha is literally type 1 error. Yep. That's how often you'll make a type 1 error. Because you'll reject the null by random chance this % of the time when the null is true. Because think about it. This is the point at which you will reject the null, given your results are more extreme than it. How often your notes would... Oh my gosh. Your results could occur 5% of the time given the null is true. So you're saying I'm willing to reject the null even though my results could have occurred by random chance 5% of the time. So the null might be true here. Think about that. When we say given the null is true, we're talking about you might have made a type 1 error here. So how do you know when to use alpha in correlation with beta? So the biggest thing is, and so Camden, you asked a really good question, because In this class, you'll never have to find beta. You'll never find beta in this class. But that's actually a very important thing for research. It's just very, I'll show you guys. Let me pull up a website that does it for us. Power calculation. Will this do it? This is the first site. This site shows the power calculations. Power calculator. You will never... Oh, here we go. Cool. Someone's got it right here. All right. Head over to the screen. This is what this is used for. Let me make the font way bigger. Okay, so they have right here their null mean and the hypothesized mean. And look, they have their alpha level. And then they have the desired power, which is beta. And so let me put the chat back on the screen. So what people oftentimes use this for is before you do research, you might say, okay, I think that, and I think sigma, oh, they're actually doing the standard deviation, because that does come into play a little bit here. They say the mean for the first group is 15. That's the alternative mean. So that's our hypothesized mean. That's our alternative mean. And we have right here sigma. Let's go to a sigma of 2. There's the two-sided test. And now we're going to figure out the sample size. So wait, beware the calculated sample size is too small for approximate calculation for 2. Let's go to 99 power. What? Your power calculator is odd. Go to small variation. I don't know what's going on with their power calculator. There we go. So probably, I guess my standard deviation was so small. But this right here, just depending on, because I want to use an alpha level of this, I want a desired power of this. We're gonna define power in a second. But what people do with research is they might do some preliminary research to get an idea of where their mean is at. They want to do a certain test, and then they understand the variation to a certain extent, and then they will calculate, this one is for specified power, and we can calculate a sample size for a specified power, and then you can flip it here, apparently. I've never used this power calculator. Now we're going to enter in a sample size, and it'll tell us the power, apparently. Oh, good. That's amazing power. Change it to that. And there's the power for that one. So it's important. We'll define what power means in a second here, but people use it. Let me go back to the main screen. People use power to calculate kind of like if they should do their tests. So what does power mean? I should tell you. Power is the ability to find results. And power is simply 1 minus beta. So how important for us to know power is it to know beta? Power is simply the ability to find results. And then more specifically in textbook definitions, it's the ability to correctly reject the false null. Because think about this, if the null is false, then we want to reject it. And what is what we don't want to do? We don't want to make a type 2 error. So just look at this formula. 1 minus a type 2 error. So everything but a type 2 error. So if the null is false, we can reject it. Does that make sense? It's not making a type 2 error. So power is not making a type 2 error. And if we don't make a type 2 error, we will reject the null when we should. So it's rejecting the null when you should. It's finding results. So power, if you have a very powerful test will find results. Think of this. What if we had a very powerful test to figure out if somebody had scurvy? What would the test do? It would find all the people who have what? A powerful test would find all the people who have scurvy. But you know what you could do? Is you could cheat and make a very powerful test where the alpha level is just equal to 1. What would this test also do right here? This test would have a ton of false whats. If you set your alpha level to 1, this test would have a bunch of whats. Crack me up in the chat. This test would have a bunch of what? False positives. So, but wouldn't you still find everybody? You would still find everybody, but this test might be too powerful, or it's powerful for the wrong reasons. It would have so many false positives. And people care about false positives versus false negatives. Like, you know, is it the end of the world if we have like one false positive per 1 million? Not the end of the world. But what if it's like we have all false positives? Well, then that's a problem. You can find everyone with scurvy if you tell everyone they have scurvy. And that's not a good way to do medical testing. To be like, everybody has scurvy. Like, well, Now you've just put a bunch of false positives. You're like, but we found everybody who has scurvy. And you're like, well, but that's just bad statistics now. So the three things we talked about, once again, that control beta, and beta is literally used for power, like 1 minus beta is power. Oh, man, yeah, I know, right? Current events. Right here, we have that the effect size controls beta. So larger effect size, smaller beta. Effect size is the difference between the null and the truth. Next, we have alpha level, larger alpha, smaller beta. Next, we have sample size, larger sample, smaller beta. And what happens here? If we make beta bigger, then power goes down. So yeah, we want beta to be smaller. So that's it for this. There's the power illustration. I hate that graphic. And some examples. You know what it's time for? You know what it's time for. Everyone knows what it's time for. It's time for a random phone call. That's what it's time for. Let's get the screen on going here. You got it, Hannah. It's time for a speed run. Did I not have the... I thought I had the speedrun thing going. I thought I had the speedrun graphic. Where's my Mega Man at? I think I know where Mega Man's at. There we go. Cool. All right, let me go back. You know, we need the real speedrun. You know what it's time for, everyone? It is time for a speedrun. Let's do it. There's our Mega Mans. Where's that Mega Man at? Awesome. A little bit of randomness. I don't think I have Kahoot is back on the screen. Got it. We'll do some randomness today. You know it. Okay. Let's do a speedrun of type 1, type 2 errors. Here we go. It is time for us to understand that when we have a type 1 error, let's put this right here, versus a type 2 error. In a type 1, just hold up your finger right here. Type 1, the null is true. In a type 1, the null is true. In a type 2, the null is false. There we go. In a type 1, the null is true. In a type 2, the null is false. Make sure this is an F. Make sure this is a T. So in a type 1, the null is true. In a type 2, the null is false. Then you have to pause. So review this in your head. Review it and get it memorized. Because if the null is true, what would be a mistake to do the null? If the null is true, it'd be a mistake to reject that. So I often call this a false positive. And we'll see some examples here in a moment. And if you think about the null being false, it'd be a mistake to fail to reject it. And so that'd be a false negative because you're going to fail to reject it. Also, we should know that a type 1 error is your alpha and a type 2 error is your beta. These are literally like if someone says, what was your beta? Then this is the type 2 error for your test. If they say, what was your alpha? That is literally the percent of time you'll make a type 1 error. So what we need to know now is some examples. So let's try this out. You ready? We've got right here the null hypothesis is that, let's say you're going to go and you're going to bet the Patriots don't have Tom Brady anymore. So let's say you're going to bet that the Patriots are going to win by default and lose right here. So your null is that the Patriots win because they had Tom Brady, but no one tells you that Tom Brady's gone. It's going to be interesting next year. Boo. So what happens in a type 1 error here when you bet on the Patriots? What happens in a type 1 error here? What is a type 1 error? So, but be careful. I guess you think about what you would do. So if you're thinking about betting on the Patriots, be very careful. Now, here's what I want you to do. So we got to slow it down the speed run here. I wish the timer could go to slow-mo. So in a type 1, the null is this. You got to say it. You got to be like, in a type 1, the null is this. In a type 1, the null is this. But we're going to what it. So do the full thing. Do the full thing. You gotta say what it is, but you gotta say what it means. Type 1 is true that they'll win. You're right. It is true that they will win. Correct. But what does that mean? It is true that they will win, but we what? You're correct. Yep. I think some people are getting it now. It is true that they will win, however, we reject that they will win, and we believe they will lose. Does that make sense? In a type 1, it is true that the Patriots will win. Because, the Patriots, even without Tom Brady, we'll find out. First time in like 12 years. It's a false positive. And so in this instance, we came to the conclusion, we said there's evidence the Patriots will lose, but we were wrong. So in a type 1 error, we're like, there's evidence the Patriots will lose. So we made a false positive here. I call it that a lot of times. Got my sports shirt on backwards today. And we make a false positive here. In a type 2, I want you to look at the null, and I want you to talk about it this way. Look at that null all the way up there, and it's right behind me. In a type 2, the null is what, but we are going to what it. So what does this mean? Put it into context. And I'll do another example here in a moment. For the Buffalo Bills. 20 points kneeling right there. Yeah, my cousin will tell you that. He's been a Bills fan his whole life. What's a type 2 mean? What's the type 2 mean? What is the type 2 error? So do it here. The type 2, the null is false, but we failed to reject it. That's correct, but put it in context. In a type 2, the null is false. So look at the null and say it is false that they will win. In type 2, but make sure to do the full thing. It is false that they will win. It is false. The null is false, but we fail to reject it. But what does that mean? What does that mean in context? You're very correct. Everyone's got the definitions. So it is false that they will win. So it is false that they will win, but we fail to reject that. It is false that they will win. It's believing they will win when they will actually lose. It is false that they will win. So in a type 2, the null is false. So you have to look at this null and say, this is false. So they're going to lose. But then you fail to reject that. And you say, well, I believe they're going to win. So you believe the team will win when they're actually going to lose. Does that make sense? Here, we'll do another example here in our speed run to practice what these are. And I've got another speed run also that goes over the things that go into a type 2 error, I believe. I just want to do examples here because this is where people usually get tricked on the test. So let's do the court case example because it's a very famous one. Might even be on the test. I can't remember. I'll look over the test more tonight and give hints for the test. Not to give it away, but just hints. So we have here the null is innocent in a court case. And the alternative is guilty. Now, when you talk about the type 1 error here, I want you to specifically say, this is true, but we reject it and say this. I want you to specifically say for a type 1 error here, this is true, but we reject it and say this. So you don't reject, but you believe you will win. In the type 2 error, so Camden, it was the type 2 error, it was false that they would win, but we failed to reject it and believe they will win. So it is false that they will win. They will actually lose, but we fail to reject it. Remember, type 2, fail to reject. And it is true that they are innocent, but we reject it and say they're guilty. Boom. 100 points, all those answers. Exactly. And do you see how using that format right here, we can get it correct every time? The null is true. It is true that they are innocent. You have to do it that way. Just look at the null and be like, that is true. It is true that they are innocent, but we reject it and say that they are guilty. I know, right? I play piano with my eyes closed. It's like, not like, oh, I play piano with my eyes closed, but like, I don't know. It just helps you like hone in on it. Like you put out all variation in the world and just go to your mind variation. So then in a type 2 error, what is the type 2 error right here? What is the type 2 error? In a type 2, here's the format I want you to use. In a type 2 error, the null is false. So say what the null is. This is false. But we fail to reject that this. So this is false. But we fail to reject this. Now put what that is in there. And so I guess you could say where this is true. So let me be very specific. In a type 2 error, this is false, the null. So you could say it is actually true that this is true. But we fail to reject this. It is, be careful. Let me read a few right here. It is true. Wait a minute. Did I just make a mistake in what I said? In a type 2 error, the null is false. Hopefully I didn't misspeak. Sorry. That's why I slow my brain down too. I think I misspoke. Please do not look at the last 30 seconds. Let me be very slow here. In a type 2 error, the null is false, but we fail to reject it. In a type 2 error, the null is false, but we fail to reject it. Type 2 error, the null is false, and we fail to reject it. In a type 2 error, it is false that they are innocent. It is false that they are innocent. So they are actually guilty. But we failed to reject it and say they are innocent. Does that make sense? Let me repeat it slowly again. In a type 2 error, the null is false, but we fail to reject it. Type 2 error, the null is false, but we fail to reject it. And so then we would say it is false that this person is innocent. They are actually guilty because it was false they are innocent, but we fail to reject it and still believe they are innocent. So a type 2 error would be the person being guilty, but us believing they're innocent, which is just the opposite of a type 1 error, which is when we send an innocent person to jail. We say an innocent person's guilty. I know it's a little bit tricky. We'll do one more right here. And so let's think of I'm trying to think of a different one I don't usually do. So we could think here about like, let's do this. Let's go here and let's say hurricane. So we, it's like let's say volcano. I heard something about Hawaii's volcano lately. So erupt. Okay. This is I think this is actually a really good example because it's like real world, like these are things people have to make decisions by. Which of these would probably be worse? Which of these would be worse for someone running a government, a type 1 or type 2 error here? And I will say this, type 1 or type 2 error is contextual, and then you could always make arguments for which one is worse. Sometimes it's a little more obvious, but which of these would be worse? I want you to, if you've been following along, explain to me which error you think would be worse and why. And then explain to me which would be worse and why. Like, you have to tell me why. I'm going to think about it, and I'm going to figure out which one I think is worse. Let me slow down here and think. So we're talking about a volcano. The null is that the volcano will not erupt because you need evidence to say it will erupt. So that kind of makes sense. Like, you would say we have evidence it will erupt. And so which of these would be worse and why? I don't think anyone's given a full answer yet. So write down on your sheet of paper right now what a type 1 is. A type 1 is the null is true, but we reject it. A type 2, so you should have what that is. And then I think some people might be getting it. Let me read Claire's. Type 2 would be worse because it is false. That is not erupt, but we be careful. Remember, it's a type 2 we fail to reject. We fail to reject. Type 2 is because be very, very careful. Yes, Bridget, 100 points, Bridget. Let me read Bridget's answer. Bridget says type 2, it would erupt and they would not be prepared. Bridget, that's worth 1,000 points. Bridget, amazing answer right there. I think the type 2 is the worst one because let's review. In a type 2, the null is false. So this is false. So what do you know in a type 2 error right now? What do you instantaneously know in a type 2 here? In the type 2, you know that this is false. The volcano is going to actually erupt. But we are going to fail to reject the null. So this is when the scientists look at the volcano and they say, we're fine. And then it erupts. So does that make sense? So good job. This was, I think, a really good like final one to be like, which of these do you think would be worse? So in a type 2, it would be not preparing for a erupting volcano. A type 2 in this instance is not preparing for an erupting volcano. A type 1 would be everybody evacuating and the volcano does not erupt. So in a type 1, the null is false. So, I mean, oh my gosh. Please, if I say something wrong, correct me. In a type 1, the null is true, and we reject it. It is tricky. You have to look at it in the type 1 and say the null is true. It is true that the volcano will not erupt. Does that make sense? It is true that the volcano will not erupt. In a type 1, the null is true. So it is true that the volcano will not erupt. But what do we do in a type 1? What do we do in a type 1? Even though the null is true, what do we do in the type 1 error? When you reject the null, you're saying, I think it's wrong. I reject that it will not erupt. I have evidence that that it will erupt. And you would say, well, why would you do that? It's because people make errors. Because the scientists are looking at the volcano and they don't know what will happen. I mean, they've got good estimates. So they say, we've got evidence the volcano will erupt, and then it doesn't. And that would be a type 1 error. It's false positive. Imagine them scientists saying that. Well, that was a false positive. Could you hear the scientists saying that that was a false positive? We thought it would erupt, but it didn't. Reasoning for type 1. A type 1 in this instance, and it's always, in a type 1, the null is true, but we reject it. So that means in this instance, in a type 1, the volcano will not erupt. The volcano will not erupt, but we reject it, and we say we have evidence it will erupt. So we evacuate the place. It could, just like these, it could ask you what's the type 1 error. It could have it in words. It could be like, is A, B, C, or D a type 1 error? How is, I think if you understand this, if you understand type 1 is alpha, type 2 is beta, and you understand these examples, like a type 1 being a false positive, it could ask you that. It could say like a type 1 error is rejecting a false null. True or false? A type 1 error. Let me put this in the chat. You ready? True or false? It's just type T or F after I write this. And listen carefully. A type 1 error is rejecting a false null. True or false? A type 1 error is rejecting a false null. Good job. What's the error in that? What's the error in what I wrote? Who can correct it for 100 points? A type 1 error is not rejecting a false null, because that's what you should do. If the null is false, you should reject it. That would be actually the right thing to do. If the null is false, yep, Claire, 100 points, Claire. Yep, true null. A type 1 error is rejecting a true null, and rejecting the false null is what we should do. Does that make sense? If the null is false, you should reject it. Like, this is false. Okay, I should reject it. But a type 1 error is when the null is true and you reject it. So that's an error. And then a type 2 error is when the null is false and you fail to reject it. So you can see how those are errors right here. So if you understand the definitions and if you understand some examples, you should be pretty good. It's a little tricky, but use your type 1, the null is true and we reject it. Type 2, the null is false and we fail to reject it. And then you can have it memorized, unless you are like Brian Stevens and have not had enough coffee and you just flip them every once in a while. Very sorry. Very sorry. I tell you what, we're going to take our 5-minute break. I've got some lemonade, the last of my lemonade. I'm going to grab it. We're going to take our 5-minute break and come back for our last major lecture on the test. How's that sound, everybody? Our last major lecture on the test. It'll be the last big material that you'll have to know. And when we do it, you'll probably be like, whoa, we've already done this. Brian, we've already done t-tests. And this will be the last big chapter for the test. So if you understand this chapter, you should be pretty good. I'm getting the notes loaded up here. It's a good spot for a break. A little early on the break today. We should have enough time, more than enough time for do. Got that. Let's start this screen. Sounds good. So just to clarify, type 1 null is true, and we... Wait. Remember, type 1, the null is true, and we reject it. A type 2, the null is false, and we fail to reject it. So in a type 1, just the volcano example again real quick. In the volcano example, which I think we can see right here. In a type 1, the null is true, so it is true that it will not erupt, but we reject the null and we tell everyone to evacuate. So in a type 1, the null is true, the volcano will not erupt, but we reject the null and tell everyone to evacuate. In a type 2, the null is false. So when I say the null is false, it's actually true, it will erupt. The null is false in a type 1, but we fail to reject it. So in a type 2, the null was false. It's going to erupt, but we're going to fail to reject the null. And in a type 2, we say, it's not going to erupt. It's not going to erupt. In the exam and all that. So in a type 2, we don't evacuate everyone because we fail to reject the null. So does that make sense? It erupts in a type 2. It erupts in a type 2. In the type, if what you saw right there, Camden, would actually be the correct response. If we evacuate because we think it will erupt, then we rejected the null correctly. So think about that. If we get everyone to evacuate, that means we thought it would erupt, and we were correct in rejecting the null. But in a type 2 error, the null is false, so it is false that it will not erupt. It actually will erupt, but we fail to reject the null. We're going to say, we still believe the null. So we're going to tell everyone not to evacuate because we think it will not erupt. So because of that, it erupts because the null was false, but we failed to reject it. In a type 1, the null is true, so it'll not erupt in the type 1. And so think about this. The null is true, it'll not erupt, but we reject it and say it will erupt. Thank you so much, Elise and everyone. It'll... Yeah, you're right. That would be Mount St. Helen, which I think they had that eruption. That is Mount St. Helen, where they're like, it's fine, it's gurgling, and then it erupts. So that'd be type 2. Yep. Alyssa, it is open till 5 p.m. on Thursday. 5 p.m. on Thursday. It opens tonight. Exactly. Does that make sense to call it a false positive? Like, you look at the afterwards, you'd be like, well, that was a false positive. So you rejected the null, saying, oh, we've got evidence it's going to erupt, and everyone gets out of there. And then, yes, I mean, these are the aha moments you need after you just have to, like, yeah, no, good job, Camden, 100 points. I like that you, like, stuck with it, and you're like, sometimes you just got to be like, I just got to keep eventually you just see, and you're like, oh, it's false positive, because they were like, yep, yes, we will do that tomorrow, and the bonus. Here, wait, I'll be right back. I'm going to get my lemonade. Right, Brian button doesn't work. It's only on the other screen. I got to make it so that button works. Where's my... Boop. Right back. I wish I could fade myself in. There's actually a way to do that. I've been watching way too many videos on how to do stuff. No cap on points today. It's about as difficult as the previous tests. And then, so one thing I do want to mention is we have a bonus note-taking quiz. It was called Max Extra Credit, but I changed the name, sorry. Where's assignments at? My lemonade froze. Put it in the freezer. Ugh. There, boop. Oh, I'm gone? Oh, because I did this. I'm back. I should make ways to make myself appear. So where's chat at? I didn't get to hear punch out. So what we have right here. I know you guys, it's going to be so quick. I've got 2 classes starting up on Thursday. So if you missed a note-taking quiz and you're worried, I'll be dropping 3 note-taking quizzes. I know it's too frozen. It's like frozen, like rock solid frozen, not like slushy frozen. That'd be awesome. So I'm letting it thaw out there. So yeah, I only put it in like start class, hour and a half froze. There's an extra note-taking quiz. Let's take a look here. Quiz 7. So this is the chi-squared test of independence, and Spanish me gusta español mucho. You've got the chi-squared test of independence right here for this note-taking quiz. There's a help video right here to go through it. And then last but not least, there's a bonus one, which is pretty much a review where you just solve problems that I've already done, and we'll be dropping 3 of them. Will you still drop note-taking quizzes? We get hundreds on all of them. Yeah, I mean, they're just, yeah, if you've already done all the note-taking quizzes, you don't have to do these last few. So if you are, let me just say that flat out. I'm dropping 3 note-taking quizzes. If you only need to have done 5 of them. So if you're like, oh no, I've got a bunch of note-taking quizzes, I'll probably send a reminder for this. But this is more of an opportunity for those people who don't have good note-taking quizzes. So, I mean, if I was you guys and I was like optimizing time and I was already done a bunch of stuff, I'd be like, I'm good. He's dropping 3 because of the extra one. But if you missed some, this is an opportunity here for you to do them if you've missed them. So if you missed some note-taking quizzes, there's kind of because there's 2 more left. So you only need to have done 3. And so, yeah. Is the bonus? Yes. With your guys' extra credit. Yep. Yeah, everybody's so tired. And then Thursday, classes start at 8. I'm like, oh man, I need to get into bed at like 11 then. What about the quizzes? Can we just drop the chi-squared quiz if we have 100s on the others? Yeah, you can. You can. Neil, and if you have 100 on all the other quizzes, you can, because it's not on the test. I mean, good job, optimization of time. You're like, hey, I don't got to do the chi-squared. I mean, I think it's important, but I mean, it's used in a lot of places. But since it's not on the test, and since you have a drop, but here's the thing too, is homeworks don't have drops. Yeah, and you have to do the homework. So yeah, don't not do the homework, because the homework, it wouldn't be that you could probably do it and guess a lot of the questions and not hurt your grade that much by like just taking the homework and guessing. And remember, homeworks don't have drops, so because homeworks are infinite tries. So yeah, it looks to be pretty good. Man, I froze my lemonade. Now I can't drink it and get some sugar, get some energy. I need to look for my K-cups. I think I still have some somewhere. Well, that's got it. Let's hop back to the notes. Here we are. Got the notes going on. Turn the music down a little bit. Oh, you couldn't hear it, could you? Looking at all the different sound effects. Okay, let's do this. It is time for the last major chapter on the test. This is it. Who's all here? Let's get some haze in the chat. Let's get excited for the last chapter. Last major chapter on the test. Praise the Lord. Really excited right here. Awesome stuff. We know what's going on. Woo, Crab Rave. You know what's happening. Let's do it. We got excited right here. I'm going to appear randomly. Watch this. Here we go. Oh, I got to go. Bad idea. I'm going to mess up the order here. Whoa. Now I'm here. This is not the right spot anymore, though. Let me go back to menu. Okay, good. I'll mess it up. I'll mess up the whole order if I do that. Okay. So with this right here, let's take a look at the last chapter on the test. The last major chapter was still business analytics tomorrow. Don't miss the business analytics. It's short. It's easy. Oh, there'll be more crab raves. And Ben, I think you're in our 320 class, so there'll be lots more crab raves. I'm Sarah. Sarah, thank you so much. And you guys fill out the TN voice when it comes out. Put nice things if you want. I'm glad you guys liked this. So let's do it. Let's go. Here we go. A confidence interval for the difference between two means. Okay, you ready? Here's how we know what's going on with this chapter. We need two means. Aw, you guys are awesome. When we have two means right here, what does this mean? We're going to go, oh, man, this would be so good. We're going to go to Cheddar's. We're going to get the Santa Fe spinach dip. And then what's the other restaurant we're going to go to? What's the other restaurant we're going to go to? I just want some Santa Fe spinach dip. Where else are we going to go? Anyone have ideas? Matron's awesome. You get done with everything so quickly. Cookout. Do they have a spinach dip, though? Stock and Barrel. Oh, Stock and Barrel's so good. Tomato Head. Okay. I think, so we got Cheddar's and we got Tomato Head. And then we're going to have different people try the spinach dips. So we'll do a ... like I carried this down. I think they might have it. And this person didn't like their spinach dip. I can't say that about Cheddar's. That person didn't like it as much. It's very similar. I still think, and it's actually it would be. These have the same right here. These have the same mean right now, just with the observations we can see. Muya's good. Muya Burger's good. I know Cheddar's is so good. And so, what are we comparing between these two groups? We're comparing the two means of these groups. Does everyone see this? Cheddar's is a restaurant here in Knoxville and in Kingsport. Started in Texas, I believe. Pretty good stuff at Cheddar's. I like it. Maybe some people don't, but I like it. Yep. I worked there in 2000. Oh, God. Because it's so long ago now. I worked there in 2001 through 2004. served tables at Cheddar's. First place I served tables at. I served tables at a few others. But let's check this out right here. Watch this. If you've been doing the project, then, yep, fish tanks and all that good stuff between the bar. Go right here and go to Analyze, Fit Y by X. Let's compare the pepperoni pizzas to the non-pepperonis and compare the scores. Now, what do you notice about these variables? When we do the two-sample t-test, the x variable is what? You should know this, and this is a good review of Jump. The x variable is a what type of variable? 100 points first person. The x variable is a what type of variable? Yes, Devin, 100 points right there. Devin, you're right. And the x variable is categorical. The x variable is categorical, and the y variable is quantitative. Does everyone see that? So we have a categorical x, and we have a quantitative y. And this is your two-sample t-test. And you know what we can make for this? We show it this way. There we go. What do you have here? Side-by-side box plots. We have side-by-side box plots. This is not the two-sample t-test yet, but it's pretty obvious, and if you've been doing the project, that the pepperoni pizzas have higher scores than the non-pepperoni pizzas. So I just did a box plot here to look at the data, and we have a categorical variable. We should understand that the two-sample t-test is we have two means. I have a mean for the no group and a mean for the yes group. And then we go here to t-test. That's all you have to do the two-sample t-test. And guess what? We get results. What do you notice about these p-values here? Does everyone see the p-values? That is all of our results right here. You should notice they are statistically significant. And if you understand just this output right here, you understand the whole entire chapter. So guess what? We're doing it. We're going to do a speed run of this whole chapter right here, and then we're going to review it. So let's do a speed run to start and talk about this right here, right now. That's not speed run button. There we go. Okay. Let's talk about what's going on with the two-sample t-test. In a two-sample t-test, we have here two means. In a two-sample t-test, we have two means. And probably one of the easiest way if you get output like this is to know that you can simply go above it and write mean and mean. Let me erase that. I'm going to do a white pen right here. I think that'll still keep my white pen. Cool. Because if you go right above this output, you can write mean yes minus mean no. And guess what? You've almost written out the null hypothesis here. Because the null hypothesis for this test is that the mean for yes minus the mean for no has no difference. So this would be equal to what? If they have no difference, then this would be equal to what? It'd be equal to 0. And why are we so concerned with writing the null? Because if we can write the null, we can write the alternative. The mean for yes minus the mean for no is not equal to 0. We can choose the sign of it based on how we want to test it. But if you notice, what am I testing? I'm testing the difference between two means. That's what this chapter is called, is the difference between two means. So the null here says that the difference between the two means is equal to 0. I can pick the sign, and the sign is the only thing that changes. When you write your alternative, you write the exact same thing for the null here in position 1 and position 3, because that's the hypothesized value, and then you just change the sign. So once again, we have what are we testing, then it always has the equals because it's the null, and then we have what is the hypothesized value we think it's equal to. So we're saying I think there's no difference between our pepperoni and our non-pepperoni pizzas. Now this right here, this is the difference we saw. This is y bar yes, so that's y bar yes minus y bar no. So these are the differences. I want to see in the chat for 100 points. These are the differences we saw in our what. These are the differences we saw in our what. You should know via the notation, these are the differences we saw in the whats. Like this difference is the difference we saw in the what. This difference is the difference we saw where. But the key thing I'm highlighting right here, this key thing is different from this right here. Sample, Isaac right there, 100 points. The samples. This is the difference we saw in our sample. Like, we're trying to estimate the true difference between the pepperoni and non-pepperoni pizzas. Like, what is the true difference? So what do? We go out and we take a sample to estimate the truth. So once again, statistics is about taking a sample to try to understand what the truth might be. And we saw that the pepperoni pizzas get, on average, a higher score of 2.2. So we saw that in our sample, the difference between the means was this. Now we're going to use this to make inferences about this. We're going to say, well, what might be the truth for all of them from what we observed in our sample? So what is the next bit of notation right here? This is the standard error of the differences. So that's just subscript. That's the standard error. It's like subscript with subscript. The standard error is basically a standard deviation. So guess what? The t-test is the following formula. The t with degrees of freedom is equal to y bar 1 minus y bar 2, technically minus 0, but I'm going to delete that because we don't need it because it's minus 0, over the standard error. And it's why you can put yes or no, it's fine. So guess what? If you divide this right here, what is someone do in their head, what is 2.21 divided by 0.21? What is 2.21 divided by 0.21? It sounds very similar, doesn't it? We haven't done this before, but we're going to do this first, then we're going to do the notes. Because knowing this output is very important. What is the difference divided by the standard error? Yeah. For those saying it's this. It's that right there. So you literally have in this output that it's equal to this. Does that make sense? You're just dividing the difference by the standard error. It's the t ratio. Because we said it is equal to this. So it's just this over this. And that's the difference. Does everyone see right here that this literally is the difference? And so we'll erase everything up here. This is the difference. And this is the standard error. And here's the thing for your confidence interval. Your confidence interval is y bar 1 minus y bar 2, which is just the difference. Does everyone see here that this is literally... Oops, wrong button. This is the difference right here. This is just the difference. Plus or minus, now be careful, this t right here is the t you pick based on the level of confidence times the standard error. I'm running out of room right there. So this right here is our confidence interval. The standard error here is basically 0.2. What is 0.2 times 2? Who in their head can do 0.2 times 2? Who can do 0.2 times 2 in their head? That's basically what? 0.2 times 2 is what? 0.4. Can you see the margin of error on this interval? Look at the interval here. This was on the last test. Who can compute the margin of error of that interval down to the decimal? And I'll do it here on the screen. The margin of error of that interval, which we've covered before, the one I've got right here, how would you do it? Try to compute it. I'm going to start it, and who can beat me? You get 200 points if you beat me to finding the margin of error of that interval. That might be it. Yep. Nice job, Andy. 300 points, well earned. You got it. And Alyssa, 300 points. So that is the margin of error. It's just half the length of the interval. And you could literally figure out the t statistic used to make the interval. So we could backwork it and divide this by the standard error. And that was the t statistic. It was basically 2. This t statistic is picked on the level of confidence. I want to put this huge note out there that you have to know. The t for the confidence interval, we should know, is picked based on the level of confidence. The t for the test is the standardized difference. So the t for the test, these are not the same thing. I put like a big X between this. These are not the same thing. Those are not the same thing. And so, Jack, Jack, what are you wondering on it again? For the margin of error, what 2 numbers did you use? I used a t of 2 as an estimate because I estimated the t to be 2, and then I timesed it by the standard error. Because a lot of times a 95% confidence interval, t for the test is what again? It's the difference standardized. So that every t-test is a difference standardized, but the t for the confidence interval is picked based on the level of confidence. T for a confidence interval is picked based on the level of confidence. So the t for the confidence interval won't be a standardized metric. It is standardized, but we pick it based on the level of confidence. So how do we know what t this is? This t right here is related to the 95% confidence. Does that make sense? That's where a lot of people get tricked. Because they're like, wait a minute, isn't this the t? But that's the t for the test. Very close to 1.96, but because the degrees of freedom here are 70.56, so we'll hop back to this screen. Me on the speed run. So because it's 70.56, we have to go over to the t-applet. So the degrees of freedom are 70.56. I just got way too many things open. So stat distributions t. We go here, we enter in degrees of freedom are 70.56. And there is the t right here. So remember, I calculated it myself, and I got this. I got it kind of more decimal place accurate. And but this right here has right here, maybe jump didn't carry enough in the background. But you have to go to the t-applet to get the degrees of freedom. I mean, to get the t for the test. So this is where a lot of people get lost on this, is because they're like, wait a minute. So if you notice, this is what we were doing before. So let's slow it down. Let's go to the notes, and let's slow it down. Here we go. Okay, does everyone understand when we would use this? It's when we compare the mean for this group versus the mean for this group. Does everyone understand when we would use this? We go to Cheddar's and we go to Tomato Head, and we have people try their spinach dips and give it a rating. So we've got a mean rating for Cheddar's, and we've got a mean rating for Tomato Head. This is when we use it, which is the biggest thing we should know to start. Like, when do we use this? We could also do it with batteries. So if you see, we have generic batteries and we have brand name batteries, and we can see, like, what are the scores of these batteries? Not the scores, but how long do they last, which is a quantitative measure. So the thing you should note right here immediately is that the y is quantitative and the x is a two-level categorical variable. So we see that we have a quantitative y and a categorical x. Very, 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 very important right there. We have a quantitative y and a categorical x. Very important. So when we do this right here, what are we trying to compare? Well, our goal with this is to look at the difference between the two means. The difference between the two means. That's our goal. And what is our best estimate of it? Our best estimate of it is the sample difference. So all we have here is mean 1 minus mean 2 from our sample. This would be the scores people gave the Cheddar's dips, the scores people gave the Tomato Head dips. And so what's our goal here? To estimate the real difference. Like, maybe Cheddar's wants to say, we won against Tomato Head in national taste tests, or like, Knoxville has spoken. Cheddar's spinach dip is better than, I mean, usually they don't go by statistical significance. They'll just do it if they win by one vote. But that'd be proportions technically. If people are giving ratings, it's quantitative. If they voted on it, it would be proportion. So that would change if they voted yes, no, because then it'd be categorical. So what do we see right here? Now, Brian, you didn't show us this. I kind of did. This is the standard error. The standard error is s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. This is very, very similar. So when you're looking at it, it's this right here. This is, oh, I can't see. Bring in this middle screen. This is the standard error. Let me erase so it's very, very clear. Wrong button. This is the standard error. I'll re-highlight it again in a second. Okay. Standard error is this right here. So the formula you see right here solves out to this. But I want to point something out. You've kind of seen this before. Because, does anyone remember? I should not have two things open, or else I think it's the one. Does anyone remember? Okay, good. S over square root of n. Does anyone remember s over square root of n? Who remembers s over square root of n? Who's got me on my s over square root of n? Anyone remember that? Yep. That's the standard error of y bar. That's just standard error of y bar. But watch this. What happens? Couldn't I just do this? Let me see if I can do this. How about if I square this and I square this? Okay, then that will do this. Should not have two things open. I'll do it one more time. I get one more shot before I say, nope, Brian, you're not allowed to do that. And then I do this. Yep, okay. I said I got one more shot at it. There we go. Okay, s over square root of n equals the standard error of y bar. And then we go and we square it. Square, square. Now the thing is, can I just square stuff? Can I just willy-nilly square things? Could I just square things for the fun of it? Am I allowed to do that with mathematics? Can you just be like, oh, let's just square it? If you square it, what do you do to square it? Have I now written the same thing? And actually, here's the thing though. Sorry, error. That should not be that. Because I squared square root of n. You square root it, right? So, and great job. Oh man, I was like, come on, Brian, don't keep making that same mistake. And I kept making it. So now we go right here and we go and we take and we do s sub 1. We just call it the first, n1 plus s sub 2 squared over n sub 2, and we square root the whole thing, and we call this the standard error of the difference between the two means. You don't have to memorize this, but that's why it exists. So does everyone see? It's literally just the first standard error plus the second standard error. Does that make sense? You're just adding together the two standard errors. So this is the standard error of the difference between the two means. And it's just the additive standard errors. So if you look at the original formula of s over square root of n, you've squared it, and then you've square rooted it to bring it back, and you're just adding together the two standard errors underneath the radical. So that's why this formula right here exists. And once again, you don't need to memorize this. We give it to you on the test. So what are these things? So what's the difference between those formulas on the notes? So this one right here, the very top one, is if we know the true standard deviation. So this right here, if we knew the true standard deviations, then we would use this formula here. But since we don't know the true standard deviations, we have to use S. In truth, the top one right here is if we're doing a 2-sample z-test, and this one's a 2-sample t-test. So we don't do the 2-sample z-test in this class, but if you ever see it, the 2-sample z-test uses sigma. So I tell people sigma z, S, and t. So that's a way to memorize it if you ever have to see it in another class, like sigma goes with z, S goes with t. So sigma z, S, and t. So if you ever see sigma in a formula, you're doing standard deviations and you're doing z-scores. If you see S, you're doing t-scores. So sigma z, S, and t. We will not do the 2-sample z in this class though, but the formula is nearly identical. It changes literally just the sigma and you solve for z. So right here we have a 2-sample t interval and a 2-sample t test. That is the whole point of this chapter, to just know the 2-sample t interval and the 2-sample t test. That's it. Know when to use it, know how to use it. Oh, it's not on the screen. I click it manually. Condition 1. Who's going to help me out? Condition 1. Condition 1. Gotta wake me up. Condition 1. Random. Yep. We randomly select our individuals. We randomly select the individuals for each group. Condition 2, we sample less than 10% of all pizzas or all spinach dips. So we sample less than 10%. Less than 10% of all spinach dips or pizzas are sampled. Condition 3, be careful. Condition 3, it's quantitative. That's the hint. And if you watch the conditions video, you might know them all. Pause. 100 points, Elizabeth. Pause. Condition 3, it's quantitative. We're comparing the scores of pizzas, the scores of spinach dips. We're comparing how long 2 different batteries last. Condition 3 is what? It's quantitative. It's not categorical. What is the third condition? 100 points first person. Who knows third condition? Nearly normal, Kate. Great job. 100 points right there. It's nearly normal because it's quantitative. Great job. 20 points right there. Needy, I think it was. So it's going to be nearly normal, which can encompass the large enough N. Now, here's the biggest thing. Did anyone watch my video going over this? I have a conditions video where I go over every condition for every test. So make sure you watch that video just to review, and you'll see when it's quantitative, we do the nearly normal. And so this has to be done for both groups now. Watch that video as a review. It goes over all of them and distinguishes when we use each one for which one. So the last condition here is there's a fourth condition. I was like between 3 and 4. And so the fourth condition is both groups are independent. What does this mean? So independent groups means that if you know information about one group, it tells you nothing about another. So let's think about this. If I know how good Cheddar's spinach dip is, would that tell me anything about how good the other spinach dip is? Like how good the tomato head spinach dip is? It wouldn't. That means they're independent. That means the score at Cheddar's does not depend on the score at Tomato Head. You'd be like, well, they're both spinach dips. Well, but you're not going to be like, oh, since Cheddar's was so good, well, then Tomato Head has to be so good. If you have dependent groups, it works like this. I always like to talk about like the show The Biggest Loser because I always thought it was unfair because like if you go to The Biggest Loser and you weigh 600-700 pounds, because some contestants have weighed quite a lot on The Biggest Loser and also lose weight healthy. I had a friend who's a dietitian and they had qualms with how Biggest Loser, like they'd be like, yeah, it's not really healthy because you got to find a lifestyle. Personal opinions aside, personal opinions with Brian. But if you look at someone's before weight and after weight on The Biggest Loser, yeah, exactly. I agree, Camden. Like you have to adjust and your body has to healthily make transitions. And it has to be lifestyle transitions, not just I'm going to stop eating transition or I'm going to work out 12 hours a day. And then when I get back to life, I'm only going to be able to work out 2. And I'm going to eat like I did when I was working. Because if you train, you can eat like crazy. Like Michael Phelps and them, gosh, they eat so much. Like I watched one time, like Michael Phelps eating breakfast. He ate like 10 eggs and like 3 sides of hash browns. They eat like 4,000 calories for breakfast. Just like shoveling in food, like the extreme athletes. So if you're on The Biggest Loser, you might be eating 2,000-3,000 calories a day, which is going to put you in a deficit because you're exercising and you're burning probably like 5,000-6,000 calories a day. Yeah, exactly, Camden. You'd eat maybe 4,000 because rowing is, man, I should start rowing. That's how to get really strong. So yeah, and then he just burns it because he needs fuel. He needs fuel. So I mean, it's fine to do if you're really working hard. So yeah, exactly. Yeah, like the big bodybuilders, they'll eat 5,000-6,000 calories. You coach it over age, like, yeah. I'd be so horrible at it. I don't know. I should I should buy a rowing machine when I go to Texas and like try to row like an hour or 2 a day. That'd probably be insane. But squats and deadlifts. The only thing I'm good at is like, you know what's really funny? I'm good at the pommel horse for like gymnastics. I took a gymnastics class and it was like the only thing I'm good at. So here's the thing. Let's do this. You ready? Brian is going to look at how good he is at the pommel horse. He's gonna have judges come in. Brian is going to have judges come in and they're gonna rate him at his pommel horse ability. That's the thing where you like prop yourself up and you use a lot of core strength to like so that's what I have, like core and chest. I don't know, my arms and legs. I don't know. It's like rowing I was not that good at. But so Brian's going to have judges judge him before he goes through pommel horse training and after he goes through pommel horse training. Does this sound like independent or dependent groups? He's going to have people judge him before at his pommel horse ability. There's going to be like 20 judges. So we're going to get an average score. Rowing is more legs. I might be able to do it. So judges are going to judge him before and after. Dependent or independent? Dependent or independent? The judges are going to judge him before at his pommel horse abilities. Very, very dependent. because Brian's abilities after training will depend on how good Brian was before. So when we look at my after score, just like with the Biggest Loser, to go back to that example, which I jumped for a second, the score of someone's weight after the Biggest Loser would depend on their weight before the Biggest Loser. So those are dependent. Your after weight on the Biggest Loser depends on your before weight. So we can't use this test for this. This is the wrong test. You actually want what's called a paired t-test, which is not that hard to do. We don't do it in the class, but you would want a paired t-test because it's paired with, like, this person's weight before is paired with this person's weight after. Brian's before score on the pommel horse is paired with his after score. They have dependency in them. Does that make sense when two things are dependent? Like, knowing how good Brian was at the pommel horse before would give you information about how good he'll be after. Knowing someone's weight when they start the Biggest Loser would give you information about their weight after. If you have, like, a lot of the women might be like 300 or 350, then you would have information that she might be 180, 170. Some of the men are like 500, 600. And it was just always like in the earlier seasons, like you always had like men winning the Biggest Loser because the men always came in heavier. So they always did like I think it was whoever lost the most weight, but the men had more weight to lose. Or even as a percent of their body, they could lose more. So I was always like, well, this is unfair because, I mean, it's like if you come in weighing more, you got more weight to lose. So it's like, yeah, does that make sense? It's just like, if you have more weight to lose, you can lose more weight. Oh, and it was, okay, this last little rant. They've just had some, like, I always felt bad when I watched it so much growing up. You'd get to like some of the final weeks and some of the people would be in such good shape that I was like, they need a different metric. Did anyone ever watch it and feel that way? Because like towards the final, you'd have people who were in like really awesome shape. Like they'd get like really strong. They'd be really fit. No, I'm just pretending. But, and then you'd be like, well, why are you losing weight now? Now you should just try to sustain. Now you should just try to, like, good, you reached a goal weight. Yeah. And I'd be like, change the metric. Change the game to the most fit. I don't know. Okay, Brian's rant's over. Rant on the rules of the Biggest Loser and how it's unfair. It's like if you're in good shape, you should win. So, okay. We have right here y bar 1 minus y bar 2. Kill me in the chat. I got beef with the Biggest Loser. I just, last aside on that. It's led to some unhealthy. There's no homework drops. Do all the homeworks. There's quiz drop. There's one quiz drop. We've already seen this formula right here, and I think everything is correct. I thought last semester there was an error. I don't think I see it. We have here the difference between the two sample means. Stresses me out too. We have the difference between the two sample means. The T right here. What is the T used for? I want everyone to tell me. 20 points, everybody. Lots of crazy points today. What does the T tell us about an interval? What does the T tell us? And what does the star mean? First off, what does the T tell us? It tells us what we are in the interval. Every T for an interval relates to this. Every T, you should know this. You feel like, it tells us what we are. We should know. It tells us who's going to get 100 points first person. It tells us what we are in the interval. The T tells us the what. For an interval, the T is related to the what? The T is related to the what? Confidence. Thomas right there, 100 points. Relates to the confidence. The T tells us how confident we are. So the T relates to a specific confidence level. So the T or the Z, depending on which interval we're doing, relates to our confidence level. The star means we get to pick it. The degrees of freedom, remember we just did this last week, the degrees of freedom tell us which T we are using. So whenever you have a T interval that you're building, you have to make sure you give it the right degrees of freedom. So you have to give every T its right degrees of freedom. Less degrees of freedom, more smashed down. More degrees of freedom, it rises up. The T is just like the Z, and the more degrees of freedom it has, the more normal it is. So here's where you see 1.96, but if it has less degrees of freedom, it won't be 1.96. So 1.96 is not always what this will be, but here's the thing. This T will often be close to it. Can you review how to define degrees of freedom? Yep. Good question. Let me show you. The review for degrees of freedom is as follows. Let me put in a slide right here. Here's what you need to know. So And I'm going to make it very specific for our test. Okay. So if you're doing the assignment, I'm going to... if you're doing the chi-squared assignment, you will need to know chi-squared. And so the degrees of freedom are as follows. Let me see. Let me unindent. Unindent. Okay. So for the t, it's n minus 1. So the t degrees of freedom equals, you got it, n minus 1. And then that's the t. And then 2 sample t. 2 sample t. Give me a second because I'm not writing this out. I've tried to memorize it and I just fail at memorizing it. Because I don't need to memorize it because I can just look at it. 2 sample t degrees of freedom. And it is... Here it is right here. Let me screenshot it. You'll never solve this formula ever. There you go. There's the 2 sample t degrees of freedom. There is the 2 sample t degrees of freedom. So if you can tell, the 1 sample t is much easier. Chi-squared, if you're doing the final assignment, so you do get 1 drop. I do suggest doing the chi-squared if you don't have all 100s. If you've gotten all 100s, then, yep, I would. If you've gotten all 100s, you don't have to do it. And it's not on the test. So that's a huge bonus. If you have grades that you're very good with, like maybe you got like a 98, 99 average, and you're like, I'm good, you don't have to do it. It's your present. And so congratulations. Yep, and we'll be doing it tomorrow, and I'll do the assignments. So I will do it. So I'm not, but it won't be on the test. Kate, congratulations, Kate, you just hit 3,000 points. Awesome job. She's like, I got it, I know it's happening. This one right here is equal to rows minus 1 times columns minus 1. So here are all the degrees of freedom. And what do they tell us? They tell us the specific distribution we are using within a family. A family just means like the t is a bunch of, like they're all different t distributions. They're like all hanging out. They're like, we're the t distributions. You're like, that's cool. And then chi-squared's like, we're the chi-squared distributions. You're like, that's cool too. So you can see right here, if we go and look at it, I should have kept that webpage open, but we go here and we go to stat distributions and we bring it back over here so you can see it. If on stat distributions, you go here and you click chi-square, you can see chi-squared has it with it degrees of freedom. Things like the normal do not have degrees of freedom. There's no degrees of freedom over here. T has degrees of freedom, and when you change it, it changes the way it looks. Just like chi-squared, when you change the degrees of freedom here, it changes the way it looks. There's one more. We don't have it in this class at all, but here's the F, and it has 2 degrees of freedom. It has a numerator and denominator degrees of freedom, and what does it do? It changes the way it looks. These are all Fs. If I change the distribution here, the degrees of freedom, it changes the way it looks, just like our T. You change the degrees of freedom, it changes the way the T looks, but it's still a T, and we say it's all within the T family. Does everyone have a decent understanding, like, what degrees of freedom are? They're what control basically how the distribution look, and then they're all within a family. Does that help clear up, like, what degrees of freedom are? They tell us which distribution we are using within a family, and then there's a formula for each one. You'll just have to use the applets and stuff like that, and you should have memorized n-1. So the only one you have to memorize is the 1 sample t. Oh, no. 1 sample t is n-1. So that's the only one you have to memorize. And then rows minus 1 times columns minus 1, you can use that still, but I would memorize n-1. And it's on the cheat sheet too for the test. But this formula right here, this formula, let me show where it's on the slides. Yep, right here. Perfect. So you can go to this webpage right here, and we should be able to open it. Cool, it opened. And let me bring it to the sizing the screen up. So if you look at this webpage right here, what it asks you to enter, this webpage asks you to enter in sample size 1, sample size 2, standard deviation 1, standard deviation 2. Do you remember that formula? The formula you just saw literally has sample size 1, sample size 2, sample size 1, sample size 2, N1, N1, N2, N2, N1, N2. And then look at what this webpage has you enter in. It has you enter in all of those things right here, so you don't need to solve it by hand. So if it asks you the degrees of freedom, you don't need to solve it by hand, but Brian's going to do it in his head. I'm going to get this down to 8 decimal place accurate. You ready? The answer to this question is going to be... Here's the degrees of freedom down to 8 decimals. I put it in the chat. And watch as we click, and there's the answer. It's a trick. Because if the 2 sample t has the same sample size and the same standard deviations, then what formula did Brian solve in his head? Can you see the formula I solved? Who here for 100 points can solve what the degrees of freedom are for this test now? What are the degrees of freedom for this test? This is a trick. You're about to walk out. You're close. It's not n-1. It's kind of like you'd have to write close, Camden, close. Camden, I'm giving you 100 points. Good guess. Good guess. You're on the right track. But remember, I had 50 and 50 in there before. I had 50 for N1 and 50 for N2, and it was 98. So what will this be? Who's got it for 100 points? When I solve this, what will this be? Wait, just to review, this solved out to 98. Great job, Skylar. You got it, Skylar. It's the total sample size minus 2. But this only happens. This is the highest the degrees of freedom can be. So it's kind of a don't think of it being n-2 or total n-2. That's only in the circumstance when you have the same sample sizes and you have the same standard deviations. Now you see it's not. Now look at it, it's 198, which is way different. So 198 is nowhere near 298. So it's kind of interesting it came out to 198. You might say, oh, it's going to be 248. No, that's nowhere near 248. So you have to use this applet a lot of times. Kind of, yep. And actually, that's what it is for a paired t. If it's a paired t, it's n-2. But we're not doing paired t. So don't listen to what I said about paired t. I don't do that test every day. But the highest it can be is n-2. So you have to go to this applet, though. Please remember this applet. It is in the notes, and you have to use this applet. A lot of times it'll solve out to like decimal numbers. As you can see right here in the bottom of our output, this is the degrees of freedom for the t distribution. It solves it out for me in jump. Yep, basically that's Hannah, 100 points, Hannah. Yep, that's only in the circumstance when the sample sizes are equal and the standard deviations are equal. Only in that circumstance does it actually work out that way. It's a rare circumstance, but it's kind of cool because it's n-2 then. But that's, it's like, oh, that's the highest it can be. So, and then it diverges from it. Here we are with more output. We're almost done with the lecture. We've done a great job because we've kind of done it. So when you notice this right here, what do you see right here in this interval? I might have to zoom in a bit. Let's zoom into this output. This is your friend selling you a camera versus a stranger selling you a camera. This is your friend selling you a camera versus a stranger selling you a camera, as I try to get it nice and neat on the screen right here. Your friend selling you a camera versus a stranger selling you a camera. Who offered you more money, your friend or the stranger? Who offered you more money, the friend or the stranger? Just look at it visually. Who offered you more money, the friends or the strangers? The friends. So with this in mind right here, this difference of 70, take a look, be careful. This is where people get tricked on the test. This is a big learning objective. Stranger minus friend. I want you to do this math in your head. Ready? Really? Do this math in your head right here. Let's do 270 minus 200. What is 270 minus 200? 270 minus 200 would be what? 70. What is 200 minus 270? What is 200 minus 270? 20 points, everyone answering right there. What is 200 minus 270? Negative 70. This is stranger. So everyone see, yeah, it doesn't like when I do that. This is stranger minus friend. So we're taking the stranger mean, which is, that's the median, but the median is the line in the middle of it, but median mean's probably around there somewhere. And we're subtracting from it the friend mean. Do you see how the friend mean is higher? So this difference right here, what does this tell us? Here's a trick. If it's negative, it's connected to the second amount, meaning that friends on average offered us $7.45 more. Does that make sense? We can look at our output from jump. I think I can show that on the screen pretty easily. What does this difference right here, since it's positive, tell us? Which group was higher since the difference is positive? Who here can interpret this difference between the pepperoni and the non-pepperoni pizzas and tell us what it means since the difference here was positive? The difference here is positive between yes minus no, so which group was higher? Which group had a higher sample mean when people tried these pizzas? The which group? The yes is higher by 2.2 points. In our sample, we saw that the pepperoni group had a mean, careful, these are medians right here. The pepperoni group had a mean that was 2.2 points higher than the no group. Does that make sense? That's all we're doing. And then this standard error right here is just the S sub 1 over n, S sub 1 squared over, full crazy formula. The difference is so the difference what we just saw here is the difference between the average asking price that a friend will give us for a camera versus a stranger. The differences here are the differences in the scores people gave a pepperoni pizza versus a non-pepperoni. The difference between the means. Like we have a sample mean for yes, and that looks to be at about, it's kind of really close to there, about 7. And then we have a sample mean for no, it's about 4.8. Will it show the mean? Dang, it doesn't show the mean. It's 5-number summary. So these are our no pizzas had a mean of about 4.8, and our yes pizzas had a mean of about 7. And the differences between those was 2.2, that the yes group had a mean that was 2.2 points higher on average. The differences between the means, like the average pepperoni pizza was 2.2 points higher than the average non-pepperoni pizza. It doesn't mean all of them were higher, because we do have some really good cheese pizzas or non-pepperoni pizzas, but on average, they were 2.2 points higher. And on average, our friends offer us $70.4 more. It's just the difference between the sample means. So if you want to write that down, the difference between the sample means is how we would call it. And in notation, remember, you should know instantaneously that this difference right here is y bar 1 minus y bar 2. You should know that instantaneously that difference is the difference in the sample means. Like every time I keep saying it's the difference in the sample means, we know it right here, that this is the difference right here. Does that make sense? It's just the difference we observe between the two sample means. And the standard error is just I'll write the formula out again. The standard error is the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. And so can anyone write the formula to get the t statistic? Who here can write the formula to get the t statistic from this output? We've definitely put this on the test. Who here can write the formula to get the t statistic? Who here can write the formula to get the t statistic? There we go. How do you know which one to subtract from the other? You call this like group 1. Good question there, Camden. You call this like this is the first and this is the second. So in truth, really good question, Cameron. 100 points. In this problem, this would be the mean for stranger minus the mean for friend. And you could reverse it, but so it's just you can call it 1, 2, SF. So who has the formula for the t right here? That's how we get the degrees of freedom. So the degrees of freedom are n minus 1. Oh, no, that's only for a 1 sample t. This is a 2 sample t. Since this is a 2 sample t, it's the complicated formula that we don't solve by hand. How do we solve for the t statistic? Yes, Kate, you are right. Kate, 100 points. And then solve with the numbers. So Kate wrote it out right here with y bar 1 minus y bar 2. And look, wait a minute. If this is what we're doing, then aren't we just taking the difference and dividing by the standard error? So wait a minute. This is the difference. This is the standard error. So can anyone solve it mathematically for me? Who can solve it to like 4 decimals? Yes, Josh, you are right. Josh, you got it. It's just you take the difference, you divide by the standard error. That's what it equals. There you go right there. That's it. It's just right there next to it. There's the t ratio. It's just think of it, t ratio. It's the ratio of your difference to the standardizing metric. Does that make sense when I say the t ratio? It's just the ratio of your difference to your standardizing metric. So that's guy right there. 100 points, all those answers in the chat. Following along. Love it. We have here the confidence interval. Now, the degrees of freedom here are very small. So what is Brian going to do with these degrees of freedom? He's going to go where? Where will Brian immediately go with these degrees of freedom? To the t-applet. To the t-applet. So let's go here to stat distributions, t-applet, and let's put it back on the screen. Okay, so I'm going to have to zoom in a good bit here. I'm going to put in 7.6 or whatever it was. What was it? 7.622. So we put in the degrees of freedom, and then we're building a 90, not today, my Pearson, 100 points right there. So this T statistic right here is the T Brian will use to make a what % confidence interval. This is the T Brian will use. Same thing on the screen still. Does everyone see this? This T right here will be used to make a confidence interval. This T I'm highlighting is not this T right here. That's a T ratio done from a test. This T is the T used to make a 95% confidence interval. Does that make sense to everybody? That's where people make mistakes usually, is they think, oh, wait, this is a T ratio right here. That's a T ratio, but that's the difference standardized. That's a T test. The T for the confidence interval is picked based on the confidence level. I could change this, and I could go to like a 98% confidence interval. Now the T is basically 3. I could go to a 90% confidence interval. Now it's 1.895. But does this make sense that this confidence level tells us the T we will use for the T confidence interval? And it's based on the degrees of freedom. That kind of tells us what T we're using and the confidence level. So do not think that this T right here, I'll see so many students plug that in for their T confidence interval. No, don't do that. Don't do that. Okay, so the T is 2.365. So here's what I'm going to do. I'm going to solve this by hand. So I figured out the T is 2.365. So I think we have it right here. Oh, we almost have it. New slide. Okay. So what do we need? We need y bar 1. And so let's say sample mean 1. Sample mean 2. And then standard error, which someone has to find, and then T. So my T was 2.365. My standard error is 18.71. It just says standard error, so we're taking that. And then right here, we could just do the difference. Equals y1 minus y. Let's write it. We'll just write it in abbreviation form because it'll be too long. Sample means 1 minus sample mean 2. It's going to be easier if I do this. I want to make sure people know exactly what we're doing right here, so I'm going to do it the following way. Okay. Can I do this? There we go. Okay. And then, so let's write it this way. You ready? We got y. Really? It's trolling me today, everybody. Y bar 1, y bar 2 equals, I don't think we know what these are equal to. Let's see here. Can we do chapter? You got it. You got it. We definitely can. We're definitely going to do that. And the difference right here is equal to this. And that is equal to negative 70.45. So then the T interval is, you got it. Chapter 16 is easy. Yep. It's not that bad. And then, so this is y bar 1 minus y bar 2 plus or minus the T statistic. And then we do the standard error. And that's standard error. Cool. And then we just solve. Negative 70 plus or minus 2.365 times, was it 18.71? So right here, let's take a look and let's just see if we get the same numbers. We're just going to solve for the top one, or we could solve for either. So 18.71 times 2.365. What did I just find? 100 points. Who can tell me Brian just solved what? He times together these two numbers right here. Brian just solved what by timesing them? If you're following along, what did I just get? And you get the T from the difference. This T right here had to be found via the applet. This is the T for the confidence level. This is the T for the confidence level. What is, Brian? I've highlighted what I solved. What did I just solve for? I just solved for the what for this interval. I've highlighted what it is. Like, I've got the number above it, but it's everything after the plus or minus. What did I just solve for? Anybody know? It's everything after the plus or minus. Not this. Yes, Isaac, right. Margin of error. Isaac, 50 points. Everyone else, Isaac, 100 right there. That is the margin of error. Does everyone see it? That is a plus or minus. So it is the margin of error. So that is the margin of error because it's after the plus or minus. The difference is the first part, and then the margin of error is the plus or minus. So I just solved for the margin of error of the interval. So that is the margin of error of the interval. I'm going to just type this in as 70.45. I'm going to add to this, and we get 114, and it's very close. It's just that jump is more decimal place accurate. So we see this right here. Jump's just carrying more decimals in the background that we don't see. Yep, and t times the standard error is the margin of error. Nice job right there, Jack. 50 points. Great job. And let's see here. There's just more mathematics. They're showing you just how to do it by plugging in. Here's how to go to an applet. This is how I found my answer. I just used a slightly different applet. So if you see, this is where I'm finding my answer of 2.365. And you have to go in, you have to put in the degrees of freedom, and then you have to put it into here. Some of them are more exact. I think lowercase technically. I think I might have capitalized it. Great question. Camden, 50 points. Amazing questions. So I should just let them solve it right here. And I think that applet might have calculated it more exactly. And then we'd have to see how their decimals go. But this is why we let Jump do it a lot of times. More examples showing how to do it in Jump, which we did. Conditions. And just more examples. This is the whole chapter. Here's the t-test, which we talked about. What is this for 100 points? What is this usually equal to? It says it on the notes anyways. It's just the difference over the standard error. That's all this is the difference over the standard error. 0, 100 points, Morgan, right there. You're right. And you know what's interesting? I wish I could reorder this. You know what I'm going to do? Watch this. If I take this up here, and if I reorder it, watch this. I'm going to start snipping this and reordering it. We're going to take this. We're going to plug this in here. Okay, we take that. We're going to take this. What am I building? What have I built right here by just reordering it? What did we build? Done. What did I build by reordering it? Up top, you have the t-test. Down below, you have the what? So up top, I have the t-test. And down below, I have the... Does everyone see how, like, tests and confidence intervals are virtually identical? But one thing I keep wanting to point out here is that this t and this t are not the same. Because this t down below has the star, you're picking it based on the confidence level. We don't, on the test, we don't pick the t. We solve for it. On the t-test, you don't pick the t, you solve for it because you find the difference standardized. On the confidence interval, you pick the t based on your level of confidence. So when you do a confidence interval, you say, I want to be this % confidence, and then that tells you the t. But on the test, you literally don't get to pick anything related to the t. It's just, what is the difference? Standardized. Every time you do a t-test, you will come to the same t if you're doing the same test. When you make confidence intervals, you can change what the confidence interval is and what the t is based on the level of confidence. That's why we often put a star on it to say, you can pick a 90%, 95%, 98%, and then your t will get wider. Who thinks they understand right now the difference that these are not the same, that you will look up your t based on a level of confidence when you build a t interval? You'll say, I want a 90%, and then that will be your t. I want an 80%, and then that will be your t. But when you do the t-test, you do not pick it. You do not pick it. It is literally just the difference standardized. You look at the results right here, and you say, okay, we take this number here, and we divide it by the standard error. So you take 2.21867, you divide it by this right here, and then there's the t. If you look, that number right there is the t, With conference rules, you pick your T. With test, you solve for T. Boom, Camden right there. Camden, 50 points. Amazing notes in the chat, Camden. Yeah, I see a lot of people get confused on that because what people will do is they'll take this T right here and then they'll plug it in to this interval. So they'll take the T that they solve for in the test. No, there's no cap. Camden, you've done an amazing job. Great job. Just that's what it. Camden, everyone's done great today, but Camden, you get another 100 points for being an all-star. Because I love those comments. I love those questions. And you know, like you were pretty much right most of all of class, but every once in a while I'd be like, no, it's more like this. And that's the conversation we should be having, because then you're like questioning things and being like, wait, is it more like this? More like this? And then so you've done exactly what I've asked for. So thank you, Camden, and thank you everyone else. Everyone's been great, but just nice work. I want people to know, like, this is what the class is all about. I'm right about to start a new class. If you guys want to come into class, if you see me live on Thursday morning, you are welcome to come into class and say hey. You know I'll say hey to you. You saw people do it from last semester. Drop by Thursday morning or Friday morning. Your buddy's like, Brian, I'm sleeping in. Brian, I'm in another class. So I have class 8 till, I got an 8 till 9:30 and then 9:45 to 11:15. Yeah, swing by, say hey, Devin. Like, be like, hey, what's up, Brian? I'll be like, hey, what's up, Devin? I'll be like, Devin will tell you, talk in chat. Because my goal first day with them, I think we've pretty much covered everything here because it's literally just more examples. So we'll do more examples. One thing we should mention, let me mention one last thing right here. This right here, when you write your alternative, let me cover that again real quick. You'll show off your, yeah, do it. I've got to delete other people's points. So, I have to make a new points thing. Not deleting your points. Not yet. If you take another class with me, I'll have to delete them and start you over. You're like, no, not my points. Don't take away my points. I don't want to take a class to you now, Brian. My points are too valuable to me. I guess I could write down how many points you have and then go from there. Maybe, I don't know. I'll be like, yeah, put a note. Like, so-and-so has so many points. You want to keep them, Ben? Yeah, Ben. Ben, I can do that. And then we'll just have to write down how many points you have. So, Ben, you can keep yours. And I can be like, Ben, you can show off your points and be like, look. And so I've got, if you look at the syllabus, Ben, which do I still have that up? I actually put it literally in the syllabus. So you guys are helping me a lot. Like, I always grow and change what I do. So here's what they have. Here's the new, what do you guys think about this point system? And then we'll start doing practice stuff. This is their point system. Oh, Camden. Well, Camden, I'm always here to help out. And you can always swing by and say, hey. What do you guys think about this point system right here? I know I put a crazy amount. And then what I'll do at the end of the semester is I'll just like scale it to this. Like I'll do some if else statements in R and I'll download it. And then I can figure out exactly how many points people get. Well, no, the 10,000 points is meant to be ridiculous. So you guys had a totally different scale. And so my goal is that people get to like 3,000 points. But then your guys' point system goes up to, I think it's 2.5. So and then 3 is 4,000 points, I think we said. So your guys has a cap, and then I'll just kind of, I hate being subjective. I want there to be no cap, and the 10,000 is like a ridiculous cap. And I always go crazy at the end of the semester and give off crazy points. But I always say it's because I want you to be here at the end. If you're here at the end of the semester, then like, and there should be no cap. No, it's 2.5. Double check. If you see me in a video, if you can send me in a video where I said 3 is 3,000, send it to me, but I'm pretty sure it's 2.5. Is it? Because I thought it was 2.5. No, 2 is 2,000. No, wait, no, it is, wasn't it? Wait a minute. I think you guys are right. I think I said 1,000, right? Thank you guys. Once again, we reject the null. Brian is wrong. Sorry, my brain is flipping. No, you guys are totally right. Let me show you guys your point system again. Everyone's right. Brian's very, very wrong. That's the name of the game. No, I do remember now. It's just I've been like getting this class ready, and your guys' point system is now. If you are watching this from another class, this is not your point system. Your guys' point system is the following. Everybody is very correct. These are the point systems. This is the point system. That is the point system. So this is it right here. No, Ben, you're totally right. Ben, you're totally right. Ben, 100% right. Sorry, and I'm glad we kind of talked about this because I'm setting up the other class and like, just a lot. And then the best thing to do is to have it. So this is your guys' point system. And then I just kind of look at it and think, and I did go a little crazy at the end here, but this is a major bump to everyone's grades. So this right here via your participation, which that's what makes the class. You get the 3 points. I hate subjective stuff, so I hate being like, but it's good to get a bunch of points. It doesn't hurt. Like, the more borderline you are, if you have more points, the nicer I can be. So how do you earn points? Just watch live, just curious? Yeah, that's it. That's what you watch live, you interact. And I'm going to like hold my feet to the flame that like the first week, what I'll do? I'll set a thing that during class live, the first week you can earn up to like 20 points. And the first week you can earn 20 points live every class by answering questions. The second week you can earn 40 points. The next week you can earn 50 points. And the final week you can earn like 100 points each day by answering questions live. So it becomes more and more valuable for me to give you points. And I'll probably do it like that. Maybe it'll be easier to track and stuff. And then I won't give away crazy points that break the scale. I'll keep ruining my own rules in my own game. But yeah. I hope you guys found it fun, the extra credit system. So yeah, keeping some sort of track of it. That's all good right there. So yeah, let me revert this back. This is their point system, not your point system. But I tried to put an upper limit on it because usually I just do 2 points. And my goal is usually during the semester, extra fun. Oh, that's awesome. Yep, that's why I like Alyssa. That's it. And Tyler, you're right there, Tyler. You got it, man. Remember, we got class tomorrow. You're going to get it, Tyler. You got it, Tyler. You're going to get it. Nice job. And the more people I can get to interact and do this and be part of it, like, do you guys feel like you know some people in chat right now? Do you guys feel like that? Let me load up the homework. We'll load up chapter 17 homework. So we'll do chapter 17 homework right now. Boy fun. Let me see here. Can I? Oh, I can get my lemonade. It's unfrozen. Okay, 2 seconds. I just know if I have it over, I'm gonna knock it over on my computer. I know it's nice. Like it's just chill. Sarah B and your buds. Oh man, like we've had people in the. Did you guys like? It's like I'm really glad. And I'm also thinking of. Let me give you one last thing while I load this up. I'm thinking of making, and I should get this done this summer. A Stat 201 Discord. A Stat 201 Discord. And we definitely have to have mods and stuff because we don't want like craziness. But I think there's group me's for Stat 201. But I was thinking we should have something more official, like a Stat 201 Discord. And there could be like a tutoring thing on it. Like that'd probably be better and easier. And like people could post that they need tutoring. And so if we did a Stat 201 Discord, there could be like, we could even have like a tutoring channel where people could be like helping out. But I think maybe I'll talk to Tim Connor. I always get it wrong. Because I see Tim when I look at his name in the grade book. But I'll talk to Connor. He might have some stuff on that. But if we had like a Stat 201 Discord and people could like talk there and get to know each other and help out and all that stuff. But I don't know what you guys think of that. Get stat bots that gives you formulas and help on homeworks and quizzes. What's stat bots? Never. Oh, that's awesome. Thank you. She asked if you were TikTok famous yet. Discord is basically like group me and all that stuff. That's awesome, Camden. So yeah, we gotta do this TikTok stuff. I gotta start looking into that. I gotta come up with some TikTok ideas. Yeah, I could start doing that. We're gonna do chapter 17 right now, and then we'll hop into some chapter 16. So we'll do chapter 17 homework, then we'll do chapter 16 homework. Just to kind of connect it to the thing we just did, as I get just the hiccups here. Hiccups live on stream. So let's do some chapter 17. It's good. I tell you, drink some sugar and you just get some energy. It's the way it goes. Chapter 17, homework. Replace questions. Only 4 questions. We can learn how to do the Chapter 17 homework. Okay, let's do it. Let's knock out this Chapter 17 homework. Do the Carol Baskins. I don't know what that is. I don't know what that is. I'm old. You know, it's fun to joke that I'm old, and then like 5 years from now, it won't be fun. It's like, it's fun, and then it's not fun. Is that like from The Office or something? You guys will have to tell me which show that's from. I know the name. Oh wait, no, that's from Tiger King, right? There we go. Because I've heard the name enough. You feel just turned 21. I know Chelsea and I are gonna watch Tiger King, so we're waiting. I've got over 1 month till I can be on the Tiger King fad, till I can understand, and I'll be like, oh my god, it's so crazy. And then you guys will be like, Brian, Tiger King is so start of summer, not end of summer. Like I recognize the name after thinking about it well. Yep. UT has been completely awesome, and like we're building. So what I have right now is really great, but what I'm going to do in Texas right now, I broadcast out of a 1-bedroom apartment, and in Texas, I'll actually have a room for it. So in Texas, one of the rooms will be dedicated to the studio, and I actually want to have a 2-camera setup. And so you'll see even more cool stuff, and I'll have like come in, check it out, and be like, what's going on with Stat Nation? Yeah, it's gonna be like a gaming room. So it's gonna be like literally like if you watch one of the streamers on stream, I might even cut to where I'm not green screening because I kind of want to do like some lighting and stuff. Yep. Oh, I like that reaction right there, Devin. Are you taking 320 with me? So Devin's reaction is like, yes, that's awesome. I love it right there. I like being like, yeah, that's awesome. So I like that people are hyped about it. Yeah, that's awesome, Devin. Yep. And it'll be even better. Like we're just improving it. So if you liked this, gonna be even better. Yep. Since you dropped some noting quizzes, if people missed, can there be bonus if we never missed one? I might look at it and be like, you've done well. Like I can't say how much it'll be worth. There's a lot of bonus in the class. So and knock out my whole bit. Yeah. That's awesome. Yeah. 201, 324, 74, knock it out. Just take the and Devin, have you seen, let me do one last thing here, Devin, then we'll start doing the assignment. I am teaching it online. Yep. Online. And then don't worry. Ben's probably seen it, and Devin, you may have seen it. I'm making a bunch of videos for how to do things inside of R, and I'm taking a lot of requests, and I'm trying to make like a video a day. So if you watch those videos, you'll learn how to do a lot of the simple things. And I'm making like 1-minute videos. So they're really quick and they're really pinpoint. So if you're using those, you should get set up. Yeah. Awesome. Yeah, so Devin, if you want, I'll send you that playlist. And if you want to get R installed, if you start working a little bit in R this summer, you'll be way ahead of the game. Like you'll go into class day 1 and you'll be like, this is easy. You'll go through the first week, you'll be like, this is still easy. And by the time we get to like the 3rd or 4th week, you'll be like, it's not so bad. And everyone else will be like, oh my gosh, we're doing so much. And you'll be like, I learned it. You got it, Devin. You ready for this conference roll stuff right here? Let's do it. Yep. Over Christmas break, yep. Good deal. Oh, so you're taking it in the spring. Cool. I like it. A study examines the fat content in grams for samples of beef and meat hot dogs. Aren't those the same thing? The resulting 94% conference roll of beef minus meat. Okay, wait a minute. So what did they collect? They collected a mean for beef and a mean for meat, and they're trying to investigate the true difference. Does that make sense? Like, I want us to envision this. I want us to actually see this going on. They went and they collected, here we go. They collected a bunch of hot dogs, and they looked at the fat content. So they collected these packs of hot dogs. They have beef and they have meat. And so then they collected all these hot dogs, and then they looked at the fat content for these. Does that make sense? Does everyone understand? Oh, it does? Matthew, 100 points. I never knew that. I've done this problem a million times, more like probably a couple hundred, but I never knew that. That's crazy. Like, just didn't know that. So when you look at this interval right here, this interval is when we take the mean for beef, minus the mean for meat. I want to try an Impossible Burger. You have to tell us about that, Camden. I've heard it's just as good, and everyone's like, you really can't tell the difference. Some people like it more. So I want to try the Impossible Burger. Yeah, don't eat red meat. I should eat less red meat. So I think we're doing meat minus beef. I think we're doing meat minus beef. And the interval here is positive. Imagine if we had a sample mean from this. So we have sample mean 1 minus sample mean 2. And what if this was 10 minus 6? What would be at the center of your interval right here? Oh, I'm sorry, Nikki. Let me make you a mod too, Nikki. Aw. Well, thank you guys. You can always watch my classes. You can always join in. I need to get Beyond Burger, people are saying. I'll get Beyond Burger, Skylar. The difference between these two, well, be careful. This isn't the interval. I think, Hannah, good job, 50 points right there. This isn't the interval. This is what we use to solve the interval, is that this is the difference between the two sample means. Does that make sense, Hannah? That this is the difference between the two sample means. So we observe a difference between the two means of 4. Think about this in context. The meat hot dogs had 4 more grams of hot dogs than the beef, had 4 more grams of fat. Does that make sense? The meat hot dogs had 4 more grams of fat than the beef hot dogs. Does that make sense? So you're not doing this as an interval down below. You're saying what's the difference between the two sample means, just with what I've drawn right here. Does that make sense? If you do an interval, which you can do, your interval might be something like this. Can anyone look at this interval here? And what is at the very center of my interval? What number is in the middle of my interval right now? What number is at the very middle of my interval? Drawing something else for the moment. What number? You got it. And that's what the difference was. Do you see how the difference between these was 4? Does that make sense? And I guess let me change this because I don't want to make it confusing. Don't look at the margin of error yet because I think it could confuse you. The difference is still 4. What is the margin of error of my interval? What is the margin of error of my interval? So what is the margin of error of this interval now? The one, let me highlight it because I changed it. What is the margin of error of this interval? Because this is my interval to estimate the true difference between them. The margin of error of it is, careful, remember half the length, 50.7 right there, half the length of the interval is the margin of error. So what's the margin of error? The margin of error, this interval could be written out as, yep. The margin of error is half the length of the interval. Does that make sense to everybody? The margin of error is half the length of the interval. The margin of error is half the length of the interval. Does that make sense, Camden? How are we doing on that? The margin of error is half the length of the interval. Which part are you confused on? Is it finding the margin of error? So here, I'll explain. I'll kind of walk through what happened in this problem here again. We went and we sampled meat hot dogs. And when we tried the meat hot dogs, we found that they had, on average, 10 grams of fat. This is just kind of a made-up version of what we're seeing. I'm just kind of making it up. Like, we tested the hot dogs, the meat hot dogs. They had 10 grams of fat. We tested the beef hot dogs. They had 6 grams of fat. The difference between them is 4. So that's the difference between them, which is at the center of our interval right here. So the difference between them is 10 minus 6, which is 4. And so now we can see this is the interval that we made. The software gave us an interval of this. We're just saying the software gave it to us. So the mean of the interval was 4, because that's at the center. But then the margin of error is plus or minus 3. And then Camden, I'll do yours right here. We'll do your problem. My interval being completely positive means what had more fat in it, the beef or the meat? Which of these had more fat if the interval is positive? This is the interval. Yep, this is the interval. What my Pearson gives you is this down here. They give you this right here. So since my interval is positive, which one, the beef or the meat? The beef, because it'd be big number minus small number. Hopefully I didn't reverse it. So the mean for fat content is probably higher for beef. If your interval is negative, then which one is higher? If the interval contains 0, Devin. If the interval contains 0. If the interval contains 0, is that your interval? So with Camden's interval right here, Does everyone notice how 0 is in Camden, another 50 points? Camden has 0 in their interval. So 0 might be the difference. So since 0 is in Camden's interval, then we would say the type of hot dog with the higher mean cannot be determined. Because it might be for Camden's interval that maybe meat has a higher mean or beef. So the negative would be that meat could have a higher mean by 3.8, or beef could have a higher. Jack's interval also contains 0. So think about this. You might be saying, well, there might be no difference between these. So, and you have the same number as me. If you have the same numbers as me, then the interval is positive, so beef is higher. So we would think that beef is higher. Does that make sense? And if your interval contains 0, it cannot be determined. If your interval is negative, then meat is higher. For Camden, for yours, it cannot be determined. It cannot be determined because 0 is contained in the interval. Think about this. You're saying, well, show me your interval, Hannah. Let me see your interval. Is it... put your interval in the chat and I'll make sure if it goes from what to what. And then I'll make sure we get the right answer on it. You might say it's the same as someone else's, and I might have been... Oh, you have the exact same as me? The mean content is probably higher for beef. That should be right here. Not today, my Pearson. Not today. Good. So just make sure they put beef first. Yours might say meat minus beef. Does yours say meat minus beef? I don't know if they switched that. Does yours say... If yours says meat minus beef, then it'll be higher for meat because meat's the first one. They might have reversed it to say meat minus beef. If it says meat minus beef, then the interval being positive would mean meat is higher. Sorry about that. Yeah, I was like, and so they tricked you because they switched the way they subtracted the two. So yeah, sorry about that. I didn't know they do that. I don't look at that. Yeah, no, I've done this problem a lot, but then I don't remember like which order it goes. All good. 50 points, Hannah. Thank you very much. What does it mean that 0 is not contained? So since 0 is not contained, there is a difference in the two sample means. It's significant. Because if 0 is in the interval, then we think 0 could be the difference. If 0 is in the interval, it's like, well, maybe 0 is the difference. If yours, show me your interval, Joseph. Yours is meat minus beef. So if it's negative, and remember, if it's negative, that means the second one was bigger. So if it's negative, that means the second one was bigger. Does that make sense? If the interval is completely negative, that means we think the second mean might be bigger. Yep. So Joseph, yours, you would think that meat has probably more fat because do something like 4 minus 10. 4 minus 10 is negative. So that would mean the second number is bigger. Like 4 minus 10 is negative. Does that make sense? The second number is bigger when you do 4 minus 10, and it makes a negative number when you solve it. So you would think that this would be, the second number would be bigger. And so hopefully that makes sense. It's a little tricky. And then what is our alpha level? Who knows this? I need help. I'm gonna jam out to some music. You guys know me just jamming out to music. What's up, Alex? Alex, so good to see you. Alex is here from last semester. We have so many people gotten so many points, Alex. Alex, do you remember how to find the alpha level for a 94% confidence roll? Oh, Alex, you got to help out. We need the right answer in the chat. Alex, we got music in the stream now. We got music. We got some Mega Man. I can just play some music. Oh, Neelan's got it. And if we put that to a percentage, we'll go right here. Alex, wait, Alex, you were online the first semester on this, not last semester. Alex is from first semester. So good to see you, Alex. How's everything going this summer, Alex? We got some more confidence roll stuff right here. I know you should, if you want, you could be a tutor again next semester. How do we find that? How do we find that? How did we get that? Neelan, how did we do this? It was a 94% confidence roll. 94% confidence roll. Space pen. Oh, wait, I just wrote the same thing. There we go. Yep. You guys are awesome. Is that making sense right there? Good stuff. Does that make sense? It's 1 minus the confidence interval, whatever it is. Like I should write level right there. Like whatever your confidence level is, you'll do that. There we go. And then put it as a percent, but put it as a percentage though. So Hannah, put it as a percentage because it wants it as a percentage. Yep. And so everyone should be doing fine on that. Does everyone? Yep, you got it. You got it. It's related at a 5% alpha level. It's 0.05 alpha or 5%. Yep. Good job. Look at this. We're crushing the assignments. We're going to get this done here. How do we find, can anyone do the formula right here to find the margin of error? We get the upper and the lower. Yep. Great job, Jack. Who here knows the formula? Remember, what is the formula? What is the formula? I know. Not today, my Pearson. Not today. What is the formula right here? Yes, Morgan, you're right. It's upper minus lower divided by 2. Be careful. It's a negative number, so you have to actually do plus. So you do this, upper plus. You're saying, why are you doing plus, Brian? Because it's minus minus. So since it's upper minus lower divided by 2, it's a negative number for the lower. So we have to do this right here. And then look at it and be like, are those about, plus or minus 3? And they are. So once again, this was upper minus lower, but be careful because the lower is negative. So since the lower is negative, it's actually, does that make sense to everybody? It'd be 4.362 because it's half the length of the interval. Good question, Thomas, right there. The margin of error is half the length of the interval. So when you do it, you're saying this is your interval and you just want half the length of it. So if you're wanting this right here, the margin of error, you're going to go and you're going to take where the upper is at, where the lower is at. You're going to get their difference, like how far are they apart. So you do upper minus lower, and then you want half of that difference, and that is equal to the margin of error. So that's how we get it right there. Does that make sense, Thomas? We take half the length of the interval. The margin of error is the plus or minus on it. If you divide the two numbers, if you do this right here, what do you get? Who here for 100 points can tell me what this is? What does this solve out to if you average the two numbers? Like if you take the two numbers and kind of average them out, you get what will this equal? If you divide the two numbers together. Not the margin of error. Kind of. It's kind of the mean. That's the center of the interval. So the upper plus the lower divided by 2 is the average of the two numbers, which is the very center of the interval. Does that make sense that that'll be the center of the interval because you're just averaging the two numbers together? You could look at our previous example. If you did that formula on this interval, what would you get? 1 and 7 added together are 8, and you average them and you get 4, which is what the difference between the means were. So the center of this interval is 4. 1 plus 7 equals 8, divided by 2 equals 4. So you get the average of the center of the interval. So 4 is the center of this interval. And if you notice right here, here's the center of the interval plus or minus the margin of error, and you can see 4 plus or minus 3. So just kind of look at this interval here and think about how the mathematics works that we just drew out to solve for either the center or the margin of error. So the margin of error is the upper minus lower divided by 2, which is just half the length of the interval. And then the center is the average. Wait, so I did the upper minus lower. Just make sure if you do when you're doing the minus that you're adding it. It's weird that you say you have to add it, but it's because it's negative. So did you do something like 4 plus 1? Make sure you do plus and then divide by 2. I know you're like, it's like, well, wait, why am I adding it? It's because it's a minus minus. Because it's upper, and then, so it'd be plus 3.757. So it'd be 2.157 plus 3.757. Because in truth, what you're actually solving, Camden, is going to be, let me write what you're actually solving. You're actually solving this right here. But because it's minus minus, that will turn into that right there. Does that make sense? Because you're doing 2.1757, whatever it is, minus minus 3.757. So the minus minus turns into a plus. It's crazy. So hopefully that shows you in the chat right there that you should do the minus still, but it's minus minus. Yeah, it's so crazy. Why do they do this to us? If we made a 99%, no. Just, hey, you're going to get the hundreds. Another 50 points, Cameron. I don't care. You get all the points. Keep asking the questions. When people stop asking questions, that's when I get afraid. Because when it gets silent, I'm like, is anyone following along? So we have here a 90% confidence interval. And then we go to a 99. We go from a 90 to a 99. What would happen here? What would go from a 90 to a 99? What would happen to the margin of error? From a 90 to a 99, what would happen? 90 to 99, get bigger. Yep. because the critical value increases, the margin of error increases as the critical value increases. Boom. Done. Oh, is there more? Really? I am 90% confident. So you can see it's still up there. I am 90% confident that the true difference between the scores of traditional students and non-traditional students is contained in the interval blank to blank. And if you look, the first number being negative is how much higher traditional could be. So make sure you note that the minus goes with the traditional. So traditional might be about 1.562 points higher. So with 9% confidence, a non-traditional student is expected to score between this to this points. This point's lower, and it says a student. That's a problem. So it should be students. With 9% confidence, students in traditional math classes expect to score between this many points lower. It's this one, it looks like. So this is tricky. Why is it students? What are we trying to analyze? Are we trying to analyze an individual student, or are we trying to analyze the mean? What are we trying to look at here? A singular student, or are we trying to look at the mean for students? We're trying to look at the means for students. So don't get tricked. Not today, my Pearson. It got me one time because this one says student and this says students. So this one is talking about the mean for students. This is talking about an individual. And it could be that non-traditional is this much lower because that would mean traditional was higher. So the reason I knew it was this one right here is because it says non-traditional students might score about this many points lower, because this right here is how much non-traditional might be lower than traditional. The negative would mean traditional was higher, which would mean non-traditional is lower. Little tricky on that one, hard to understand, but that's the answer to that one. Does this result suggest that students who learn are expected to score higher? What do you notice is in this interval? Be careful, your interval might not have it. What value is contained in this interval for what the difference might be? The difference could theoretically be this between traditional and non-traditional methods. The difference could theoretically be what number that's in this interval. Between -1, you got it, Neelan, could be 0. So no, because the interval contains 0, there's insufficient evidence. So they're actually running a hypothesis test here. They're actually doing the hypothesis test, and they can't reject 0. So they would fail to reject 0. We could write that out like, I fail to reject 0. 0 is a possible value. Not today. I was so confident I didn't even say not today. This problem. Okay, you ready? Let's do it. Okay. This problem right here, you have to do all the notation on. 100 points. I'm going to put all different boxes here. 100 points per box. You should be able to figure out all the notation on this. You ready? So let me lose my pen. It's classic. So let's put, this is, we have 1. And then we have, okay. And then we have other things. Okay. So n sub 1. And then we have, let's do the first one. Okay. Can anyone tell us any of these right here? I think you guys can see it if you look close enough. You can see the numbers. Can anyone tell us any of these things right here? Camden, you're kind of Camden, you're kind of right. Yep. And so this right here is 10, and this right here is 10. They drive each route 10 days. Y bar 1 equals, is that the first mean equals? And this is technically A, I should say. A, and then I'm going to change these while everyone's trying to figure out in the chat. Oh, yours is 20. Yeah. Good job. And then Y bar 1 is 5 minutes, or Y bar A. And then Y bar B. Do we have Y bar B? Oh, no, you're right. It's not going to be, it's 5 minutes is way off. Y bar 1 is 47 minutes. Sounds more accurate. Let me check. Yep. That's right. Oh, it's 5 minutes faster. You actually found the difference between the two. So you actually found... So that's the difference. That's the difference between the two means, which you can actually solve for that right away. That's fine to solve for. You can, it's all right. That's what we're going to solve for next here in a moment. Great job there, Josh. 100 points, Josh. And also, and also Joseph right there. So any other things? I'm stuck. I don't know. I don't know the rest of it. I know you guys got it. I'll help out with the degrees of freedom and the T. I'll help out when we get to those. You got it. Keep going. There's also a trick on this one. 2 minutes, and it is a 2 minutes. 3 minutes. Oh, yours might be. Yes, good job. Boom. Notation done. So now we need to go find the degrees of freedom. Here's the weird thing about this one is you'll subtract. Let me show it. We don't need the problem anymore. Problem is superfluous now because we have all the notation. In this problem, you will do y bar b minus y bar a. That's the way it's set up. You could do it the other way. It's just the way the problem was created. So in this problem, you'll do y bar b minus y bar a. So what does that equal to? What is, so I think you guys were solving it earlier. The degrees of freedom won't be 19. Won't be 19. Good guess, though. Good guess. How do you get S? They're just given to you right here. Standard deviation and standard deviation. It won't be 9 either, though. It'll be, remember, it's the complex formula. It's the really complex formula that we'll use the applet for. Good, Jess. 50 points, Joseph. So this one, we have to go to the applet. We have to go to, I'll drop it in the chat. Let me drop the applet in the chat. We have to go to the applet. Let me drop the applet in the chat. And let me put it on the screen. Okay. So you have to go to this applet right here. And this is how you... Oh my gosh, Neelan, 50 points. 100 points, why not? Neelan, great job. Great job, Neelan. So we have to go and put in our numbers right here. So we have to go back to our sheet. And we have 10, 10, 3, 1. So we go back here and we put in 10, 10, 3, 1. 18 was a pretty close guess. It's probably going to be about 16.5. Okay, I was way off. It's nice job. 10.97, you got it. And you know what? Let me think. I'm going to see something. Do we have stat distributions open? Let me see. If you get one of these wrong, off by the tiniest of decimals, tell me. That says that. This says the T is 2.201. And this says it's going to create problems, isn't it? I think it's because the way this one... Yeah. Man, this applet with the small degrees of freedom. That's the other website it's recommended. Which website? Let me see this right here. Which website is this? Yeah, that's the one it says. And I think this one, I hate it because it's not visual. So, degrees of freedom, we put them in here. We put in the probability. I guess it's pretty accurate. Yeah, you could use this one right here. Let me put it in here. Well, you already have it. Why did I do that? I do recommend... this one's doing pretty... It's just not as visual. Sorry. And so this gets us our right T statistic. So I've put that in the chat. Please tell me if you just think your problem was a little bit off. I'll fix it. Just because a lot of times we do not solve these by hand. So the reason I'm not so concerned, like if you're off by a little bit, just tell me. We'll fix it. Because once again, these things are usually solved with applets and calculators and stuff that just solves you the answer instantaneously. So now we go plus or minus the T square root S sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So now we just need to plug in our numbers. So we're just going to plug in everything we found right here. So let's go ahead and start plugging in numbers. It doesn't matter. Oh, well, those are 1 and 2, but they're a and b. I think we'll know what those are. So let's go ahead and start solving the standard error. The standard error is 3 squared, which is 9. We divide that by n, which is 10. That's 9/10. So then we get the other one is 1/10. So that is, because that's 1 squared over 1 over 10 is 10. So this is square root of 1. Wow, so we can kind of figure this out. This whole thing right here, if you solve out this right here, equals on mine to 1. So the standard error is just the t-statistic, because we're just going to times it by 1. So it's 2.202. And then we just take the difference between the two sample means, which is 5. And it's 52 minus 47. And so here's the answer right here. That was a nice, easy mathematical solve. Make sure to put in your numbers and solve it out. Be very careful. Carry your decimals via the calculator. But now that I know the t-statistic is 2.202, I'm just going to go 5 plus that, and it's, 5 plus that, 7.202. That's the upper. And 2 decimals, which means this would be 2.80. Just double checking, thinking it through. Yes, we got it. I was like, I bet we made one error. How did you get 5? 5 is found via the difference between the... Does the TI do this? Yep. TI does this instantaneously. 2 sample T on the TI. 2 sample T on the TI. Let me grab that video for you. 2 sample T on the TI. And you take 52 minus 47. So, 2 sample T on the TI. TI tutorials. 2 sample. I keep hoping my videos will make it like big. Like one day I wake up and my video's been watched like 10,000 times. But because I hope they're really helpful. I want to talk to Texas Instrument too and tell them, like, hey, I'll make you videos. There we go. And how do you find the t-statistic again? To find the t-statistic, we're using the applet that we have in the chat. And you put in here your degrees of freedom and your probability. You want to put in the middle. And you want to just click this button here. That's how we solve to get this exact number. Do you have your degrees of freedom? Do you have the degrees of freedom? So, what do you do for the mean 1 sign? Oh, you must be doing the test. Oh, no. I'm sorry. I did test. 2 sample T test. 2 sample T interval. 2 sample T interval. Sorry about that. Do the 2. It'll be the same. Your degrees of freedom were 10.97. Is it a 95% confidence roll? Awesome, Claire. Have fun. Cool. We'll see you at 4 p.m. for the Kahoot. It is. Then your T statistic will be 2.202. So you'll have 2.202 also there. 2.202. And does everyone else have this problem completed? Who else? Should the man believe the claim that he can save an average of 5 minutes? The interval is centered at 5 minutes. Yes, because the interval contains it. So the 5 minutes was in the interval right there. 5 minutes was inside of the interval right there. So we definitely believe that claim. How is everyone else doing on this problem right here? Your interval was wrong, but did you wait, Isaac, I think I know what the problem is. Isaac, were you entering into the calculator, or what did you have, Isaac? The T sub DF is the T. The T sub... Oh, no, we'll help you, Camden. So, ow. Just hit my stand. There's a stand right next to me here. Let me not do that again. I keep... I'm going to cut myself. You had 1.8. Let's double check. We're going to check Isaac's work right here. Let's double check Isaac's work. Oh, no. Okay, wait. Okay. Isaac, I want you to tell me your numbers, Isaac. Okay, the mean. Okay, here we're doing Isaac's. You ready? Everyone follow along. Isaac says his mean for B was 46. His mean for A was 43. Does everyone see those are Isaac's means? What are your standard deviations, Isaac? Standard deviation A, 4 and 2. What are your sample sizes? What are your sample sizes? 20 and 20. Okay. Okay. So what is Brian now going to find? What will Brian now find? I did cut myself. 2 seconds. Tell me what I'm going to find. Put a little Neosporin on this. I'll be right back. What will I find? Well, so I don't think that's the T though, Isaac. I think your T is off. So, we need to find the degrees of freedom now. So we're going to find the degrees of freedom. So the degrees of freedom here, we have to go to the following site. We have to enter in your sample sizes, and then we have to enter in. Oh, it was? Okay, good. Let's double check. Yep, that's got it right there. And then what percent confident? Your T just seems off, Isaac. The T seems off because your T, I think, is my T. So that's why I think the T is off. Because now we have to go to one of these applets here. We have to enter in your degrees of freedom, and then there's your T right there. Does that make sense? And so I think this is where the error was. I think it was the T. So this is your T right here is 2.049. Does that make sense? How are we doing on that? I still see a sad face. Does that... We'll see if anyone got it right. This is one of the tough ones that people usually have trouble with. That's why I obviously pause on it. Can you link? Yep. There you go. So we're using the T distribution right here. It just is a little more decimal place accurate. And so we're using the middle. And as long as it wants a 95% confidence, that's why we chose the middle right here. And who else? So that Isaac, this should be your T value, and then plug into the formula with it. Who else? And it's a difference of -3. Let me double check. Let me check your numbers. It'll be a difference of +3. Because the way they set the problem up is it's y bar B minus y bar A. That's the way they write it when they solve it. So this right here is how we have to solve it. It's just the way they solved it is y bar B minus y bar A. Who else is stuck right now? I guess you could put B here first. At this point, these won't matter. If you're stuck, tell me you're stuck, and we'll put your numbers in here. And we'll find out what your numbers would be. So if you're stuck, if you have not gotten this homework problem, tell me, and we will plug in your numbers. Your confidence roll is this. Is my B the same? Sorry, expand upon that, Christina. Got it. Awesome. Yeah, it was just the T statistic. Awesome, Camden. Keep up the good work. Oh no, you're B. Oh, question B. Christina. So with question B, are they trying to see if 5 minutes is a plausible number? Christina, does yours say like, is 5 minutes a plausible number? Because your interval does not contain part B. So, I mean, your interval does not contain 5. So your interval does not contain 5, right? So if your interval does not contain 5, do you think 5 minutes is possible? Yes or no? Your interval does not contain 5. So do you think 5 minutes is possible? Yes or no? Your interval does not contain it. So would you reject that claim or believe it? Because yours interval does not contain 5. So what would you do there since your interval does not contain 5? What would you do since your interval does not contain? Should the man believe? Should they believe it? Because remember, your interval does. I think you got it. You'd reject it. Nice job, Thomas. Right there, 50 points, Thomas. Yep, you'd reject that claim because it's not in the interval. So that kind of goes to what we've been talking about a lot. That you can use confidence intervals to do tests to be like, okay, this interval, this value is not in it. Yep, I'd reject his claim. I'd say we have evidence against that claim. My interval contained it, so I'd believe it, and I believed it because mine had it in it. Yep. This one's not so bad with jump, so everyone should have jump. You ready for this? Okay, slow down the video right here, or pause as I do this. Copy to clipboard. So we see here we copy to clipboard, right? We got it? Copy. Now we're going to hit Control-C or Command-C, depending on if we're on a Mac or a PC. What do you could, there might be a way to do it in Excel. You can do this on the TI calculator. You'd have to go to Stat, Edit, and enter in all the numbers. Stat, Edit. If you tell me what you want to do it on, Isaac, we'll do it on that next. We're going to go over here to Jump, and we're going to go to File, New Data Table. File, New Data Table. I'm pausing on all these steps so everyone can like do this along right here. File, New Data Table. And then we'll go to Edit, Paste with Column Names. Edit, Paste with Column Names. I'll try to do it on Excel. I'll see if I can do it. Edit, Paste with Column Names. We paste with the column names. We go to Tables, Stack. Tables, Stack. We double click. We double click. We click OK. Double click both, put them there, click OK. Now, this is how it should look. If you've done it correctly, you should get a new sheet with the label of the serial and the data for the serial. We go to Analyze, Fit Y by X. Analyze, Fit Y by X. And then we put the Y variable that's quantitative in the Y variable. We put the X variable that's categorical here. We click OK. Quantitative, categorical. We click OK. We click the red arrow, and we click t-test. So now that we've done the t-test, here's our interval. There's the answer. We have now found the answer of 40.06 to 31.59, and that is literally the interval for the answer. So it was 40.07, I think, rounded up. 40.07 and 31.59. 31.59. And that should do it. That's got that interval. So I am 95% confident that the true difference between children's and adult cereal is where children's cereals contain more. And we just put the numbers in here. This is where children's cereals contain more. 40, and I see there's a question. Oh, wait. What did I do? 31 adult cereals. Dang it. I picked didn't read it. Not today, my Pearson. Not today, my Pearson. I didn't read it. It's more grams than adults. So it's children's have more grams than adults. I saw it said children's had more. So it's a homework, so you can get it wrong and fix it. But it's that children have more sugar than adult cereal and all that good stuff. What about the calculator? And Christina, rewind real quick in the video. If you want to do it on the calculator, let me pull up one of the videos I have in the background. So I can show you how to do it on the calculator with the 2-sample t interval. And then, Christine, if you're stuck, I'll go back and I'll review. On the 2-sample t interval, you'll have to enter in the data. So you'll have to go here, and I'll drop this video in the chat. This video walks through how to do it on the calculator, the 2-sample t interval. And you will enter into it the data first under Stat Edit. So to put data in under 2 lists, you go to Stat Edit. So you go here, you click Stat. Click Stat Run. And then you'd have to immediately go to Edit. Dude, yeah, we can. We can do that next if you guys want. So does everyone understand here? You'd go to Stat and Edit. You would edit list 1, edit list 2. And then after that, you would go to Tests. And then you would go to 2-sample t interval. So it'll say 2-samp t interval right there. And the 2-samp t interval is what you'll be putting in. If you notice, here's all the notation. They call it X sub 1. Same as Y sub 1. So does that make sense? And Isaac, did you want me to do it on Excel real quick? On Excel, let me try to do it on Excel here. I'm just going to challenge myself. Then we'll do Excel. Okay. So in Excel with the data, wrong data. If we're doing it in Excel, which we can do, we need to take the data first, copy it, bring it over to Excel, whichever way we like, and I'll go back and do it the other way if other people are still stuck. What I want to do here is I want to get N1, N2, S1, S2, Y bar 1, Y bar 2. So I'm going to go right here. I'm going to write equals count, and then I'm going to do this and get that. I'm going to go equals count. There might be a way to do this with the analysis tool pack. There's that. I get standard deviation 1. So this is equals standard deviation. And I believe that's it, as long as I select the right one. There's that. Equals standard deviation 2. We select this. Y bar 1. So this is equal to average. And then Y bar 2 equals average. And if you've programmed in Excel before or done this, this is very similar to R. Oops. What did I not like? Oh. There's that. Okay. And now we need the degrees of freedom, but so I don't know if you can get the degrees of freedom in Excel. I don't think Excel calculates degrees of freedom, but we do have the standard deviations and we do have the sample sizes. So we're going to have to go outside of Excel to get the degrees of freedom. And so the degrees of freedom will have to be calculated via us going to this page. So it's 20 and 30. And then the standard deviations are, where's the Excel? 6.927. And then the other one was 7.790. Can you show me how to change the color points? Oh, we can't do it because it's quantitative. Yeah, no, a lot of people were asking that. For the decision tree, we can't do it because it's quantitative. 44.036. So no worries. No worries. There's that. This is the interesting one. The T is going to be equals inverse T. So Isaac, this is the tricky one. Here we go. We want T inverse. And so the arguments T inverse takes is the probability. We only want to shade the bottom 2.5% of the curve because this is a 95. Yeah, so don't worry about it. Hopefully I didn't write that in the project. And then the degrees of freedom equal this. And there's the T. We've done it. This is it. Now we just have to write the rest of the formula. We could solve this from by hand right here. Let's do chapter 16 homework, and then we'll do chapter 17 quiz next. We'll do 16 homework and then quiz. How's that sound, Christina? Because I think they're both due tonight. It's the big night. It's a big night. Or did I put it? Yeah, I can't remember where I put stuff. Just there's a lot. Don't miss assignments. So we could take a vote, but it looks like 16. Vote now if you want. I'll start doing a more official vote, but we see 2 for chapter 16. And then I'll go back, Alyssa, and we'll look at that. Which one are you? Is it the bike problem, Alyssa, or is it the bike problem? Looks like people want 16. We'll do 16. Isaac, do you think you have it from here, Isaac? Like what to do with all these numbers? Like you could solve it by hand from here because you have all the components. You have the T statistic right now, so that's the T. Where do I, after going to sample T, which one are you working, Alyssa? Are you doing the bike problem or the children's cereal? So the calculator, the degrees of freedom calculator. We'll go back. I'll talk cereal here. Degrees of freedom calculators in the chat. That's degrees of freedom calculator. And then this is where I've been getting my T's from lately. Oh, the TI calculator video? The TI calculator video is this one. So, yep. And so the TI calculator, you have to do stat edit and enter the data values in under list 1, list 2. So, and I think Isaac's got it from there. So you have to go to list 1, list 2. You go to stat edit. I don't try to do it in this video, but you go here and you go to stat and you go to edit. Under edit, you'll go into list 1, list 2. So you see it right here. You'll have to click edit. And when you click edit, you'll edit list 1 and list 2. And when you go to the 2 sample t-test, you will select data. So when you get to the 2 sample t-test, instead of doing stats, you'll do data. The test. Well, expand a little bit more on it, Isaac. So you want to do the 2 sample t interval. So you want to do the 2 sample t interval because we're making the t interval. Does that make sense? I think. Let me look at Alyssa's thing right here. Alyssa, you were wondering about when you're in jump, what to do next. Here, are you at this point right here? My question is about a sports reporter, older. No, on the calculator. Which part are you stuck on the calculator, Alyssa? And then I'll look at Neelan's. You're trying to get the p-value, Neelan. Do you have the t statistic, Neelan? If you no, so for the data you enter in list 1 and list 2. I think I might have to take a look at that, Neelan, because you'll have to find the t statistic. I think you might have done the test, Alyssa. Did you do 2 sample t test? And I'm sorry, I think I put that in first. Did you do 2 sample t test or 2 sample t interval? Yep, 2 sample t interval. Yep. And Neeland, here I'm gonna take a look at Neeland's problem really, really quick. Then we'll do chapter 16. Let me do yours really, really quick here, Neeland. The sports reporter problem. Then we'll do chapter 16. Quizzes. Sports reporter problem. Okay. Suppose microwave popcorn. All right. So with this one right here, Neeland, the biggest thing is we want to make sure we have all of our notation written down. They've done a really great job for us. So are you saying that when you solved, when you're saying, did you get a t statistic here of this right here? Is that the t statistic you got? Is that the t statistic you got right there? Okay, that's a very, very small t statistic. Oh, and then listen, I'll go right back and we'll take a look right here. So now with this, if your numbers are anywhere close to mine, I think you have a calculation error, Neeland. Because the difference here between the means is about 1.4, and I'm not sure that t statistic should be that small. Oh, yours are smaller? Okay. And you're taking the difference between y bar 1 minus y bar 2, and it should be the mean of, let mean 1 be for baseball players minus the mean for football. So if yours are smaller, then you might get a very, very small t statistic. We want to see if, let's see here. Researchers selected baseball players, or sports reporters suggest that professional baseball players are older on average. So the difference would be positive. So we can confirm that this is the answer here because we're looking for the alternative that they would be older. And if your t statistic is this, so I'm going to draw this out for you, Neil, and I want you to take a guess of the p-value. Your t statistic is about, here's 0, here's your t statistic. Can you take a guess at what your p-value should be kind of close to? And then you have to go to the t distribution with the right amount of degrees of freedom and find it out. But this is what you should see as a picture. I'll let you see if you can get it from here. But this is what you should see graphically when you make it. You should be shading above your t statistic because you're doing a greater than test. Does that make sense, Neeland? And do you have a guess at what your p-value might be? Like you should have be like, oh, my p-value should be kind of close to this, but a little bit less than that. Like if the t statistic is right, could we do the t value real quick? I think mine is wrong. Okay, put in the chat. I'm gonna talk to Alyssa here real quick. Put in the chat your means, your standard deviations, and all that stuff. Put in all your mean, all your standard deviation, all your sample sizes, and I'll be able to solve it right here. And I'll solve your t, and then we're gonna do chapter 16. Alyssa, did you enter list 1 and list 2 under the? So Alyssa, did you do stat edit, and then did you enter in list, or do you have jump? If you have jump, it's way easier, I think. Personal opinion. But Alyssa, did you enter in stat edit, and then did you go to list 1 and list 2 and enter in all the numbers? Did you enter in all the numbers for list 1 and list 2? And then you want to enter them in descending order, like, and the only, did your interval come out negative or positive? Did your interval come out negative? Yeah, it could be if you enter in, oh no. Yeah, if you can do it in jump, I think it's quicker. Your interval should be positive. Double check your numbers. If you do the interval, yeah, double check your numbers, Alyssa. That looks to be the problem right there. My guess is that it, your feed keeps messing up. Oh no, what's that mean? If you enter in one wrong number, the interval blows up. Yeah. Do we have Neelan's numbers? What are your numbers, Neelan? Okay, here we go. Let's hop over to the problem here. Boop. Okay. So we have here baseball players is the sample size of 28. So I'm going to start writing out the equation with the numbers in it. We have here 28, and there were 29 football players. Standard deviations are football players have a standard deviation of 2.62, and baseball players have a standard deviation of 4. And we're doing a T, so I got to divide this. And then we have to do the mean for baseball. And then we take the means. The means for baseball was 27. And the mean for football was 29. Is the mean for football 29? Is that right, or is that reversed? Because usually they have baseball being older. Or are they trying to say, oh, that's so weird, Jack. Are all these numbers accurate here, Neeland? Do 26.46? Oh, I can't read. You're right. Yeah. You put it, you wrote it correctly. I can't read. So there we go. Let's go ahead and solve the bottom of the equation first. So the bottom of the equation will be 4 squared, which is 16. 16 divided by 28 is this. The next one is 2 point this squared. We divide that by 29. We get this. We add the two together. We get that. We square root it. So, yep, I did that. I hope I did. Let's double check. We're going to double check the answer. You ready? 4 squared is this. Divided by 28 is that. And then 2.62 squared is this divided by this. We add the two together is this. We square root it. And we get this right here. Then we take the top two numbers, 2.7 this here, minus 26.46. And then we divide by, and we get that t-score. So that is your t-score right there. Does that make sense? So double check your work. This should be the t-score that we find. Does that make sense, Neelan, right there? Yep. So now that we have the t-score, we're going to take the t-score and we have to go and put it into this applet and do a right-tailed test. And really, the t-score is 1.3349. And we have to know the degrees of freedom. This is the painful part of it, is that we have to get the degrees of freedom. The degrees of freedom will be found with the following applet. Our sample sizes here are 28 and 29 with standard deviations of 4 and standard deviations of 2.62. And then, yep, that's the right degrees of freedom. Take your degrees of freedom, go back to the applet, put in the degrees of freedom, solve for the probability, and there's the p-value. So that is the p-value right here. Here's the answer to the p-value. Does that make sense, Neelan? We put in the degrees of freedom, we put in the t-statistic, and we solved for the probability, which is the area under the curve. So that should do it. That should get that problem. You got it. Great work, Neelan. Let's do some chapter 16. Chapter 16. Gonna get it done. Chapter 16. All right. Chapter 16. Chapter 16. Homework. Oops. Oh, the homework's always the same, but still. Replace questions. Only 4 questions. Yay! Muppet Show night. Yay! Okay. So, where is it? Where's the chart? Okay. You're welcome. Great work. A casino wants to know if their slot machines really have a 1 in 5 chance of winning. So think about this: when you pull a casino machine, then you would look at your probability of winning, and that would be either the mean of winning or the proportion of time you win. Which one would it be? I'm gonna finish my lemonade right here. Would this be means or proportions? Means or proportions? Be right back. Means or proportions? I am now out of lemonade. Means or proportions? Does anyone know? Would this be means or proportions? For which one, Thomas? For Neelan's at 0.05, you would not reject. If it says 0.10, you would reject. This is proportions because it's the proportion of time we win, and we only put p here. We don't use p hat, and we want to see if it really is a 0.05. So the null would be equals, and the alternative would be not equals, because we're going to see if it's equal to that, and that's proportions. And we got it right. Don't tell me I got it wrong, my Pearson. Not today. So, well, it doesn't say what the results are. It just says we're going to test it. So we're going to see if the proportion is truly equal to this or the proportion is not equal to. Now look at this. We have money right here. Do you think money is dealing with proportions or means? Do you think money deals with proportions, like how much people spend? We would say the proportion of dollars people spend or the mean amount of dollars people spend. What sounds better? The mean amount people spend? Yep, means. So then we're going to use mu because, remember, we're going to use the population parameter. So the mu equals, and then what are we testing? We want to see if it has changed. Does everyone see where it says on my question, has it changed? That would mean the sign is what? The first, the second, the third, or the fourth. If we're going to see if it's changed, which of these will it be? We want to see if it's changed. Which answer is it? We're going to see if it's changed. So we want evidence if it's changed. Which of these will it be? 100 points first answer. Not equal, Josh. Amazing job right there. You got it. Yep. A pharmaceutical company wonder if a new drug has a cure rate greater than. So automatically we can see the greater than and identify this. We know the null has the equal sign. And they're looking at if people get better from a drug. So getting better from a drug would be yes, no. That's categorical. And so that would be proportions. And proportions are P, the true proportion. We did it. We're up. A bank wants to know if the percentage of customers who use their website has changed. So since it's changed, it's does not equals. Null has the equal sign. And since it's proportions, it's P. So because we're saying, do people use the website? Do they not? This is like an old question. Like the percent of people using the website is 20%. It'd be like crazy now. Because the one question with the calculator at the point. Send me it and I'll fix it. Send me and I'll fix it. I'll fix it up. I got you there, Alyssa. Put on my headphones. A company is sued for job discrimination because only 6% of its newly hired candidates were immigrants, when 40% of the candidates were immigrants. Is there strong evidence that the company's hiring practices are discriminatory? Okay, so in a one-tailed test, you're welcome, Alyssa. Great work. Keep working hard. You got it. In a one-tailed test, send me and I'll fix it, Isaac. In a one-tailed test, we'd be asking, the company discriminates too much. That's the greater than test. We could do another one-tailed test to see the company's discriminating too little. That's another one-tailed test. Or a two-tailed test would be, the company is not discriminating at the amount by which we think they should be discriminating. Like we'd have some sort of, it sounds weird. Or you could say the discrimination part's weird. It's what the question is going to allude to. But like we'd say what we expect them to hire certain candidates at, and the two-tailed would say it's not equal to that. Yep. So it's a one-tailed. Nice job right there, Elizabeth. Yeah, it's one-tailed because they're going to not get discriminated. Okay, so what would be the null for this company? Let's write this out. I think it's asking about a type 1 error. So the null would be not discriminating. The alternative would be is discriminating. Okay. So what would a type 1 error be, which I think they're asking about? In a type 1 error, the null is what? In a type 1 error, the null is true. It would be what about the company? It would be true that the company is not discriminating. Does everyone see that? In a type 1 error, the null is true. Null is true. So it'd be true that the company is not discriminating, but we would reject the null and say we have evidence they are. So in a type 1 error, the null is true. They are not discriminating. So the type 1 error is deciding that the company is discriminating when in fact it is not. This is the right choice. If the company is discriminating, you should say they are. That's the right choice. This is the wrong choice right here. When the company is not discriminating, the null is true. Wait. There we go. Type 1 error is deciding the company is discriminating when they are not. So we're going to accuse them of discriminating when they're not. So it's what we said. Always write it out and make sure you can see it and know what's going on. What's a type 2 error? A type 2 error is when the null is false. In a type 2 error, the null is false. It is false that the company is not discriminating. So the company is discriminating. But we are going to fail to reject the null, and we're going to say we don't think they are discriminating when they actually are. So let's double check right here. So deciding that the company is not discriminating when it actually is. So because we failed to reject the null. In context, what is the power of the test? It's the ability to correctly reject the false null. So the power of the test would be the ability to figure out what? If we're trying to reject the null, a powerful test would be able to find a company that is what? Think about it for a moment. If we're trying to say this is a very powerful test, it can find results. So a powerful test would be able to find a company that does what? A powerful test would be able to find the companies that are doing what? A powerful test would be able to find the companies that are what? If the test is powerful, you got it, Josh, 50 points, and Elizabeth, and Josh right there, and Thomas. Yep. A powerful test can reject the null. It'd be able to correctly determine that a company is discriminating. It can reject the false null. If we test at the 5%, oof, not today, my Pearson, not today on this question. If we test it at the 5% level of significance instead of the 10%. So what are they changing here? What are they changing? They're changing what here? What are they changing if they say, if we test at the 5 instead of the 10? So they're saying they're going to go from the 10 to the 5. They're changing alpha. This is alpha level. So they're bringing their alpha level down. So the power of the test will do what? So if you bring your alpha level down, you have to watch out. This is where it's tricky. So the way it works is alpha. It's a review of class now. Alpha, if you bring alpha down, beta goes up. If you bring beta up, power goes down. Because power is 1 minus beta. Okay. Just nice. I want them to look good. So I want them to look good. I want them to look like professional. Send me yours and say, how does this look? And I'll tell you how it looks. Definitely in the notes. Go look at the notes or go look at the videos. Through the videos, here, I'll show you a video of it now. And I'll put the videos in the chat. And so we should get that question right on that. Where's pivot table videos? Making pivots. I'll put the video down here when the ad ends. All right. So many ads. What did I do? I put ads on the videos. These videos right here in the chat, I'm putting a playlist in the chat right now. And so this playlist in the chat will help you make some nice pivot tables. And so, there we go. Okay. So, can I see myself? There we go. Excel tutorials. So here is how to make it look nice. And I go through all the steps right here. So this has all the steps on how to like change colors and to make it look nice, to put your titles in, and to make everything look really good for your pivot chart. So if you follow, they're all very short videos. They're like 2 to 3 minutes. It'll show you the steps on how to like change the colors, how to do different things. But the videos are not that long. You can make a pretty nice pivot chart, pivot table. You're welcome, Camden. You're welcome, Christina, right there. So if you follow these videos right here, you'll get a pretty good looking. You can see it's 5 videos, 1 minute, 3 minutes, 2 minutes, 1 minute, 2 minutes. It's not even 10 minutes of videos, and it shows you just directly how to do stuff. I might need to update some of the videos. They're still pretty accurate. Maybe, hopefully, I don't know. So we're making our alpha go down. If our alpha goes down, our beta goes up. If our beta goes up, our power goes down. So since alpha has decreased, the power has decreased. Oh, no. No. I mean, you're here. If you're here, you can ask questions. The power of the test will decrease because the significance level has decreased. Not today, my Pearson. Not today. Wait, if the test is tested at the 0.05 level instead of the 0.10, not today. Not today. I've got that problem wrong before, if you can't tell. And just because I just up, down, up, down, up, down. The lawsuit is based on hiring 35 employees. Is the power of the test higher, lower than, or the same if it was based on 11? So they're going to compare. So what are they changing here? What are they changing here? They're changing the what? They're changing the what right here. They're saying we're going to go from 11 to 35. They're changing the what. It's a thing we talked about today. This is a very good problem. It's a good review problem. What are they changing about this problem? Wow, we are back here. Yep. So what are they changing by saying we're going to go from 11 employees to 35? We're going to change it from 11 to 35. They're changing the what? One of these things. We just changed alpha. Effect size is like how much they are discriminating in this problem. Like, it'd be easier to detect. This one is changing N right here. So this one's changing. Good job, Elizabeth, 50 points. They're changing for this one. They're going from 11 to 35 employees. So that's changing the sample size they're using. So if we look at, we've got a good cheat sheet going right here to tell us how it works. It still is the same thing. You could plug in whatever you want right here. It's still the inversely related stuff, where if we have N going up, beta goes down, and power goes up. So power, which is 1 minus beta. So sample size, you might copy paste it if you can, and let me read it. And let me make sure I'm doing mine correct. The lawsuit is based on, so wait. The way they word these things. The lawsuit is based on hiring 35 employees. Is the power of the test, is the power of the test higher than, lower than, or the same as it would be if it was based on 11? The power of the test is higher. Yes, but all these say increases. Okay. It's got to be A or B, and I'm pretty sure it's A, because they're saying 35 is more than 11. Good. But they might have changed the way it looks. If you drop it in the chat, Thomas, I'll see. The way they word this is weird. It even has caught me off guard, because they're asking, like, compare 35 to 11, but 35 is the one you're saying is 35 more powerful. Yeah, and if they're saying, is this what they're saying? The lawsuit is based on the hiring of 60 employees. Is the power of the test higher than, lower than, or the same as it would be if it was based on 90? So yep. And that's so weird that my person does it. So yours says that the lawsuit is based on the hiring of 60 employees. Is the power of the test higher than, lower than, or the same as? So when you look at this, your numbers, Joseph and Thomas right here, your numbers are lower. So check it out. Since your numbers are lower, your sample size is lower. So your power would be, well, that's beta. Your beta would be higher and your power would be lower. Should the count be... No, it'll be different. Good question, Camden. It'll be different. And I wouldn't do mean, or if you do like score, you could do count. You can send me the graphic. Count will work. It'll just show you how many pizza. You can do like different pizzas. Oh man, you can do so many cool things. There's so many cool pivot graphs that can be made. Pretty quick and easy. Yes. The mean of the score and deliver, yep. And then just make sure to change the value field setting, because that's where you'll lose points if you do something like sum, because then it's just like sum of score is a bad idea. Yep. It's just that there's different amounts of toppings used. If you want to send me it to me to look at, I can do that. I can review it. I can be like, that's a great graphic. I'd be like, good job. That's a good graphic. I'll review stuff. A random poll. You're welcome. A random poll of 900 working men found that 11% had a second job to help pay bills. Estimate the true percent of men that are taking on second jobs by constructing a 95% confidence interval. 95% confidence interval. Notation time. I need some help. Chat, help me out with this notation. That's good. Okay. What do we have right here? I've got a few things I can solve for. And it also said 95%. What do we have notation-wise? Boop. Boop. Yep. Nice job, Elizabeth. 50 points right there. Crazy points today. And what else is this right here? And then we'll immediately solve for it. Be careful. P hat, technically. And then Q hat, because it's from a sample. It's P hat, because it's from a sample. Don't worry. Not the end of the world. It's just when we identify the formula, it'll kind of help us out. Because now the formula for this is P hat plus or minus Z square root P hat Q hat over N square root. And once again, over N. Square root of the whole thing, too. I've seen a few people who just accidentally put the square root over the top. It's the whole thing square root. Just make sure you do that. This is a 95% confidence interval. So what is my Z score? This is a 95% confidence interval. What is my Z score? Does anyone know that? What is the Z score? Because it's a 95%. Yes, Elizabeth, 50 points right there. Great job. 1.96, classic Z score. And obviously go and look it up if you don't know it. You can also Google it. Someone's like, I just Google it. And it's like, oh. After you do it like 20 times, you're like, okay, it's 1.96. So that's the formula. I'm just going to plug it in here. Let's do it. 50 points right there. Ethan, great job. We got here P hat times Q hat over N. Hair just goes floop. Over N square root times 1.96. That's the margin of error. So there's my margin of error. Now we go and do 11% plus or minus this. It's very close to, it wants as a decimal. I think I can get away with it. Is that going to do it? No, wait. What did I do wrong? Let me see. Look at my, does it want it as a percent or a decimal? Oh, it didn't make an error. Okay, let me try. Oh my gosh, wait. I don't know how to add and subtract. What did I do? It's 11 minus 2%, 11 plus 2%, and I just can't do math in my head. I should let the calculator do the work. It's 11 minus the margin of error, and it's 11 plus the margin of error. And then it rounds to 9. I just must have, when I was thinking it, subtracted the margin of error twice off of it. So I looked at the interval, I was like, that's not symmetric around it. Because what should be at the center of the interval? 11 should be at the center. And when I looked at it, I was like, what did I do? So it's just 11 plus or minus the margin of error. We solved the margin of error to be this. So all you do is 11% plus or minus this. So you say, okay, 11% plus this. If you could type 11% plus the margin of error, 11% minus the margin of error. And that's got it. Because this, what are we testing? They say 7%. Because 7% is not in the interval, we have strong evidence that more than 7% of workers have a second job. That seems right. Good, it is right. So they were testing 7%. Cool, we're on to the last problem. Your intervals were wrong, but your numbers are the same. Wait a minute, for this one? Are they exactly the same, Isaac? You have 900 workers and 11%? What? It should be 0.09 to... Make sure you did the decimals. Happens to me all the time. You know what you got to say before? You got to say, not today. For the Z. That is correct. That is always for the Z, Jack. That's always for the Z. Jack. I put the Z in your name. That's always for the Z, but not for T's. So T's are dependent on the degrees of freedom for the right T statistic for a 95% confidence interval for a T interval. But for a 95% Z interval, it's always 1.96. Always. You get that all the time. Oh, it's awesome. 50 points for Jack right there. And million points for Zach. No one gets those points. A researcher developing scanners to search for hidden weapons at airports has failed to conclude that a new scanner is significantly better than a current scanner. He made his decision based on a test using an alpha of 0.05. You're welcome. Would he have made the same decision at the 0.20 level? How about the 0.005? Okay. There's a lot going on right here. There's a lot going on with this. Let's break this problem down to its parts. I think I'm going to watch an episode of Dexter while I ate lunch today. It's season 3 is just getting crazy. Don't know spoilers in the chat. You're like, Dexter hurts people. I'm like, no, I didn't know that. I didn't know Dexter does that. Not like the opening of the first episode tells you that. Don't tell me anything else. Okay. So what do we get right here? They failed to conclude at the 0.05 level. That's so important. They failed to conclude. What do you know about this right here? I need someone to tell me what this means. What do you know about their p-value? What do you know about their p-value right now? You would know this about their p-value right now. If they failed to conclude at the 0.05 level, you know something instantaneously. You know this instantaneously about their p-value. They failed to conclude. They did not have evidence at the 0.05 level. What do you know instantaneously? It's higher than 0.05. Exactly. Nice job right there, Jack. Another 50. So it's higher than 0.05. Does that make sense? Like, we know the p-value right here has to be above 0.05. So what we know right now is the p-value could be above here. We know this. We know, like, tell me this. And we know it can't be. It can't be below it. Does this make sense right here? That the p-value has to be above 0.05. So let's just make up a p-value. Ready? Let's say scenario 1, the p-value is right there. Scenario 1, the p-value is right here, and scenario 2, it's right here. Okay. So in scenario 1, oh, was it? In scenario 1, would we reject the null at the 0.05 level? So let's do 0.05 for scenario 1. 0.005, excuse me. Scenario 1 and scenario 2. And 0.20 scenario 1 and scenario 2. Oh yeah, Josh. So with the 0.005 in scenario 1, we would not reject. So that means we do not reject. That's why I'm putting the X there. You do not reject because it's not below. How about in scenario 2 with the 0.005? Would you reject with scenario 2 and 0.005? Like, if your p-value landed here, would you reject or not reject at the 0.005 level? Your p-value is up there. It's way above this mark down here. Also no. It looks like since we can't reject at the point, we did not reject at this level, so there's no way we can reject at a lower level. Does that make sense? Like, just understanding we did not reject at the 0.05 level. Well, then how in the world could we reject at a lower level? Does that make sense? Like, we didn't reject with this amount of criteria. How could we reject at a stricter rejection? Like, this would be harder, so we can't do that. So now let's look at the scenario 2 over here, or it's the alpha of 0.20. And with the alpha of 0.20, would you reject if you landed right here? If you landed right here, would you reject, yes or no? If you landed right there, would you reject at the 0.20 level? If your p-value was somewhere in there, yep. And so this instance, we would reject. And how about if our p-value is actually up here? Would we reject there? If your p-value is there, which take a look at that. If your p-value is up there, would you reject? If your p-value is there, would you reject? And why would you not reject? The answer is no. You would not reject because your p-value is higher than your alpha level. And that is possible here. So in this area, which I've marked, we would not reject because our p-value is above alpha. Because these are the alpha levels at which we reject. They're like our limbo bars we talked about. And we can't go underneath them. I mean, if we do go underneath them, we reject. But 2, everything of p-values there is above it. Is that making sense? Who feels like they understand why with the 0.005 level, we can't reject no way, no how, but with the 0.2 level, well, maybe we can reject, maybe we can't. I don't know. You'd have to tell me the p-value because it's easier to reject, and yeah. Does this make sense? What if it has been concluded? Oh, so does yours say, yeah, we do chapter 17 quiz next. You got it. Does yours say, Christina, can you put your full problem in the chat and I'll do yours next? Put your full problem in the chat and we'll explain that one. So state his conclusion. His decision may have been different for this, but it would have been the same for this. Good. Got a little bit scared there. So if you put yours in the chat, I'll be able to, if he concluded, so I'll maybe start saying what yours is. This is Christina's version. In Christina's, if they concluded it, then let's take a look. A researcher developing is significantly better. He made his decision on a test using. Then, yeah. When is so better than the Kurt scanner. And they made their decision regarding. It looks like they were able to conclude. Let's see. So if they were able to conclude at this level, like let's say they're able to conclude here. If they were able to conclude here, that means their p-value has to be somewhere here. So does that, at the 0.05, he made his decision, would he made the same decision at the 0.10? And so if he was able to decide there, so that means the p-value has to be, oh, it just wants to know, would he make the same decision at the 0.10? So in this instance, they're just asking about 2 spots right here. So what you know right now is he was able to conclude at the 0.05 level. So if you're able to conclude at the 0.05 level, where would your p-value have to be? Your p-value right now is in region 1, region 2, region 3. So where must, I've kind of got the answer highlighted. If you're able to conclude at the 0.05 level, you know that your p-value has to be what to 0.05? If you were able to find results at the 0.05 alpha. So right now you have alpha equal to this, and you found results. Lower, you got it. So what does that mean? His p-value has to be in this range right here. So the p-value is in this range. So what would that mean? Try some stuff and then show me what you got. It could be anything. I guess, yeah, you could do some crazy stuff. You don't have to use a row. You could just use columns and you could just make but yeah, give it a shot. Whatever you want. Make something you find interesting. So you can do pepperoni. Yeah, man, I want a pepperoni pizza. Man, I want a pepperoni pizza. I've been so good. I haven't eaten out in so long. Haven't been eating fast food. Haven't been eating pizzas. It's like the one way I'm not, the one way I'm staying in shape. Do you think you have it, Alyssa? Do you think you know what they would do at the 0.10 level? Because you're saying your p-value has to be here. You're like, my p-value has to be here. So that would mean something if you compare it to this right here. Do you think you know what it is, Alyssa? Because your p-value has to be down there. And your alpha level is at the 0.10. So would you do the same thing? Would you still reject the null? Because your p-value has to be hint down here below the alpha. That's the biggest hint I can say is your p-value is definitely below the alpha. Because we know your p-value is below 0.05. So if you went to the 0.10 level, your p-value would definitely be below it still. That kind of gives it away if you heard what I'm saying. Like, oh, it's still below alpha. We know the p-value has to be below alpha. So I'll check back, but I think you have it. I think you got it. Let's do that chapter 17 quiz. 100. We got the homework done. Let's do the quiz. The quiz time. Assignment manager. Quiz time. Chapter 17 quiz. Oh. Hey. Is there any quiz question that people are currently working on? Which quiz question are people currently working on? I know we have some people doing Chapter 17 quiz. Which quiz question are people currently working on, and we can hop to those. We've done the hot dog one. If you're watching this right now and you're like, wait. I mean, we can do it if you want. Man moves to a new city. Yep. Is that the bike one? We can do it again. Yep. Okay. We got it. You ready? So let's do it. This is the bike one right here. The first thing we're going to do is identify our notation. So we need to identify notation first. So let's go here and identify the notation. Thomas, I need your help here. What notation do we have? What notation do we have here? We need some, like what, you can start telling me what these things are. Like I see this, I see this, I see this, I see this, got that. What are some of these things right here? We got to get all of this notation marked right here. We got to be like, okay, that says it's a standard deviation. What are some of these things? What are some of these things? And we will need, let me start getting things in the chat right here. Or I'll start, no idea. Oh, don't worry. Okay, well, so here's the notation we will need. Let me mark it. We have Y bar B, Y bar A. We got you here. We got you, Thomas. You're part of Stat Nation. We got you. Stat Nation helps everyone out. Stat Nation's Vol Nation. So now, do you know any of these right here? So we have Y bar, which is sample mean, and then sub A, which means sample mean of group A. Can you identify any of these right now? And just with what we have, it says he rides each route 10 times. That's like how many times he did each one. It says we have some means. Would you have any idea of any of these notations here now? Any idea on any of these? If you get me started here, it's like starting an engine. You tell me one of them, boom, I'll get the rest of them for you right away. Where would any of these go? And then those look to be the means. Yep. So we have mean for route B is 43. Mean for route A, and make sure it's Y bar. You got it. Could you? Yeah, I'll do it. You got it, Neelan. You got it. And then we have standard deviation for route A is this, and standard deviation for route B is this. Please tell me if I make an error. And then the sample size for both of them is 10. Does that make sense right here, Thomas, how we got all of these notations right here, which are key to doing the problem? All of these notations were found right here. Does that make sense? So we have every bit of notation. We have the mean for B, the mean for A, the standard deviation for B, the standard deviation for A, the sample size for A, the sample size for B. And I guess technically, there we go. Got it. So now, once we have this, we need to go and find the degrees of freedom. So now we're going to go find the degrees of freedom. And just from memory right here, it was 10 for the sample sizes, 5 and 1. So now we have the degrees of freedom. How's it looking right there? You got it, Jose. We'll do that one next for you. So does this make sense right here that we're going to go find the degrees of freedom? So now I know the degrees of freedom for my problem. So the degrees of freedom are like 9.7. So we're going to write here df equals 9.7. And then we're going to take the degrees of freedom, and I'll put this in the chat too. Once we find the degrees of freedom, we're going to go to this applet right here, and then we're going to put the degrees of freedom into here. So you need the degrees of freedom. Take the degrees of freedom, copy it a few times. Go here and enter in the degrees of freedom, and then you have to go to middle, that's key, and then you have to put in a probability of 0.95 and click this. You should get something close to my number, probably like 2 something, but this is the t-value we will use for the confidence interval. So you have to put in the degrees of freedom, click the middle button, and put in 0.95, which you're making a 95% confidence interval. Here is the t-statistic, 2.237. We have now got all of our notation. So the t-statistic is 2.237. Yours said NAN. What did you enter in? Make sure you enter in, what'd you find for your degrees of freedom? And what'd you enter in? So you should get, you might have not entered something in here. You might have, or maybe not. 31. So if you have that, so did your person ride the route 20 times each? This should be your T right here. So that should be your T statistic right there for 95% confidence interval. And that should be it right there. And if they write it 20 times, that sounds about accurate. Were your standard deviations like 3 and 2 or 1 and 3 and 2? Do you have standard deviations of like 3 and 2? It's going to be really sad if I know that. If you're like, yes, I'll be like, oh my gosh, I've done these problems way too much. So, but yeah, my guess, 5 and 3. Yeah, I thought they might have a little bit of a difference. That sounds about accurate. And we could check your numbers right here. We could go 20, 25, and 3. Degrees of freedom. Great job. You got that right. We hop over here to this page. Not that one. And we hop to this page. We put in the degrees of freedom. We solve for the T, and there it is right there. So this is your T statistic. So as you're going through and taking your notes, you'll put the T down here. Now what we do is we write the following formula. We write y bar B minus y bar A plus or minus. If I could write a plus or minus. I can't. Degrees of freedom, square root, S sub B squared over N sub B plus S sub A squared over N sub A. So now we just plug in the numbers. So now be very careful, but plug in your numbers from here. Just very, very carefully plug in each and every number. If you write in every number the correct way, you will get it correct. So I'm going to plug in my numbers just by kind of doing it in the calculator, but check your work. I've got my T statistic here. Just carefully follow through your formula. The way I do this is I solve this part first. So I'm going to go here and do 5 times 5 is 25. Divide that by 10 is 2.5. I'm going to copy that. Then I'm going to go to 1 squared is 1. And then I'm going to divide that by 10 is this, obviously. Then we're going to add these two together and get 2.6. I'm going to square root it. A lot of people forget to square root it. I do sometimes. Then we're going to go to times 2.237. Now, what I just found here is the margin of error. I just found everything here, and this is the margin of error. Now I just have to take the difference of the two means, which is 43 minus 42, which is 1, and add and subtract the margin of error. Do you see how 43 and 42 have a difference of 1? And I guess technically this should be in parentheses because we're going to solve that and then do the plus or minus on it. So now that we have the 1 plus or minus the margin of error, we're going to go to 1 plus this, 4.607. So 4.61. Then we're going to go 1 minus this and negative 2.61. That's right. That should be right. Should the man believe the 5-minute claim? No, because the confidence interval does not contain 5 minutes. Was it a 95? It was. Woo! Get scared there. And then make sure, plug in your numbers here. I'll kind of show it again, then we'll do Jose's problem. So right here, we plug in all of our numbers, and this was y bar B minus y bar A. And then we plug in every number. There you go. Yep, that could be all right. And then you would not believe 5 minutes because 5 minutes would be outside the interval. That seems very, very plausible, Josh. Great job, Josh. That seems like a plausible answer. And then was your difference between the two with a margin of error of 2.9? So you should have got a difference of 2. So you should have had like 45 and 43 or something. And your difference was 2, and your margin of error was 2.9. Very, very good work, Josh. That looks accurate. Do I keep going off screen? It's looking weird, Dave. Great job. Let's do Jose's problem here. Jose's problem. We got this. We did it. What is the problem? Stop yawning in the mic, Brian. We did the children's and adult cereals. Was it the size of a drinking glass? Okay, here we go. Jose, what do we notice right here? We've got some notation. So the first thing it wants to do is the null and the alternative. The null has the equal sign, and they want to see if these amounts are different. Did the size of the glass change the size of the sample? So they're asking, did it change it? Is it option 1? Is it option 2? Is it option 3 or option 4? They're asking, did it change how much people drink? They're asking did it change how much people drink? So the big thing is they're saying, does it change the amount? Option 3, you got it. Boom. Because it says, does it change it? Great job, Thomas. 50 points, Thomas. The mean for glass is the same. The mean for the smaller glass is different because does not equals means different right there. Find the t and the p-value for these results. So we need to take this stuff right here and plug it in. So we're going to take all this and let's go ahead and drop it in a Word document. Cool. And so now we've got this notation right here. Now we can do, how did they set up the test? I got to see that. They set up the test as mean 1 minus mean 2, small minus large. See, it says where mean 1 is small. So it's, they're doing mean 1 minus, or they're doing small minus large. So we need to do small minus large here. Okay. So we have to take the difference of the small minus the large, which is going to be 5.41 minus 6.69. And once we take this difference, we're going to standardize it. So we're going to take the difference and standardize it. So this will be S1 squared, which is 1.81 squared over, and then the sample size, 28 plus, and then 2.82 squared over the sample size. And so this is what we get right here. And this will equal to the t. So take a look at what we have right here. We're writing out the formula. Y bar 1 minus y bar 2 over square root s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. And that is equal to t with a certain amount of degrees of freedom. So what else do I need to find right here? Who can tell me for 100 points what else do I need to find right now for this problem? There's one other thing I need to know for this problem, and what will it be? What else do I need to know for this problem because I'm dealing with t? Once you see we're dealing with t's, what else will we need to know? It's like, oh, we also need to know this. We also need to know the what for this because we're dealing with a t. T's come from a family of distributions. T's come from a family. Whenever you're dealing with a t, you need to go and you need to say, what are my what? Where did I put that slide? There it is. What are my degrees of freedom? Whenever you're dealing with a t, you have to ask what are the degrees of freedom. You also have to deal with the chi-squared, which we'll see tomorrow, not on the test. And the homework you can do if you want, but you should. Homework you should definitely do. The degrees of freedom, nice job, Christina. 100 points right there. So we need to go get the degrees of freedom for this. So we need both of these, the 1.81 and the 2.82. Those are decent to memorize. So let's go ahead, try to keep them in our head here. So was it 18 and 28? And it was, double check. I think I got them reversed. Yeah, I do. It was 25 and 28. So 25 and 28. Is it 28? 28 has the 1.81. Okay. So 28 has this one. And the 25 has this one. Can we hit the, yeah. Yep, we can do that one, Jack. We got it. Here's the degrees of freedom. Now I need to go to my applet. Well, what I'm going to do is I'm going to put down my degrees of freedom is basically 40. And now I solve for the t. So let's solve for the t right here. 5.41 minus 6.69. Actually, I solved for that last. 1.81 squared divided by 28 is that. 2.82 squared divided by 25 is this. Add it to the other one is this. Square root it. We've just solved the bottom of the equation. So now we go here and we go to 5.41 minus 6.69. And we divide by, and there is our t statistic. Now this kind of gives me a hint at what the p-value is going to be because that's basically 2. So the p-value is going to be very close to 0.056 or so. So this is the t statistic right here. We found the t statistic. So we're going to take this t statistic. One, we're going to tell it that it's the answer. So the t statistic for this, and it's negative because the small glass was lower. I'm going to delete down to the decimals, so it's that. We're going to take this right here and bring it over to a t-applet. And in the t-applet, we're going to put in our t statistic. We're going to put in the proper degrees of freedom that we found. So the degrees of freedom we found were this. So here's our degrees of freedom for the t. And then we're going to solve for the does not equals test. This is the does not equals. This is the less than, greater than confidence interval and does not equals test. So now we're going to solve for the p-value, and it was about what we thought. This one's a little bit more exact. It carries enough decimals. Don't like that applet a lot. Of course, I like using R. State your conclusion. Are we using a 0.05 alpha? I do not reject the null. My p-value is above alpha. The data does not provide evidence that they are different. Check your answer. Not today, my Pearson. Not today. Not today. P-value is high. Just let it fly. These do not provide evidence of a difference. Why is it a difference? Because we're testing to see if there's a difference. Because the problem asked, let us investigate if there is a difference in the size, if they change how much they have. Sports researcher, you got it. Sports researcher. A sports researcher wants to analyze. So we're going to do a statistical test right here. So once again, note that this problem is very, very similar. It has the notation given to us. So what we should be able to do is we should be able to take and pretty much just copy into here and use the same format. So we're going to take and replace the numbers that we just did and kind of substitute them in. Yep, we can do the poorly math test one. You got it. And we're just going to plug in our numbers right here. The bottom numbers are the same. I'm going to say what these are as I do them. These numbers down here are the sample size. Baseball is mean 1, and football is 2. These are not the means, they're the sample sizes, hence N1, N2. Is this analogous to a higher or lower alpha level? So if they have a higher cutoff, Neeland, if they have a higher cutoff, let me do this. So Neeland, rewind tape 2 if you're coming like mid-sentence on this. I'm gonna start now. The banks are going to, suppose the banks decide to lower the cutoff to this. And I think, are they trying to give out loans? And people need a certain rating. So they're making it easier to give out loans. And so they're making it easier to give out loans, right? And is that the null? So that, I think that would be the same as lowering their alpha. But think about this. Does the bank start out with giving loans? Banks want to give loans. I think that's what you have to assume about this question, that banks want to give loans. So the banks would reject somebody. And so if they lower this right here, it's the same as, wait a minute. So the banks, the cutoff, no, it'd be lower alpha. It's lower alpha because they're more likely to retain the null. Because think about this. I walk in with a 230 credit score. They would reject me at the 250, but they would not reject me at the 200. If you lower the, because remember, well, think about this. Here, I'll write it out really, really quick. Click here. So what they do is the null is give loan, and the alternative is do not. So the null is that they'll give the loan, and the alternative is that they'll not give the loan. So if they lower the criteria, they're more likely to fail to reject the null. And they're actually making it harder to reject the null. They're making it harder to deny loans. And what do they need to deny loans? They need evidence. So they need a low p-value. So they're lowering their alpha level with this. Does that make sense? Yeah, so they're making it harder to reject the null, and harder to reject the null means lower alpha level. So it's analogous to a lower alpha level. Good job. It's tricky. That one's tricked me. Like, all the ones that you guys get tricked on, I promise you, when I say, like, oh, that's tricked me, it really has. Really has. Yeah, and you got to look at it from, like, a null. Like, they want to they want to give out loans. Well, it's just like dimmed. It's a sign. So let's go here. If for the last one I got a p-value of probably, as long as it says like an alpha of 0.05, you would reject the null. If it says using an alpha of 0.05, you would reject the null. This is y bar 1. This is y bar 2 because it says baseball minus football. And then we have standard deviation 1 and standard deviation 2. And so that's the formula right there, and these need to be squared. Good thing I didn't forget that. And so now we also need to find our degrees of freedom. I'm going to go ahead and do that now because we can. So the degrees of freedom for this test are going to be found via the calculator. Let's pull it up right here. Go away. And then let's go to the calculator. What was it again? Got so many pages open. We'll do this. It's not going to help for long. 30 and 40.2. 4.2. 02. And then the other one is 32 and 2.78. 32 and 2.78. And then we compute the degrees of freedom, 51.2054. And then we go back to a problem. And we know our degrees of freedom. There we go. And so now that we know the degrees of freedom, we just have to solve for the t. We got this. Look at this. We got this. Let's do this. 4.02 squared divided by 30. That's this right here. We're going to copy that. 2.78 squared divided by 32. We add the two together. We get that. We square root. We take the top difference, 27.66 minus 26.18. We divide by the standard error. We get the t ratio, and there it is, 1.6755. I'm going to have a little bit of fun. So with this one right here, we know what the t statistic is. It's 1.6755, and we want to know if baseball players are older. So by seeing if baseball players are older, we're asking if the mean for baseball players is actually greater than, so the difference would be positive. And the test statistic we just found right here is this. And I should be able to guess the p-value. I should be able to. The p-value for this one's going to be about 5%. It's so close. Oh, no. So if it asks, do we reject or not reject? Oh, no. Oh, at the 0.10 alpha level. The p-value for this is so close to this, and I'll show how to get it in a second. But the p-value is so close to this because I know certain numbers. It's going to be like this. Okay, that's my guess. We definitely fail to reject the null. There is not evidence. Why do I fail to reject the null? Because my alpha is 0.05, my alpha is 0.10, and my p... Oh, wait. I reject the null. There is evidence. My alpha is not 0.05. I always go by 0.05 alpha unless told otherwise. I reject the null. There is evidence because my p-value is lower than alpha. Now, please remember I did guess my p-value here, and I got it correct. How did I know that? Because the t had a lot of degrees of freedom. Oh, it gave me the degrees of freedom? That's so nice. My Pearson. See, look, 51.20. You don't have to calculate it. It tells you it. But now you'd have to go to the applet. You'd have to put in the degrees of freedom. Then you'd have to put in the t statistic you found. Then you have to do the greater than test, because we're shading to the right of it, and calculate the p-value. And I guessed 5% at first, because I know the z-score for this. Can we do the math final question? Yeah, I think so. Is that the one you wanted to see, Josh? Let's see. Let's go take a look at that. So once again, you have to use these applets right here. Here's the applet in the chat that I'm using. Why am I graphing to the right? Because I'm doing a greater than test. And then why do I click this button right here to find the probability? Because I want to find the p-value. So that's why I'm doing that right there. The math test one. Let's see. Come on, questions. A math test. Here, I see some really easy ones. So we did this one. Spending more at store A and store B. Popcorn kernel 1, popcorn kernel. Math test. Here we go. Okay. Having done poorly on their final exams in June, 6 students repeat the course in summer. Then they take another exam in August. If we consider these students representative of all students who might attend the school, explain why you can't use these methods. So we have student A who takes it in June and student A who takes it in August. student B who takes it in June. And so, do you think that these student scores would be dependent on their, like, what do you think? I'm trying to allude to it. What is the fourth condition for our tests? The fourth condition, I've got it highlighted even. The fourth condition is that the groups are independent. So student A's score in August, standardized text one, you got it. And then, wait, is that the one we're currently doing? Maybe. So this one right here, these are before and after scores. They're not independent samples. This violates the independent groups assumption. Yep. So they're not independent groups. That does not work. We can't do that. We did hot dogs. Is it this one right here? Is this the one you're talking about, Thomas? So with this one right here, it wants us. Yep. Okay, so how are we going to find the margin of error? How can we find the margin of error? How can we get the margin of error of this interval? How would we get the margin of error? How can we find the margin of error of that interval? What should we do to find the margin of error? We've got a cheat sheet up. Yep, you got it. Alyssa, amazing work, Alyssa. Coming to the rescue right there. 50 points, Alyssa. Great job. We're going to take the upper minus the lower divided by 2. Great work. There's the margin of error. We got it. Margin of error solved. And then we have to think, if we go from a 95 to a 90, 95 to 90, what would that do to an interval if we go from 95 to 90? 95 to 90 would make the interval what? The margin of error is going to be what if we go from 95 to 90? The margin of error will be whatter. If we go from 95 to 90, the margin of error will be thiser. Going from a 95 to a 90, the margin of error would be 95, 90. Oh, wait, 95 to 90. 95, 90. So remember, 68, 95, 99.7. So if you go from 95 to 90, it's going to be smaller because the critical value decreases and the margin of error decreases as the critical value decreases. So explain what this means. I am 95% confident that the true difference between the non-traditional students and the traditional students, can't speak today, is contained in the interval 4.874 to 10.726, and we think that the non-traditional might be higher. Now, please note that this says students, which it should. So we want to do students here, and we're going to say that the non-traditional are higher than the other ones because the interval is positive. That's because if it's positive, the first number was bigger. If it's negative, the second number was bigger. So I'm 95% confident students in non-traditional math courses are expected to score between this many points to this many points higher. That is correct right there. You got it. That the true. But then remember, only for quantitative, Alyssa, that is correct. Great job, Alyssa, right there. That's for quantitative. I'm 95% confident the true mean, and then make sure to say what it is, the true mean of scores for these students. Did they say mean right here? They say students, which is considered means. I wish they said means. The true difference between the means of, yeah. Does this result suggest a difference? What do you notice is not in the... Yeah, no, great job, Alyssa. Another 50 points. You're doing excellent review. I am blank percent confident that the true blank is contained in the interval blank to blank. Does this interval suggest a difference to you? Yes or no? I would say it does. Because... Yes, because 0 is not contained in the interval. The entire interval above 0... Thus, there's evidence of a strong difference. And I think, not today, my Pearson. Not today. Not today. Never today. Never again. I think we did the serial question. Is this one really short? We got this one. State the null and alternative hypothesis here. So they want to see researchers collected samples of water. They measured the pH level. What do they want to test? Do you want to test to see if there's a difference? Researchers collected, they measured a lower, the plot of the right shows it. It never gives preference of a difference. So unless I'm going crazy right here, it's going to be not equals. Oh, well, that's obvious. So, yep. Oh, wait, did you see, Jose, rewind the tape? We just did that one. Check it out, Jose. It was like maybe 10 minutes ago, Jose. So check it out. If you don't see it, I'll redo it again. I was so confused on what the answer to this would be, but I should have just looked at the possibilities. Why is this the only answer I can choose? Why is answer D the only possible answer? And they didn't really give a preference, so I was leaning towards it. But then, oh, that's good. Awesome job, Jose. Awesome job. And I'll probably go for another 10, 15 minutes. I might do more later, like after the Kahoot, because I'm going to eat some lunch. I'm getting really hungry. So that lemonade's only keeping me going so long. So an excellent work on those points. Why is this the only answer to choose? You should be like, oh, that's the only possible answer because the null has the equal sign. So since the null has the equal sign, that's the only possible answer. These are they nearly normal, my Pearson? You're going to say they are, but are they? My Pearson did not do a thorough enough investigation. And then watch this be like, no, you didn't know that they're nearly normal. I'm like, yeah, well, independent groups means that the L and M and S, all those groups are independent of each other. We're only testing 2 of them, though. Independence assumption is basically randomness. What conclusion do you draw? The p-value is lower than this, so we reject the null. There is evidence because the p-value here is ridiculous. The t-statistic is also very, very high, so we reject the null. The only thing I don't like is this nearly normal. Really, I'm supposed to figure out from this. That's not a good way to check nearly normal. You should have a QQ plot. You should look at the histogram. You should use the large enough n condition, but we got it. Not today, my Pearson. Even when you try to like not do the nearly normal really well. When someone wrote this question, didn't understand what the nearly normal is completely. Tisk, tisk, tisk. I think I might head off here. Suppose an experiment was done to gather data on the number of unpopped kernels or microwave popcorn. Half of the students in your class took a bag home, put it in the freezer overnight, and popped it the next day. The other half took the bag, left it in their kitchen overnight, and popped it the next day. Each group counted the number of unpopped kernels. Could you use the methods within this chapter? Yes. Because you're just testing to see the amount of unpopped kernels in the popcorn bags that are left on the kitchen counter versus the amount of popcorn kernels that are on average unpopped left in the freezer or something. So we should be able to do it. Yep, we can use our methods. Suppose an experiment was done to gather unpopped kernels. Half of your students took the bag at home, put it in the freezer overnight. Half popped it the next day. The other bag, popped it. Each group counted the number of unpopped kernels. What is the appropriate null? What is the appropriate alternative hypothesis to test whether the freezer method left fewer? So now we're between A and B. That the freezer had less on average. And wow, my Pearson, your book does not say this. You got to update the person who wrote the problem. Got to be consistent. So you might say, I've never seen that X bar before. Same as Y bar. It just means mean of variable, whatever. And so we use the true mean, though, and that's right. It's a little process of elimination. Look at this. Also, we just did that one. I think we got to do it. We'll have completed every problem. If we do this, we will have completed every problem. And I might just speed run the last few to do it. Okay, so I'm going to explain this problem right here. I'm probably going to go eat some lunch, and we'll come back and we'll do some more work. But we'll do this problem right here. We got it. This problem right here is very much like the football problem or the... I can't remember what the other problem was called. I don't know if that's the answer. That's not the answer. Maybe that's the answer. That's probably the answer. We'll find out. These problems are very similar to this one right here. So we're just going to put the numbers in, and we're going to start plugging in the numbers to our equation below. Once again, just so you can see, I'm going to write this out down below. I just want to make sure you know what the notation is to solve for t, and this is not the same as the t used in a conf roll. The notation right here is y bar 1 minus y bar 2, s squared 1, s sub 1 squared over n1, s sub 2 squared over n sub 2. And so those are the numbers we need to input. Let's go ahead and put in our sample mean 1. It looks like we're going to use store A as the sample mean 1. Are we? Let's check before we do our work. It is store A first. Store A minus store B. That's the difference we're going to consider. And so right here, we're going to put the mean for this group, 42, 53. And so I'm going to write my 5 like this. There we go. And now we go sample size 1 right there. Sample size 2 right here. Standard deviation 1 right here. Standard deviation 2 right here. Got it. Cool. Let's solve for that t. I'm going to solve for t first this time because why not? So we go 21 times 21 divided by 84 is that. 18 times 18 is this, divided by 80. Let's not make an error. Plus the other one is that. Square root is 3 something. That is now the bottom of the equation. 42 minus 53 is this, and there's the 3.6. We have now found the t statistic, which is the standardized difference of how far these are away. So that's a standardized metric, which that's kind of large. That's a decently large t. But we also need to find the degrees of freedom, which we're going to find via the applet. So the degrees of freedom, we need to know what t we are using, because t's come from a family of distributions, all with different degrees of freedom. So we're going to go over here to our t applet. We're going to have to put the numbers on the screen. It was like 42 and something. What were those numbers? 40, 84, and 80. 84 and 80. I think that's right. 160. Cool. These are the degrees of freedom. Now we go to the applet. Degrees of freedom. Go to our t. T. And now we have to know the test. So we have to know the test we're doing. The test I thought would be a two-tailed test. And so the probability is this. I now know if it's a one-tailed test. If it's a one-tailed test, it's probably going to want the less than test, which will have a probability of 1/2 of this. So the less than test has a probability of 1/2. So I don't like these visual applets sometimes, or the way this one looks. Let me show you on statdistributions.com, because it's just this one's more exact. The degrees of freedom were about 160. And then we want the less than test. And you see this won't carry out enough decimals. That's the problem with this one. So the t was something like, is it negative 3.6? It was that. And you see it's saying a p-value of 1. If we do the two-tailed, why is my brain breaking? The two-tailed. T-value of 3.6. Oh, I can't even think today. Wow. Whoa. Brain is slowing down. So once again, I'm using this applet right here to get my p-value down to 4 decimals. We'll see how many decimals it wanted, and we'll see what way it wanted the test. Let me make sure chat hasn't said anything. I had chat pulled down for the moment here. Okay, good. So data collected. We want to know, suppose researchers are interested in this question collected from by asking customers for their purchase amounts. Suppose the researchers decide, it doesn't say anything about whether store A or store B is higher. Do customers spend more on a trip to store A or store B? Okay, it's the two-sided test. It never gives a preference to store A or store B being higher. It just says, do customers spend more at store A or store B? The test statistic right here was what we calculated here. The p-value is going to be to 3 decimals. Really? If it wants 3 decimals, then that's going to be it. Not 4. And then we definitely reject the null. There's evidence. We reject the null. There is sufficient evidence to say that the two means are not equal. Not today, my Pearson. Not today. You know what, my Pearson? We're doing them all. We're getting this done. Because right here we have an interval for the meat minus the beef. The interval contains 0, so we cannot tell if there's a difference. We cannot determine which one is higher. There we go. What does the fact that the interval contains 0 means? It means that 0 could be the difference. The difference in the two is insignificant. And this interval was created a 96%, so that's 4% alpha level for the two-tailed test. Remember, confidence intervals and tests are basically the same thing, and we can figure out the alpha level for a two-tailed test by doing 1 minus the confidence level. We're going to copy this data to the clipboard. We're going to bring it over here to jump, and we're just going to open a new sheet. We're going to paste it in. We're going to go to tables and stack, if my eyes will stop blurring. Then we'll go here, and then we'll do this. We'll go to analyze, fit y by x. This is done slower earlier in the video. If you go back to the homework section of this, this is done slower. There's the interval. We got it. Problem solved. Not today, my Pearson. Not today. The interval goes from 31.5 to 41.2, but it's going to round that. So 31.5 to 41.21, I think it rounds to. And this is our revenge on my Pearson, because this is the one thing we made a small error on the homework. On this one, we said, based on the 95% confidence intervals, children's cereals contain, on average, this much more grams than adults. So children's cereals contain about this much more. Please watch the start of the video for a much longer version of this problem. What did I do? Adult cereals contain. It is. What did I do? I mistype a number. Is it 95% confident? Oh my gosh. Where did I mistype? Not today, my Pearson. Not today. Sorry, guys. Need lunch. Can't punch numbers in. I can punch it. That's why I just punch it in, and then it doesn't. I can't copy numbers. I can do stats. I just can't copy numbers when it tells me the answers. So make sure to get your numbers correct. If you make an error like that, please tell me. I just did that to show if you make an error, please tell me. I'm going to... Neeland, are you still here? I don't know, Neeland. Are you still working Chapter 16? I might do that after the Kahoot. After the Kahoot. Who is still here? Is anybody still here? Do the project, do the homeworks, do the quizzes, prepare for the test. It's the end of the semester. You guys got it. You're doing great. You're working hard. I'm going to head off here in a second. But we now have completed the whole thing. Aside from one error, we did it. We got it done. All quiz questions done. That's got it. And I will see everybody at 4 p.m. Bye for now. Bye.